Hello everyone and welcome to this session on Tableau full course. Tableau is a powerful and fastest growing data visualization tool used in the business intelligence industry. It helps in simplifying raw data in a very easily understandable format. Tableau helps create the data that can be understood by professionals at any level in an organization. It also allows non technical users to create customized dashboards. In this session, you will learn Tableau from scratch. So let's see the agenda for the session. First, we'll be learning about what is data visualization. Then, we'll be learning about some benefits of data visualization. After that, we'll be talking about what is visual analytics. Then we'll be talking about what is data analytics. After that, we'll be discussing more about what is Tableau. And then we'll be followed by power of Tableau. After that, we'll be doing some differences between Tableau and some other vendors. And then we'll be doing a hands-on on installing Tableau. After that, we'll be doing an overview of Tableau products. And then we'll be switching to Tableau Dashboard. After that, we'll be doing a hands-on on how to load a sample data in Tableau. And then we'll be covering charts and graphs in Tableau. After that, we'll be discussing about Tableau career roadmap. And finally, we'll be covering Tableau interview questions. So that's all with the agenda. Let's start the session. But before we begin the session, make sure to subscribe to our channel and press the bell icon so that you'll never miss any update from us.
Data visualization, right? You have tabular data, which is converted into graphical representation using Tableau. You can do this within a fly. And why should we do that? So from this kind of a data, which is in a tabular format, it's going to be really difficult to pick up some information that you are specifically looking for. But using Tableau, drag and drop the fields in your software as an inside your workspace, and within a fly you'll get your chart. You can decide any chart that is going to be used for visualizing your data. Let it be a pie chart, let it be a bar chart, tree map, the world map, country map, area chart, anything. You have 24 such readily available charts and graphs. Definitely, you have a lot of benefits when it comes to data visualization. It is going to help you make decisions faster, take decisions accurately and in a better manner, okay, in a quicker manner, so that you can start improvising the performance of your organization. See, now you might have a query. We do have great scope for Tableau developers, okay? How is that possible? We do have, extremely great scope, and you have a lot of openings for Tableau developers. Why? Because now what is Tableau used for? Tableau is used for analyzing your data. Okay, so wherever you have data, we might need Tableau to analyze the data. Why do we analyze data? We try to find out the most important aspects of our organization. Let's say, for example, which product is having the highest sales, or might be which product is having the least sales. How do we improvise the sales of that product? Or let's cut down the production of that product because it's not, moving well in the market. So such analysis can be done when you connect your data with Tableau. That's the reason we analyze the data, to understand the performance of our organization. Okay, so when you know what's the current status of your organization by analyzing the data, you can take necessary steps as in how to improvise the sales or profit value in future. Yes, so analyzing the data is very important to understand how well you can improvise the performance of your organization. So wherever you have data, data has to be analyzed, and we have data everywhere. Right? Let it be a pharmaceutical sector, let it be an IT sector, a school, a hospital, a simple store, automobile sector, right? To maintain their stocks, to track their sales, profits, discounts, quantities sold, right? Quantity produced, might be expiry date products, all such, whichever industry you get into, whichever domain you get into, you have data that has to be managed, analyzed, for improvising the performance. Yes, so that is the reason why we have great scope for Tableau developers. Let it be any domain, you do have data which has to be analyzed and for which we will be in need of Tableau software, right? Now you might have another query. See, Tableau is not the only data visualization tool available in the market, right? We also have, these are some of the basic points that are right now flashed on the slides. Okay, see, now apart from Tableau, yes, it is one of the most important data visualization tools. But apart from that, we do have similar tools or competitors of Tableau, like Power BI. We have Microsoft Power BI, we have ClickSense, we have Zoho Analytics, we even have Alteryx, right? So we have a lot of tools available in the market, which can also be used for visualizing the data. But comparatively, Tableau has a few important points in hand, which is justifying why Tableau is standing right on top compared to all the other tools. Okay, now suppose if you had been working with Power BI already, then you'll have an idea. See, Power BI is also a data visualization tool, but the user interface of Power BI is definitely very clumsy when compared to Tableau. The processing speed with which you work in Tableau is much better compared to Power BI. Though the purpose of these tools are just, the same. Both these tools are helping you visualize your data, but the performance, the processing speed, the user interface is extremely well organized in Tableau. So as a beginner, okay, who's newly getting into who's starting to learn a BI tool, Tableau is a great start. Okay, it's going to be well organized right from the user interface perspective, right from the way you are love to work with Tableau. It's going to be very easy. Okay, it's a very easy to learn and easy to understand tool. So definitely it's a great start, right? So again, you have some basic points why you go ahead with data visualization. Okay, it leads to better understanding. You can take your business decisions accurately and quickly. Okay, and some real-time scenarios, as I told you, in a hospital, in a school, pharma domain, retail domain, bank sectors, wherever you have data, you have to analyze your data, for which Tableau is required. Okay, now this is just a visual example of how a dashboard created using Tableau looks like. Okay, see, now we might come across a lot of new terms, related to Tableau: dashboard, worksheets, legends, filters, and so on. Right? So you needn't make any effort to remember these terms, because I'll be repeating them again and again throughout our course. We'll be using them multiple times in every single session. So gradually you'll get familiar with them. Okay, so as of today, it might sound new, but as we go on, without knowing, you'll get familiar with them. Okay, so dashboard is nothing but a collection of worksheets. Worksheet is nothing but a chart, right? So when you place multiple charts in a single space, we call that as a dashboard. Or might be something like a notice board where you have different, circulars placed in a single space, something like that, right? You have multiple worksheets placed in a single space, and that is what is known as a dashboard, right? So here we have a pie chart, here we have some stacked bar chart. Okay, so different charts which is visualizing, multiple columns or multiple factors of your data is placed in a single space, and this is what a dashboard is all about. So by the end of our course, you will be able to create such dashboards. Now you can customize everything from the scratch, right from the chart you choose, the colors you choose, the background you choose, the way of labeling your charts, everything, every minute aspect of your dashboard can be customized and decided based on your requirement. Okay, right? Now getting into the different products offered by the Tableau software company, right? And after which we'll, I'll also walk you through a real-time working dashboard, just to give you an idea. See, this is how the final product looks like. Once you have an idea about what can be created with Tableau, it'll be even more interesting to start working from the scratch. Okay, I'll give you an idea how the end product looks like so that you will have a clear picture. So this is what we are moving towards. Okay, so yeah, again, a few basic points. Tableau is an interactive BI tool. BI stands for Business Intelligence. It was founded by an American software company in Jan 2003, almost 2 decades, okay, approximately. Yes, so that was when Tableau was, developed. Okay, and yeah, these are some of the points where Tableau is justifying that it is, the reason why it is standing on top. Tableau is an easy to learn, easy to use tool with the drag and drop technology. Okay, and the most important point is over here. Tableau stores, the second point, Tableau stores data in the random access memory of your system. Okay, therefore the processing speed is much faster than those that store data in disks. Now, when you look into the other BI tools, they store the data. Tableau or any such BI tool is not capable of storing the data within itself. There's no storage capacity available within the software, right? So the other BI tools store data within the disks, okay? But when it comes to Tableau, it directly stores data in the RAM or random access memory of your system, because of which you'll have a better processing speed. Processing speed is nothing but the speed with which you work in Tableau, okay? Right? So that is much better in Tableau when compared to the other BI tools, right? And the power of Tableau, as you all know, it's easy to share. You can share your dashboards with people in your organization so that even they can look into your charts and analyze data according to their requirement. Yes, and this is where, see, Tableau and other vendors, though we have so many other tools available in the market, we have Tableau, which is standing right on top compared to the other BI tools. Okay, though Microsoft Power BI is quite close to it, but still Tableau is on top. Tableau, in fact, has been awarded as the best BI tool, the best data visualization tool by Gartner Magic Quadrant for Business Intelligence and Analytic Platforms for the 8th consecutive year. Now, this was as per the report submitted last year. Okay, so as in for the 8 consecutive years, Tableau has been receiving this award, right? So before we get into, okay, so I've been talking for a long time. Any queries from your side, please do let me know. Might be any suggestions or might be some feedbacks, whatever you have in mind, just feel free to talk. Okay, just pour in your suggestions, your queries, and we'll answer them then and there after each and every topic. Okay. Right. So I'll just continue. If you have any queries, just keep sending them through the chat box. Okay. Okay, great. Yes. Now, before we get into the ways of downloading and installing the software, I'll give you an idea of what are the products offered by the Tableau software company, out of which is the most important one we are going to focus throughout our course, right? So we have, so on the whole, now one suggestion is when you're sending in queries, you can send it to everyone so that if there's anyone else having the same query in mind, it'll help them to get that clarified. Okay. Yes. Now it is definitely not necessary or compulsory to learn all the BI tools to get the job. Okay. They are quite close to each other. Now, for example, after a month, once you're perfectly fine with Tableau, once you get familiar with Tableau, when you look into the workspace of Power BI, 95% of the features, in fact, I would say 98%, the terms used will absolutely be the same. So once you get to know one BI tool, it would be very easy to work with the other BI tools as well. Might be you'll take a couple of days, to explore the environment. For example, the feature of filters, let's say it's available on the right side in Tableau. Might be it's available on the left side of the workspace in Power BI. That would be the only difference. But most of the features, see, 95 to 98% of the features, the way you work is absolutely the same between the BI tools. Okay, so there wouldn't be much difference at all. So once you get to know one BI tool, you can definitely add the other BI tools also in your skills within the resume. All you have to do is make sure you just look into the workspace. Might be if you're interested in Power BI after finishing Tableau, look into the workspace of Power BI. You'll have an idea how closely they are related to each other. So it's definitely not compulsory to learn all the BI tools. Okay. And how many people can work on a single data? Now, see, Tableau is just a mirror which is reflecting your data. Okay, I'll give you an example for that. So there's no count. Any number of people can work on the data. Okay, you're just using the data and converting it into visualization, right? You're not directly working on the data. You're using the data, you're connecting the data with Tableau and converting it into graphical representations. We are not going to make changes to the data as such. Right now, I have a very good real-time example for that. Okay, to explain the connection between your data and Tableau software. It will be very easy for understanding. Okay, I'll definitely get back to that point. And there's another query: do we have to know all the Tableau products? Definitely not. See, we have Tableau developers. So as a Tableau developer, we should know in and out about Tableau Desktop, because using Tableau Desktop, we are going to develop the dashboards. Whereas we have Tableau admins. Tableau admins are the ones who will be working on Tableau server. Okay, now I'll tell you. On the whole, we have 6 products offered by the Tableau software company, right? Tableau Desktop, Tableau Server, Tableau Reader, Tableau Public, Tableau Online, and Tableau Prep. Now, I'm just trying to give you a basic introduction and overview of what each product does, okay? So that, in future, the term called might be Tableau Online. You shouldn't be confused as in what is Tableau Online all about. Though I'm working with Tableau, though I'm into a course of Tableau, I mean, I have no idea what Tableau Online is all about. That shouldn't be the case, right? So I'm just trying to give you an idea of what each product does, an overview of each of these products. And out of these, our course is going to focus on 2 of the major ones. Okay, so I'll tell you. Now, out of the 6 products that we have right here, I am going to categorize them into 3 separate headers. Okay, let's start with the developer tools or products, however you call it. We have sharing tools, and then we have the ETL tools. Okay, now see, as the name tells you, developer tools are used for developing or creating a dashboard, creating a visualization. Okay, such tools which are used for creating or developing a dashboard fall under developer tools, right? Now, once you've developed your dashboard, you will have to showcase it. You'll have to share it with people in your organization, or might be you'll have to share it with your client. Only then they'll be able to use your dashboard and analyze data as per their requirement. So sharing whatever you've developed is equally important, right? So the tools or the products which are meant for sharing purpose fall under the sharing tools. So as a developer, once you're ready, once you've developed your dashboard, you'll have to, put it into one space from where everyone will get into the sharing tool, use your dashboard for further analysis. Again, the same, notice board example that I give you. There's no point in, typing some circular and keeping it for yourself. You'll have to place it on the notice board so that anyone who might be, going through that, getting into that room or going through that passage will look into the notice board and understand what the circular is about. So you're sharing the information, right? Similarly, developing a dashboard is not enough. You'll have to share it with your client or people in your organization so that they'll have an idea. They look into your dashboard. Okay, so this is how data has been analyzed. They'll try to understand the performance of their organization with your dashboard. So that is where sharing tools come into act. Okay, and ETL tools. Now, ETL actually stands for extract, transform, load, right? So you extract your data, you make modifications or transformations, and then you load your data. So basically, ETL is nothing but a cleansing tool. Now, suppose you have a lot of, let's say cleansing work that needs to be done in your data. You have a lot of null values, you have some columns that are to be renamed, you might have, let's say, empty rows, empty columns, some issues, some basic cleansing work that needs to be done on your data. Okay, so that is when you can use these ETL tools. Again, we have ETL tools in the market like Informatica and Alteryx. Okay, but we have some ETL tools offered by the Tableau software company itself. So we'll definitely look into those, right? Once you have an idea what are the different products offered by the Tableau software company, right after this, we'll be getting into the installation part. So page 18 is something that we'll be coming back. Okay, 16 is nothing but, see, these are some of the examples of, how dashboards can be created using Tableau, how Tableau as an employee, how you can stand apart if you are aware of Tableau, some picturestic, representations of how good or what's the power of Tableau, basically, as the header tells you, right? You can share information easily. You can, pull data from multiple locations and create one single dashboard for analysis purpose, right? Some of the points that can be done using Tableau. And 17, this is where I told you, you have multiple products offered by the Tableau software. I mean, ETL is extract, transform, load. Yes. Yeah. So this place is where you have different BI tools available in the market, out of which Tableau, the most important BI tool, the reason why it is standing right on top, it has been awarded as the best BI tool for the 8th consecutive year by Gartner Magic Quadrant for Business Intelligence and Analytic Platforms. Why Tableau is standing right on top? We did go through a few points that justified it, right? Tableau is an easy to learn, easy to use tool. It has a, cleaner and an organized UI, user interface. It stores data in the random access memory. It has a better processing speed. These are some of the points why Tableau is standing right on top. Okay, that's about 16, 17, 18. We'll come back once we are done with these products. Okay, so going back to the products offered by the Tableau software company. So as I started with, we have the developer tools, the tools which are used for developing purpose. So the most important and the exclusive product meant for developing dashboards is Tableau Desktop. Okay, so if you're planning to become a Tableau developer, you will definitely have to know in and out about Tableau Desktop, because this would be the main tool you'll be working with once you get into an organization. So it's exclusively meant just for development purpose. Okay, apart from Tableau Desktop, though this is the main tool for developing dashboards, we also have another tool called Tableau Public. Okay, now Tableau Public can also be used for developing your dashboards. Okay, and this is in fact the only tool which can be used for developing dashboards as well as for sharing the dashboards, okay, with the entire public, as the name tells you, right? Now you might have a query when we have one single product, as in we have Tableau Public, which is taking care of the development part as well as the sharing part. What's the purpose in having all the other tools, right? See, now when you look into the first header, first category, developer tools, though Tableau Public can be used for development purpose, but compared to Tableau Desktop, you will have a few limitations in Tableau Public, right? Now we exactly have 4 limitations in Tableau Public when compared to Tableau Desktop. Okay, but still, just for practice purpose, might be during our sessions, if you want the software for practice purpose, Tableau Public can definitely be used, because Tableau Desktop is a paid software. It's not available for free. Tableau Public is a freeware, right? So I'll tell you what are the limitations in Tableau Public. 98% both are absolutely the same. Look wise, concept wise, everything is just the same, except for 4 limitations. That is, I was in 4 points or 4 features which are not available in Tableau Public, right? So Tableau Desktop is the exclusive product used in a real-time scenario, but for practice purpose, you can use Tableau Public also to develop dashboards, which is having 4 limitations when compared to Tableau Desktop. So these are the tools used for developing or creating dashboards. Okay. Now, once your dashboard has been created, you'll have to share it with your client, or might be with the public, or might be with people in your organization, right? That is when sharing tools come into act. So we have Tableau Public, which is a sharing tool. We have Tableau Server, and we also have Tableau Online. Now, again, you might have a query. See, Tableau Public, when it is serving as a sharing tool, what's the purpose of having Tableau Server and Online? What are the differences between them? In what way they differ from each other? How will I know which sharing tool to make use of? Okay, see, Tableau Public, as the name tells you, it's Tableau Public. You can use this as a sharing tool to share your dashboard with everyone in the public. See, suppose I'm creating a dashboard based on COVID data, or might be if I'm creating a dashboard with some weather related data. So in such cases, I'm working with public data. So there's nothing wrong in sharing the dashboard with the entire public. So if there's someone who's planning to see how the weather looks for the next month, or might be how the weather or how the COVID data has been since the last 1 year. So such analysis on public data, okay, can be done with your dashboard that has been created on public data. Suppose you're creating some data, some dashboard on public related data, you can very well share it with the entire public using this as a sharing tool. But see, that's not the scenario in all the cases. That's not how, or that's not our requirement in all the cases. Now, I might be working, let's say, in a bank where we have the bank customer data, their bank balances, their transaction details, and so on. Now, a dashboard that has been created for such a confidential bank customer data, will I be able to share it with the entire public? Not at all, because it's not only the bank customer data which has to be kept confidential, the corresponding dashboard is also to be kept confidential, right? Not everyone from the public will be allowed to view or use the dashboard. There's no security protocol at all when it comes to Tableau Public. Anyone can view, use your dashboard for their analysis, right? So when it comes to an organization, we definitely don't prefer Tableau Public, because our data, the organization's data, has to be kept secure, confidential, and all that, right? So that is when we choose Tableau Server or Tableau Online. Okay, now Tableau Server is used for on-premises deployments, whereas Tableau Online is used for cloud-based deployment. So Tableau Online is a cloud which is maintained and managed by the Tableau software company themselves. You can create an account of Tableau Online, get a space for your organization in the cloud of Tableau, share your dashboards, or literally store your dashboards in Tableau Online, which is acting as a sharing tool. Okay, now Tableau Server and Tableau Online, they have extremely high security protocols. Not anyone from the public will be able to view and use your dashboard. Only people working in your organization will be given specific credentials to get into the server or online account, using which they can access, view, and use your dashboard. Right? See, suppose you're working in an organization and the organization is having its own Tableau server account. So you will be given a set of credentials, login ID and password. Using those credentials, you will have to get into the Tableau server account and publish your dashboard or use the dashboards that are already published over there. So because of extremely high security protocols, every organization will either use Tableau server or Tableau online as their sharing tools. Okay, what do we mean by premises? So on premises, in a sense, see, normally what happens, you'll have one main server system in your organization, which is controlling all the systems, all the other systems in your organization, right? So for such, for such an environment within the premises, within your organization, you have one main server system controlling the others. That is what is Tableau server about. That is where you can create a main Tableau server account and let all your employees, share your dashboard using that Tableau server account. But if you go ahead with Tableau online, Tableau Online is a space, is a cloud, which is maintained by the Tableau software company themselves. So it's something like renting a space in their cloud. We rent a space, we create an account in their cloud. That's the Tableau Online account that you create and use it as a space where you share your dashboards among people in your organization.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Right? So on the whole, both are used for security. Both are used for sharing dashboards. Both have extremely high security protocols, but the only difference between them is this is a cloud-based sharing tool, whereas this is a on-premises based sharing tool, right? And then we did have Tableau Reader also, which was one of the sharing tools, but nowadays we do not use Tableau Reader to a greater extent. This was the only tool used in the earlier days by content creators or developers. This was the only sharing tool available in the earlier days, but nowadays we don't get into Tableau Reader as such. Okay, and finally, so out of 6, we have desktop and public used for development purpose. Okay, for sharing purpose, again, Tableau public is used to share the dashboard with the entire public. Tableau server, Tableau reader, Tableau online, all are sharing tools. And finally, we have Tableau prep. Okay, so Tableau prep is the ETL tool offered by the Tableau software company. We also call it as the preparation tool of Tableau, cleansing tool of Tableau. Okay, now if you've already worked with a few ETL tools like say Informatica or Alltricks, okay, Tableau prep is in nowhere close to these. Okay, they are the major ETL tools available in the market. Tableau prep is not even 50% of them. Okay, Tableau prep is one of the basic ETL tools, okay, using which you can just filter some empty rows or columns, might be filter null values, or might be create a simple join or a union between tables. Basic cleansing work is what can be done using Tableau prep. Tableau prep is definitely not up to the mark, okay, when compared to the other BI tools, but still, just for namesake, they do have an ETL tool offered by themselves, as in Tableau software company itself has its own ETL tool. So for that reason, they have Tableau prep, but comparatively, Tableau prep is not up to the mark. It is very basic when considered in terms of ETL work. ETL is nothing but extract. Extract is you extract your data, or might be you collect your data from different locations. You apply transformations. Transformation is nothing but you apply modifications, right? You make modifications on the data and then you finally load your data. Load is nothing but you get your output. So I'm sending my data, you can just imagine, I'm sending my data into a machine, okay? It's cleaning my data and I get a cleansed data as an output. That is what an ETL tool does. So after cleansing your data, you can connect it with might be Tableau Desktop or Public for visualization purpose. But I would tell you one thing, see, it's definitely not mandatory to use an ETL tool before working with Tableau Desktop. It's all up to you. It all depends on your data. If you want, you can go ahead with an ETL work, but it's definitely not compulsory or mandatory. Okay. So these are the different products offered by the Tableau software company. And out of all these, our course is all about Tableau Desktop. So we will be focusing on, in our upcoming sessions throughout our course, we'll be focusing only on the developer tools. We'll go ahead with Tableau Desktop and Tableau Public, everything, Tableau Public as a developer tool, right? So we'll be going through everything in and out about Tableau Desktop and Tableau Public as a developer tool. And might be in our last class, I'll tell you how to publish it, how to share it once your development work is over, how to share it into these sharing tools, right? So our course is completely going to focus only on the developer tools. Now, if suppose you've enrolled, we have a different course for Tableau Server, which will again go on for 26 to 30 hours. Okay, so if you had already enrolled for a course of Tableau Server, once we are done with this course of Tableau Desktop, okay, you'll be allotted another batch with a different trainer who will be handling Tableau Server, which will again go on for a month or even more than that, right? So in our course, we'll only be focusing on Tableau Desktop and Tableau Public, but I'm sure you'll have some basic idea of what are the other products, what's the purpose of having the other products, just a basic overview of what are the other products offered by the Tableau software company. Okay, right. So a few queries before we get into the installation part, downloading and installation part. Okay, so two products, Tableau Reader and Tableau CRM. Could you please categorize them too? I think Tableau Prep. Yes, Tableau Prep is an ETL tool. Tableau Reader, as I told you, it's a read-only tool. Now, for example, you're developing a dashboard, okay? You want people to look into your dashboard so that they can analyze and understand the data. That's the whole point why we build the dashboard, right? The purpose why we create charts, why we create dashboards as Tableau developers is for our clients or higher officials to use our dashboard and understand the data, analyze the data easily. That's the reason we build a dashboard. Okay, so for such a sharing purpose, Tableau Reader used to be the only tool in the earlier days, using which dashboards were shared by developers, right? But nowadays we have better and advanced sharing tools with extremely high security protocols like Tableau Server and Tableau Online. So we don't use Tableau Server on a wider range, right? And there are a few Tableau certifications available. Yes, now we have 3 levels of Tableau certifications available, right? We have Tableau Specialist, we have Tableau Associate. I think the order, it's basically 3 levels: Specialist, Associate, and Professional. Okay, so all the 3 levels of Tableau Desktop certification, Specialist, Associate, and Professional. Professional is the advanced level, right? So all the 3 levels will have questions related to Tableau Desktop and Tableau Public as a developer tool. So by the end of our course, if you're regularly practicing, you will definitely be able to clear all the 3 levels, because all the 3 levels, as I told you, will have questions related to Tableau Desktop only, but the only difference between them is the level of complexity, right? So it might be the basic 2 levels. The first 2 levels as Specialist and Associate will try to focus on, okay, That was all about the products offered by the Tableau software company. Now, I am sure in future, if you come across what is Tableau Server all about, what is Tableau Public all about, you'll be able to have some basic idea about it, right? So now, as I told you, we have we have the jobs termed as Tableau developers and Tableau admins. Okay, so developers are the ones who will be working with Tableau Desktop to develop a dashboard, and Tableau admins are the ones who will take care or manage the sharing tools. Okay, so as a developer, my job is over once I've developed and published my dashboard into the sharing tool. I've sent my dashboards, I've published my dashboards into the sharing tool. Okay, now maintaining the published dashboard, that is what a Tableau admin does. Now you might have a query, what is maintenance, what is maintaining a dashboard all about? What are the key points or roles of a Tableau admin, right? See, once you've published your dashboard into the sharing tool, the Tableau admin should take care that not everyone who is viewing the dashboard should have the access to edit it, right? Because they'll not have an idea of how you've built the dashboard. So not everyone should have the access to edit your dashboard. That user role, assigning user roles is what is to be taken care by Tableau admins. Okay, giving access to users might be, we might have the sales department and we might have the, let's say, production department in an organization. I don't want the sales dashboard to be accessed by the production department people, right? So accordingly, the Tableau admin will give access to specific users. Okay, so that is taken care by Tableau admin. And you might have your data which is getting updated often, right? So as your data is getting updated, your dashboard should also be updated, right? So that is what is Tableau admin taking care of. So you have a lot of maintenance roles when it comes to Tableau admin jobs, right? So this is basically the difference between a Tableau developer and a Tableau admin. Okay, so yeah, that's about developers use the developer tools, especially Tableau Desktop, whereas admins, their work is completely on Tableau Server and Tableau Online. Okay, now once you are aware of all the tools, now let's focus on Tableau Desktop and Tableau Public. Let's get into the options available to download and install Tableau Desktop and Tableau Public, right? Now let's get into the different ways or options available to download and install both Tableau Desktop and Tableau Public. Okay, I'll just get into Google. And first of all, let's start with Tableau Desktop. Okay, so we have 4 options or 4 ways to download and install Tableau Desktop, right? Now I'll start with download Tableau Desktop and get into the link that we have. Okay, that's directing you to tableau.com. So this is the first option. Okay, starting with your 14-day free trial, using which you can keep using Tableau Desktop for free for the next 14 days, after which it would expire, as in the trial version would expire, and you won't be able to continue using Tableau Desktop. As in, you might want to try with a different email ID after 14 days, but Tableau is not going to let you do that because it copies your mission number in the sense, in a particular desktop or laptop, you can download the 14-day free trial only once, right? Once it expires, it keeps the track of your mission number. And even if you use a different email ID, it is not going to let you download the free trial again on the same desktop or laptop, right? So anyways, I'm sure everyone will be able to proceed with this, starting your 14-day free trial. This is the first option, okay? Now the next option, if you're already working in an organization where Tableau is in use, okay? You can just let the concerned person know, the person in charge, you can just let them know that you are in need of the product license activation key. In short, you can call it as the product key. Okay, this product key is a 20-digit alphanumeric kind of a code, okay, using which you can activate even the expired product after 14 days of expiry. It'll ask you activate the product, or even before starting your 14-day free trial, you can right away use the product key and activate your product using the product key that you've received from your organization. They will have the license key for activation. Okay, you can get this from your organization. The third option that we have is you'll have to pay a specific tariff. Might pay something around $60 to $70 on a monthly basis, approximately, right? You'll have to pay this to the Tableau software company to keep using the software without any interruption. But I don't think that would be the best option. Anyways, you have it, one of the options. And the last and final option that we have is Tableau Desktop for Students. Okay, so you can just again get into this link which says Tableau for Students. So if you are a student currently pursuing your higher education, as in might be your undergraduation or post-graduation, or if you know someone who is pursuing their higher education who is 16 years of age or older, you can get their student ID and use it for downloading and installation of Tableau. Right now, I'll tell you, just click on this space, get Tableau for free. Now, all you need is, let it be your sibling, your niece, your nephew, your cousin, your friend, your neighbor, anyone who is currently pursuing their higher education. You can get their student ID. Just a photo of their student ID is enough. Okay, just click a picture of their student ID. The only criteria is that it should be a valid student ID. They should be currently pursuing their higher education. Okay, now it wouldn't become a valid ID if you had completed your course a couple of years back. That will not be considered as a valid student ID.
Just a quick info, guys. Intellipaat provides Business Intelligence Master's Program in partnership with Microsoft, the course link of which is given in the description below. Now, let's continue with the session.
Okay, so you will have to make sure the ID that you're making use of is valid, is of a person who is currently pursuing their higher education, and they should be 16 years of age or older. With this student ID, you will get a product key from the Tableau software company, which is a 1-year free license to activate Tableau Desktop. Okay, so see, once you give in the basic details over here, the country of school, the first name, make sure first name, last name, and the date of birth should exactly match the ID that you are using. Okay, whereas you can give in your own email ID, that wouldn't be an issue. Okay, but just make sure you shouldn't give in your name. Whatever ID card you are planning to use, that ID's first name, last name, and date of birth should be specified or mentioned right here. Okay, and then you'll have the school name and for what purpose you're using Tableau and all that. Okay, once you're done with all these details, you'll be moving into the next page where you'll have to attach a photocopy of that student ID. Okay, and after submission, within a few minutes, you'll be getting a mail to this email ID. Okay, you'll be getting a mail from the Tableau software company with a product key, with a 20 alphanumeric, 20-digit product key. Using that product key, you can activate Tableau Desktop and keep using it for free for the next 1 year. That is known as the student license of Tableau. Okay, if in case you're able to get a student ID, I think this would be the best option, because for the next 1 year, without any interruption, you can keep using Tableau Desktop. Okay, now another important point that you'll have to remember is that, see, the 14-day free trial version of Tableau, the student version of Tableau, which is free for the next 1 year, or the licensed version from your organization, all the versions are absolutely the same. See, just because Tableau is giving you a 14-day free trial, it doesn't mean some of the features are going to be locked or something as such. See, for example, even in an MS Excel or MS Word, if you don't have the complete licensed product, you'll not be able to might be edit your work. Some of the features will be locked, right? But that's not the case when it comes to Tableau. Let it be a 14-day free trial version. Let it be a student version. Okay, no limitations at all. Student version, trial version, complete, licensed product, all the versions are absolutely the same. You'll have access to all the features, just like how you build a dashboard in a licensed version. You will be able to use all those options in a free trial, in a student version, and all that, right? So no limitations at all. You'll not be able to find a difference whether it's a free trial or whether it's a student version or a licensed version. Okay, so you'll absolutely have no differences, no limitations between these versions. So any option you proceed with, you'll definitely get the whole product to use, right? Now, let's say you only have the 14-day free trial in hand. Okay, now if you've already installed your 14-day free trial, then that's okay. But in case you still haven't installed your 14-day free trial, what we can do is, let's save this 14-day free trial during the latter part of our course. As in, during the second half of our course, that is when we'll actually be already into some of the advanced topics. Okay, we would have already started creating worksheets and dashboards. You'll be working into your assignments and project work, right? So you can make use of the 14-day free trial of Tableau Desktop during the second half of our course. Now, this point, as in why I started this point, is, let's say, for example, you're not able to get a student ID, you're not getting the product key from your organization, you're not able to proceed with any of the other options, but you only have the 14-day free trial in hand. In that case, I would suggest you not to download the 14-day free trial right away. Let's make maximum use of the 14-day free trial of Tableau Desktop during the second half of our course. Okay, till then, we have Tableau Public in hand. Okay, as I'm telling you, I'll repeat this point once again. It's perfectly fine if you've already downloaded your 14-day free trial, no worries. Okay, but if in case you haven't, you can, as of now, go ahead with Tableau Public. See, again, get into Google and just say download Tableau Public. I think this is one of the most easiest softwares, where downloading and installation is so easy. The whole installation process will be completed within a maximum of 5 to 10 minutes. Okay, 10 minutes is too long. Might be 3 to 4 minutes is more than enough to download and install the software, right? So get into download Tableau Public, the first link that you have over here. As I told you, Tableau Public is an absolute freeware. Okay, once just given your email ID, download it, exe file will be downloaded, and after that you'll have to install it, which will take around 3 to 4 minutes, as I told you, and that's it. You'll have Tableau Public in your system. So Tableau Public is an absolute freeware. Once you've downloaded it, downloaded and installed it, you can keep using it for free for lifetime. No worries at all, because it's an absolute freeware. But Tableau Public has 4 limitations when compared to Tableau Desktop. Okay, so in a real-time scenario, we generally don't use Tableau Public because of these limitations, but just for practice purpose, trust me, just for practice purpose during our sessions, Tableau Public is actually more than enough. Okay, so these are the different ways of downloading and installing Tableau Desktop and Tableau Public, and whichever method you are comfortable with, you can definitely proceed with that. Okay, now let's say in my laptop, I have both downloaded and installed, right? I have both my Tableau Desktop as well as I have my Tableau Public, which has been downloaded and installed. They are two completely different products. So if you want, you can also have both installed in your system. That's up to you. But I have to open up both and walk you through the environment. That's the reason I have both downloaded and installed in my system. Okay, so once you've downloaded the exe files, you'll have to install them, which wouldn't take more than 5 minutes, I would say. And after that, okay, when you open up the tools, when you open up the software, let's see how the start page looks like. Okay, I'll start with the start page of Tableau Desktop. Okay, right. See, the moment I open up, the moment I double click, see, this is the icon of Tableau Desktop. The moment I double click on it, this is how the start page opens up. This is the starting page, and see, this is Tableau Desktop Professional Edition. I have version 2021 3.3, which is definitely not the latest version. I mean, I still haven't updated mine because I wanted to tell you, see, suppose I have 2021 3.3, 2 months back, this was the latest version. Okay, couple of months back, this was the latest version. But after that, there might be some changes that's happening, some issues that are resolved in the background. Might be 1 or 2 minute features would have been, introduced. Basically, it's issue resolving that's happening, okay, in the background. And they've launched the next version, the next, higher version for the software. How will we come to know that there's the next higher version that has been launched? Should we keep a track somewhere? Should we keep, checking a particular website often to make sure we are up to date with the latest version? No, not at all. Once you've downloaded Tableau, suppose, there's the next higher version that is getting launched, right? So when you open up the start page, in your right-hand bottom corner of the start page, you have this orange color pop up, right? So this is going to tell you, see, there's the next version, 2021 4.2, which is available now. You are using one of the older versions or earlier versions. So click on this pop-up to update your software to the latest version available as of now. Okay, so whenever there's the next higher version that is getting launched or introduced, you will be informed, or this pop-up will tell you that there's the next higher version that's available. Just by clicking on the pop-up, you'll be directed to a page. You'll be directed to the website of Tableau, where just click on download Tableau Desktop 2021 4.2 and get the latest version. See, this was just a couple of days back. Okay, release date was on 19th of December, right? So very often, I mean, there's no specific time span within which they keep releasing or, updating the software. Sometimes it would be once in 3 months. Sometimes it would be twice in a month. Okay, it completely depends on how they resolve the issues in the background, but not much of a difference we will be able to find between the versions. It's something that's happening in the background. So from the front view, from the user interface, we'll definitely have no difference at all, right? So this is how you will be informed about, just by clicking on that orange color pop-up that we had, that is how you will be informed about the latest version available so far. Okay, right. So this is the start page of Tableau Desktop Professional Edition, the complete or the exclusive product just meant for development work, right? Now, when you look into the left side space of your start page, see, you have a lot of options available, a few file types, Excel files, text files, JSON files. As I told you, I think the first point when we started, I did tell you that the basic requirement to start working with Tableau is that you should have your data in hand. Okay, now you had a query, in which format my data is supposed to be. See, these are the different locations and files where you might have your data. Your data might be a simple Excel file locally present in your system. It might be a text file, a JSON file, a PDF file, okay? Or, I mean, it's not every time you have your data locally within the system. You may have it in some server or cloud, right? So go all the way down and click on more. You will have more than 50 types of servers and databases from where data can be connected with Tableau, right? So see, as I told you, you have Amazon Redshift, you have Databricks, you have SQL, you have Mongo, you have Google Sheets, you have Oracle, you have SharePoint, you have SAP, Salesforce, Snowflake, so many options available, IBM, right? So wherever you have your data, whichever server, whichever cloud you might have your data, you can very easily, just with a few simple steps, connect the data with Tableau, right? So we'll look into a few examples, right? But yes, these are the different locations. You also have ODBC and JDBC drivers as well, okay, through which you can connect your data with Tableau, right? So these are the different servers, clouds, file types from where data can be connected very easily with Tableau. Okay, that's about Tableau Desktop. Now, suppose you've downloaded and installed Tableau Public, or might be if you're planning to download and install Tableau Public. Let's open up Tableau Public and let's look into the start page, right? See, this is the start page of Tableau Desktop Public Edition, and in short, we call it as Tableau Public. Okay. Now, again, I have one old version, okay, which was launched, I think, around a few months back. Okay. Now, again, see, you have a similar pop-up in Tableau Public also. Now, I still haven't updated mine. By tomorrow, by our next class, I'll update mine. But I just wanted to give you an idea. See, this is how the pop-up looks like. If suppose there's the next version that is getting, launched or released, you needn't go keep a track. You needn't go visit a website and get to know about the updates. Your start page, the pop-up in your start page itself will let you know about it. Okay, so again, we have the same 2021 4.2 version available for Tableau Public as well. Okay, and here on the left side connect pane, we have the file types. These are the different files which can be connected with Tableau Public. And when you click on more, let's see how it looks like. See, this is what, when you click on more of Tableau Public, this is what it looks like. So this is the first and major difference between Tableau Desktop and Tableau Public, right? We did have these many servers, clouds, and file types from where data can be connected with Tableau Desktop. But when it comes to Tableau Public,
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Tableau Public is limited to data. Server or cloud connectivity is not possible with Tableau Public. And that's the reason I told you, though the workspace is 99% absolutely the same between Tableau Desktop and Tableau Public, the workspace is the same, but databases from servers or clouds cannot be connected with Tableau Public. And when you move into a real-time scenario or an organization, we handle big data, we handle huge amounts of data, which are normally stored in clouds or servers, right? So in such a case, Tableau Public will be of no use because server or cloud connectivity is not available in Tableau Public. That's the first difference and limitation. Now this, when they question you in what way Tableau Public is different from Tableau Desktop, this should be the first point. Tableau Public is limited to data. Server and cloud connectivity is not available in Tableau Public, right? But anyways, just for practice purpose during our sessions, we'll be using text files, Excel files, PDF files. That is when you can very well use Tableau Public just for practice purpose. But when it comes to a real-time scenario, server and clouds cannot be connected with Tableau Public. And that's the reason we say Tableau Public is not preferred in a real-time scenario. Okay, that was about the start page. Okay, now that, see, all we need is the software. Yes, we've downloaded and installed the software. We have the software in hand. Now, what's the next requirement? To start working with Tableau, what's the next requirement? You should have your data in hand, right? So when you have your data, might be a simple file from your local system or a database from your cloud or server. When you have your data in hand, why wait for? Connect it with Tableau and start visualizing your data. Okay, but before we get into the data connectivity part, as I told you, let's go through some sample dashboards, okay, that are created using Tableau so that it might give you an idea. Okay, this is how insightful dashboards are created using Tableau. That will give you, a broader idea of what, a broader idea of there's so much that can be done with Tableau. And it'll be interesting, once you know what Tableau is capable of. And after that, once you start getting into the workspace, that will be even more interesting. Okay, so now all you have to do is get into Tableau Public Visualization Gallery. So it's a space where we have a lot of sample dashboards or public related dashboards that are published. Okay, anyone from the public can view and use the dashboard, right? So we'll go look into some sample dashboards just to give you some idea. Okay, so just Google for Tableau Public Viz Gallery. Okay, what was the first difference between public and desktop? We have, on the whole, we have 4 limitations or 4 differences, but I'm not going to give you or list out all the 4 limitations at once. Whenever we reach that particular topic, that is when I'll highlight, because if I'm going to list out all the limitations right away, you'll not have an idea of what are those points all about. Okay, but as of now, we've looked into just one difference between them. Out of 4, we've ticked 1. The first difference is Tableau Public is limited to data. Server and cloud connectivity is not possible in Tableau Public, whereas in desktop, any server, any cloud can be easily connected with it. And that is what is not possible in Tableau Public. So in simple words, you can say Tableau Public is limited to data. Okay, that's the first difference. Right, now you can just Google for Tableau Public Viz Gallery. This is a space, kind of a gallery, where you have a lot of sample public dashboards that are published. Okay, you can just go through this whenever you have time. It would be really interesting because you'll have an idea how well they've made use of Tableau, how creative the dashboards look like, how insightful the dashboards look like. Maybe we'll get into one simple one. Let's say this one, the fruit consumption, American fruit consumption, a simple dashboard which is telling you, throughout the years, which product has been consumed, which fruit has been consumed more and which fruit has been consumed less, and so on. Some, information based on the fruit consumption data. Okay, see, okay, first let's start. Now, suppose if you're planning to look into mangoes. Okay, so here we have mangoes. When you click on mangoes, you'll get the line meant for mangoes. That is, see this orange line over here. This is just meant for mangoes. Okay, now this box that appears, the place where I've placed my cursor. Okay, now a box appears which is telling you in so and so year, the average, on an average, this was the amount of mangoes consumed by Americans and how the consumption rate is compared to the previous year. So you can add such details to your chart so that the end users can analyze with it. Okay, so we call these features as highlighting. Now see, if I click on bananas, it's only data related to banana which is getting highlighted or colored out so that I can focus on data related to banana only. If I click on pineapple, I'm getting the line meant for pineapple only, that's getting highlighted, and we call that as the highlighting feature or action available in Tableau. See, now what's the whole point over here? Now, we might have one person interested to know about strawberries, and we might have another person who is interested about apples, right? So anyone who is using your dashboard, they will be able to analyze data as per their requirement. Okay, that's the whole point in creating a dashboard, there's no point in having a static dashboard. Might be we'll get into another one. Let's say might be internet or small countries are beautiful, some dashboard that you can get into. Okay, I'm just searching for an even more interactive dashboard just to give you an idea. Global peace scores. Okay, you have some data behind this, some public data based on which they've built a dashboard, right? So over here, see, it says explore by year. You have 2017 related data. So each and every year, you will have a different, might be score for each and every country. Okay, ranked based on how peaceful it is, whether they've been having some wars within them and so on, some basic data behind it. Okay, the point that I'm trying to tell you is, see, now you might be a person who's planning to get the data or get the chart for the year 2015. Okay, so you can make use of the slider, set the slider to 2015 such that the dashboard is giving you, see, the whole dashboard is giving you data related to only 2015. Okay, so we are just a random common user who has got into the dashboard, and we are analyzing data as per our requirement. So similarly, anyone who is getting into the dashboard can analyze data as per their requirement. And that's how a dashboard is supposed to be. There's no point in having a static dashboard. Anyone who is using your dashboard should be able to analyze data as per their requirement. Okay, that is what is known as an interactive dashboard. We are able to interact with the dashboard. We are able to focus on what we are looking for with the help of such features, such sliders or drop-down menus. We call them as filters or parameters. Okay, and you also have something called highlight country. Suppose if you want data related to, let's say, Denmark to be highlighted. Okay, so if I click on Denmark, data related to Denmark only is highlighted. Okay, see this part over here, data related to Denmark is only colored out or highlighted. Now, this feature of highlighting is useful for the end users to focus on what they are looking for. See, out of the complete charts, the whole list of charts over here, it's only this single line related to Denmark that is highlighted. So highlighting is a feature which is helping you focus on what you are planning to look for. Okay, if I click on France, data related to France only will be highlighted. The whole of my dashboard is getting updated such that it highlights or focuses only on data related to France. Okay, right? And you also have a few filters again over here. See which countries and regions are progressing towards peace. Now we'll just clear this highlighting. Okay, now the next filter that we have over here, filter by region. If you're planning to look into the Middle East, or might be if you're planning to look into Asia. Okay, so only Asian region related data is going to be displayed in your dashboard, right? So that's how anyone who is using your dashboard will be able to analyze based on their requirement. And for that, you'll have to make it dynamic. How will you make your dashboard dynamic? By adding such features which, helps the end user interact with your dashboard. Okay, so we'll start. See, we have the software and we also have a data set in hand. Now, it's just a simple Excel file that I'm having. Okay, this Excel file, you must have heard about this. This is known as the sample superstore, right? So sample superstore is a data set. It's a normal, simple Excel file, which is prepared and provided by the Tableau software company themselves. Okay, so this is just provided for us to start practicing with Tableau. It has 3 Excel sheets, okay, within the file. The first sheet is known as orders. This is the most important sheet. We have around 21 columns I think around approximately 21 columns and around 9,994 rows of data. So nearly 10,000 rows of data is what we have in orders sheet of sample superstore. Then we have another sheet called people, and then another sheet called returns. Okay, so these are the three sheets within this Excel file called sample superstore. Now let's say this is our data set. Now how do we start connecting? So we have this Excel file in hand, and we also have our softwares, and we also have Tableau in hand. Okay, now how are we going to connect this data with Tableau, and how are we going to convert this tabular data into graphical representation? Okay, so now I have my Tableau desktop. You can also do the same with Tableau public. Okay, now what is the file type where we have sample superstore or the data set? It's an Excel file. Yes, so from the start page, this is known as the start page. On the left hand side, this blue color space is known as the connect pane. Okay, so in the connect pane, you'll just have to click on the respective file type. So I have my data, which is in the form of an Excel file. So I'll be clicking on Microsoft Excel. Okay, just click on Microsoft Excel, and after that, you'll get a dialog box that will pop up. Okay, now Tableau is telling you you have these many folders in your system. Get into the respective folder wherever you have your Excel file called sample superstore. So I have it somewhere over here. Click on the file and then click on open, right? Very simple. You just have to click on the file type. Now we are trying to connect an Excel file with Tableau, right? So click on Microsoft Excel, browse, get into the respective folder wherever you have your Excel file, select the Excel file, and then click on open. That's it. Within a few seconds, you'll automatically be directed to a page known as the data source page. So again, today we'll be coming across a lot of new terms related to Tableau's workspace. And as I told you, we'll be using these terms very, very often, again and again, and you'll gradually get familiar with them, right? Okay, so now the moment a successful connection has been established, you'll be automatically directed to this space or this page, and this is known as the data source page. The name of the page is right here. You can just look into the left-hand bottom corner of the page. It says data source. Okay, so data source is the name of this page. Okay, and right next to that, you have a tab called sheet number 1. Okay, when you click on sheet number 1, you'll be moved on to this space. This is the actual workspace of Tableau. We call it as a worksheet space. Okay, worksheet is where you'll be, building all your charts and graphs. You'll be converting your data into graphical representations. So on the right hand top corner, you have show me. You have all the readily available chart types over here. So this is the complete, most important workspace, worksheet space from where we'll start building our charts and graphs. Okay, but as of now, okay, we are into sheet 1, we are into the worksheet space, but there's no data in hand. See, you have the left hand space called tables. There's nothing under tables. There's no columns, that can be dragged and dropped with which I can build my chart. Okay, so we've just connected sample superstore with Tableau. We have orders, people, and returns, the sheets of sample superstore listed out right here. Okay, and right next to the data source tab over here, you have something called sheet number 1. When you get into the worksheet space, this is your worksheet space. See, you have rows, columns. This is where we are going to create our visualization. Okay, but in order to start visualizing your data, you have to have columns from your data. Now, suppose product-wise profit, country-wise sales. So I should have my country, sales, profit, all these columns from the data set should be available right here. Only then I can drag and drop them to build my chart. Okay, but we don't have any of the columns brought into the worksheet space. The reason for that is, right, I'm going back to my data source page. How do you do that? You'll have to click on the data source tab in your leftmost bottom corner to go back to the data source page. Okay, as this is day one into the software's workspace, it will take a little time to get familiar, but as you keep working, right, that's the most important key point. You'll have to keep working with the software, keep on getting familiar with the workspace. That's how you dive deeper into the features that we have in Tableau. Okay, right. Now, it's not enough if you simply connect your data with Tableau. Okay, though Sample Superstore has been connected, it's not enough if you just connect your data. You'll have to drag and drop at least one sheet into this space. See, it says drag tables here. This space is known as the canvas area. Okay, again, a few new terms coming up. This space is known as the canvas area. You'll have to drag and drop at least one sheet into the canvas area, just a simple drag and drop. Okay, drag and drop at least one sheet into the canvas area. What will happen is, see, I've dragged and dropped orders. So what has happened is I have the corresponding data brought into the view area. So this part, this blank space, see, I'll do that once again. Now this space, after you've connected your data with Tableau, this blank space which says drag tables here is known as the canvas area. The moment you drag and drop at least one sheet into the canvas area, what is going to happen is the corresponding data in the sense you have a set of rows and columns in orders Excel sheet, right? So all these columns and rows are going to be brought into Tableau's workspace, and this space is known as the view area. Okay, view area, because Tableau is letting you view the data that actually belongs to the orders Excel sheet. Okay, so it's not enough if you just connect your data with Tableau. You'll have to drag and drop at least one table, one sheet into the canvas area. Only then you'll get the corresponding data brought into the view area. See, it is telling you you have a total of 21 fields, as in 21 columns, and 9994 rows of data in the orders Excel sheet. Okay, so you have row ID, order ID. You can just compare it with your Excel file. See, we have row ID, order ID, order date, ship date, and so on. All these columns are, brought into your view area. See, row ID, order date, ship date, and it just keeps on going. Okay, all the 21 columns are brought into your view area. Now, when you go into sheet number 1, let's see what happens. I'll click on sheet number 1. Okay, now the left-hand space is having the complete list of columns that belong to orders of Sample Superstore, right? So orders is placed into the canvas area. You have the corresponding rows and columns brought into the view area, and all these columns are listed out right here into the worksheet space so that you can drag and drop them to build your charts and graphs. Okay, so now getting into the next few points that we have. Now, there's some checkbox over here called Use Data Interpreter. Okay, now first of all, Data Interpreter might be able to clean your Excel file. So Data Interpreter is something like a cleansing tool that we have in Tableau. Okay, suppose if you have some garbage data, if you have some null values in your data, might be empty rows, empty columns, stack headers. Now, sometimes Excel files will have huge titles occupying around 5 to 10 rows. Okay, so such titles which are actually not required for reporting purpose. Okay, all such unnecessary things in your data set is going to be identified and cleansed or bypassed in such a way to convert your data into a proper format with which you can start visualizing in Tableau. So it's a basic cleansing tool that's readily available in your data source page. Okay, I have another sample file. Very soon we'll be connecting that with Tableau, and I'll tell you, we do have some cleansing work that needs to be done, and we'll try using the data interpreter, and we'll see how data interpreter is going to clean our workbook. Okay, now, as I told you, data interpreter is a cleansing tool. It is just going to identify the unnecessary things in your data, remove them, or bypass them to give you the data in a format that is suitable for visualization purpose. Now, sometimes when you're connecting, some data sets with Tableau, you will not have the data interpreter. Might be when you connect a different Excel file, the data interpreter might not be available over here in this space. There's nothing to worry about it, because see, if Tableau feels that your data is already so clean, already in a perfect format with which you can start visualizing your data, Tableau itself neglects, or it doesn't display the data interpreter option at all. Okay, so the reason behind you not having the data interpreter is your data is already so clean. There's no need for such cleansing tool in order to clean your data. It's already clean, it's already in a perfect format. So Tableau, once it identifies that, it tries avoiding the data interpreter by itself. That's the reason you don't have a data interpreter. Okay, next we have orders, people, and returns twice listed out in this space. Why is that? Okay, now the first three names, orders, people, and returns, okay, you have a table like icon right next to it, right? A mini table like icon right next to it. So that is telling you that these are the actual sheets that belong to sample superstore. But when you look into the next three names, you have some card like, some business card like symbol. And when you place your cursor, it says named range within brackets. So orders named range, people named range, and returns named range. So what is a named range all about? See, named range is something that can be created in an Excel workspace. Named range creation is in no way connected with Tableau. Suppose you're working in an Excel file, okay? If you want, you can create a subset table in your Excel workspace, and that is what is known as a named range. Now I'll give you an example. I'll just open up some sample Excel file that I have in hand. This is just a simple Excel file that I'm opening up. And now this Excel file is having two sheets. See, customer sheet and the sales sheet. Now, if I'm planning to create a subset table in the sense, let's say I would like to select these 3 rows along with a column header. I'm selecting might be 3 rows. Okay, so I'm trying to select a continuous range of cells, and I'm giving a name for it. So that is what is known as a named range. Okay, so we have named range, which is nothing but you have a range of cells. Range is nothing but a continuous range of cells for which you are going to define a name. You're going to name this range of cells, and that is what is a named range all about. It's kind of a subset data or table that you are trying to create. Okay, now for example, I'm trying to select, just click, drag, okay, select, and then release your button. So I've selected a continuous range of cells, right? Click on the drop down arrow in your name box, okay, and then click on manage names. So you'll have to first of all drag and select some continuous range of cells. Click on the drop down arrow in your name box and then get into manage names. Okay, so this is where you can click on add and you can define the name. Okay, I'll just call it as my sample range. It is not going to allow spaces in the name. Okay, so I've just named it as my sample range. Click on add. So this is how you create your named range in an Excel environment. Okay, now if at all you've created a named range in your Excel file, so named ranges are created in Excel environment. If you've created the named range in your Excel environment, now when I connect this Excel file with Tableau, what will happen is you will not only have your sheet names. See, customer is one sheet, sales is another sheet. Along with your sheet names, you will also have your named ranges that are going to be listed out just like how it appears over here. Okay, so named range creation is definitely not mandatory. It is purely optional and it has nothing to do with Tableau's workspace. If a named range had been created in your Excel environment, then Tableau is just reflecting it in its data source page. That's it. Tableau is not creating a named range, automatically or by default. Tableau has nothing to do with it. If your Excel file is having a named range, then yes, Tableau is just showcasing it in its data source page. Okay, now, first of all, I'll tell you why they have the same names in this case, and then I'll tell you what's the use or what's the purpose of having named ranges. Okay, now, see, as I told you, sample superstore is something that is prepared and provided by the Tableau software company themselves. Okay, this is a data set which is prepared and provided by the Tableau software company. So when they created the data set, they had created 3 Excel sheets named as orders, people, and returns. And they also created 3 named ranges with exactly the same name. Why? Because when it comes to Tableau's workspace, the way Tableau treats an Excel sheet and a named range is absolutely the same. Both are treated as tables by Tableau. So the reason why they've named it using the same naming convention is that they are just trying to tell you whether it's a people Excel sheet that is being dragged and dropped into the canvas area, or whether it's the people named range that is being dragged and dropped into the canvas area, both are treated as tables by Tableau. Okay, so there's no difference between an Excel sheet and a named range as of how Tableau is treating them. Okay, it's definitely not mandatory to create a named range whenever you're working with Tableau. It's purely optional. The reason why we create a named range is, see, suppose your Excel file is having, let's say, 1 million rows of data. Okay, such a huge amount of data is present in your Excel file. Let's say it's present in sheet number 1 of your Excel file. Okay, now right away, working with such a huge amount of data into Tableau, it might affect the processing speed. Tableau's performance might slightly be reduced.
Just a quick info, guys. Intellipaat provides Business Intelligence Master's Program in partnership with Microsoft, the course link of which is given in the description below. Now, let's continue with the session.
Gradually, it will become slower in responding because of such a huge amount of data. So instead, what you can do is, might create a subset.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Table. Subset table is nothing but the named range, which is having might be the first 1,000 rows of data. Okay, something like a sample data. Just pick up the first 1,000 rows, create a named range, and use that named range into the canvas area to proceed with your analysis. Might be to start, uh, to getting basically to start getting to know your data. You can use the smaller table, which is having only 1,000 rows, and then you can start working with the actual Excel sheet. Right, so that is one scenario where we prefer using named ranges. Okay, so that's it. Nothing much about named ranges. It's just a subset table which is created in your Excel environment, and Tableau is just showcasing it in your data source page, and it is telling you, see, these are the things available in your Excel file. It's up to you to use it to proceed with your visualization work. Okay, so that's about named ranges. Okay, I have another workbook. Okay, this is a new workbook again, book number 2, a new workbook of Tableau. Now, we just went through an Excel file connectivity. Now, might be, what if I have my data present in a PDF file? Okay, now I have a PDF sample in hand. See, this is just a very simple PDF file, which is having two simple sheets, two simple pages. In the first page, we have some data as texts and paragraphs. We also have a table over here. This is page number 1. And in page number 2, again, we have some data over here with a couple of tables in page 2. Okay, now, when I'm connecting such a PDF file, okay, or any such file which is of a .pdf format, how is going to Tableau read the data or connect the PDF file and bring the corresponding data into your data source page? So what are the steps involved in connecting a PDF file, and how is the data going to be brought into Tableau's workspace, right? So this is the PDF file that we are right now planning to connect with Tableau. So I have a new workbook over here. Now this time I'm planning to connect a PDF file. So I'll have to click on the respective file type. See, PDF file is the one that I'm planning to connect. Click on PDF file, and just like how you had a dialog box, similarly, when I clicked on Microsoft Excel, we did have a dialog box that popped up, right? Similarly, when I clicked on PDF file, we are having a dialog box. Now I'll have to get into the folder. So this is a folder called PDF samples, where I have my PDF sample 1. Okay, this is the PDF file that I'm planning to connect. Click on open. And now what's happening over here is the way you connect your data with Tableau from different file types and locations will slightly be different. Okay, see, we connected an Excel file. The moment I clicked on Microsoft Excel, we had a dialog box. I went into the respective folder, clicked on Sample Superstore, and then clicked on Open, and we were directly directed to the data source page. But now it's slightly different. The way of connection, the way of connecting a PDF file is slightly different when compared to an Excel file. Okay, this is an additional dialog box that you'll have to pass through whenever you're planning to connect a PDF file with Tableau, right? So it says scan PDF file. Specify the pages to scan for data. Now what's happening is Tableau is going to go scan your PDF file, read your PDF file, and it's going to bring the data into Tableau's workspace. Now, what kind of data is Tableau going to look for? When Tableau is scanning my PDF file, Tableau is only going to look for data present in a tabular format. Okay, see all these texts, titles, and paragraphs, Tableau is not going to take them into consideration. Whatever data in your PDF file, which is present in a tabular format, only that is going to be scanned, considered by Tableau and brought into the data source page. Okay, so we'll see what's happening. Now this dialog box tells you scan PDF file, specify the pages to scan for data. And you have 3 radio buttons over here. Okay, now you will have to tell Tableau which particular page Tableau has to scan for data. Okay, see, in our case, we have only 2 pages. So you can simply tell Tableau, scan all the pages in my PDF file. But just imagine, what if you have around 1,000 pages in your PDF file, right? Let's say I'm having 1,000 pages in my PDF file, okay? And the table, okay, let's say page number 55. Page number 55 is the only page where I have a table that is to be brought into Tableau for further analysis, right? In such a case, out of 1,000 pages, where there's only one page containing the table that I am in need of to proceed with my analysis, there's no point in telling Tableau to scan all the 1,000 pages, right? It would be time consuming. All the unwanted tables from the other pages also might be brought into Tableau's workspace. So that would become really clumsy, right? So to make things easier, to save a lot of time, what you can do is you can straight away go tell Tableau, see, there are 1,000 pages in my PDF file, but still the table that I am in need of particularly belongs to page number 55. So you can tell Tableau, please don't waste time, directly go into page 55, scan for tabular data and bring my table into the data source page, right? So this is where you get into the second radio button called single page. You'll tell Tableau, page number 55. So when you click on OK, what Tableau is going to do, it will go right away into page number 55, scan that page, look for tabular data, and bring that table into the data source page of Tableau. So by doing this, you will not only save time, okay, you'll also get the exact table only brought into the data source page instead of having unwanted tables from the other pages. Okay, so this is where we go into the single page radio button. Okay, and the third radio button says range. What if you need 2 pages, or what if you need more than 2 pages, right? Suppose I have the tables required that belongs to page number 55, 60, 62, and 69. Okay, might be I have 4 pages, okay, where the required tables are present. Now, I won't be able to go ahead with the all. I mean, you can, but it's going to scan all the 1,000 pages. It would be time consuming. So I feel that option is not the one I would prefer. Single page, again, this is not going to work because single page is where you can only specify one single page at a time. Okay, so range might be the option you would prefer, where you can tell Tableau, see, I have a set of pages from where tables are required. Okay, I'm telling Tableau, start scanning from page number 55, scan till page number 69 and stop your scanning right there. So I'm specifying a range of pages. So with this option, what will Tableau do? It will go into page 55, right from page 55, 56, 57, 58, 59, 60 till 69. All the pages are going to be scanned and brought into the data source page of Tableau. Okay, right, from which you can drag and drop the required ones into the canvas area and proceed with your analysis. So these are the only 3 ways you can tell Tableau which page or how many pages are to be scanned for data. Okay, so as I told you, in our case, we only have 2 pages, so I'll be using the first option. Okay, and suppose you are using the second or third radio button where you are specifying the exact page number or the range of page numbers to be scanned for data. You'll have to remember this point. This is a very, very important point that you'll have to make a note of. Okay, it says the scan counts the first page of the file as page 1 and ignores the page numbering used in the file. Now, what does this mean? See, the scan counts the first page of your file as page number 1 and ignores the page numbering used in the file. In the sense, see, the page numbering is nothing but this page numbering. It is going to ignore such page numberings. Why? Because, see, I'll tell you. Now I'll just give you an example. Let's say I've scanned 10 pages from a particular textbook that I have. Okay, I've scanned 10 pages starting from page number 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. Okay, these are the 10 pages I've scanned from a particular textbook that I have. Okay, the table that I am in need of belongs to this page. Okay, now this is the actual page numbering. I've taken a textbook, the page numbering in the sense, the page numbering in my textbook, from the 25th page in my textbook, I've scanned a set of 10 pages. This is the whole PDF file that I have in hand. So my PDF file having 10 pages, the page numbering over here starts from 25 to 34. Okay, now the table that you want, if it belongs to page number 28, you shouldn't go tell Tableau, see, scan page number 28. Okay, this is not the way you tell Tableau, because Tableau is not taking the actual page numbering into consideration. It is going to count the first page of your file as page number 1. So what is Tableau doing? This is the first. The position of the page is what is taken into consideration by Tableau. Okay, look into the position of your page. See, this is the first page in my PDF file. This is the second page in my PDF file. So in that manner, Tableau is counting the first page of the file as page number 1. The position of your page in the PDF file is what is to be taken into consideration. So in that manner, this would be the 4th page, right? This would be the 4th page. Yes. So you'll have to go tell Tableau, if you want this particular page to be scanned, you'll have to go tell Tableau scan page number 4. So the 4th page in your PDF file, whatever the page numbering might be, the 4th page, the position of your page is what is to be taken into consideration. That is how Tableau is counting the pages in your PDF file. Right? I hope you're getting what this line actually means. Consider the position of your page. Ignore the page numbering used in your file. Now you might have a query. How will I know the position of the page? See, this space over here, the toolbar in your PDF file will tell you, this is the first page out of 2. Okay, the position of the page, this is what gives you the position of the page in your PDF file. Ignore the page numbering. Okay, that's about this line, which is telling you, you'll have to make a note of that. Okay, now click on OK. Within a few seconds, you'll be directed to the very same data source page. See, I hope you're familiar with this page, because this is the same page where we were directed to when we tried connecting an Excel file, right? So this is the most important point. No matter from where you're connecting the data with Tableau, once a successful connection has been established, you'll right away be directed to this page known as the data source page. And that's why we have this point. The way you connect your data with Tableau, the way of connection, the steps involved in connecting your data will slightly be different, from each other. See, the way you connected a PDF file was slightly different from the way you connected an Excel file, which will in turn be slightly different from the way you connect might be your SQL database, right? Though the way of connection is slightly different, once connected, what's happening? Once a successful connection is established, you are being directed to this page known as the data source page. So once you get into the data source page, right from this point, the way you proceed with your visualization work, the way you build your charts, the way you create your dashboards, the way you make them interactive, all the features and everything is absolutely going to be the same. Okay. Once you get into the data source page, you'll definitely be able to find no difference as in from where the data is connected, because once you're into Tableau's workspace, the workspace is just the same no matter where the data is connected from, right? So And in a similar manner, see, we tried connecting a PDF file. Once the successful connection is established, we are being directed to the same data source page. You again have your canvas area, and over here, see, you have page 1, table 1, page 2, table 1. This is how the naming convention is. Okay, now suppose you have multiple tables in a specific page, it will be named as page 2, table 1, page 2, table 2, page 2, table 3, and so on. So that's the default naming convention when you're working with PDF files, right? So we've already connected the PDF file. We had the scan PDF file dialog box, which was an additional step with 3 radio buttons. You'll have to specify the pages to be scanned by Tableau. It can either be all the pages, just a single page, or might be a range of pages, right? And after that, you are being directed to this page known as the data source page. So here we have again the file name, the file type, data interpreter. You have the tables that are being scanned by Tableau in your PDF file. And here we have the canvas area as well. Okay, so what are we supposed to do next before getting into the worksheet space? You'll have to drag and drop at least one table into the canvas area. Okay, so during which what will happen? The corresponding data, whatever data is present inside the table, will be brought into the view area. Yes, so I'm dragging and dropping page 1, table 1, and you're getting the view area, which is having the rows and columns that belong to your table that was present inside your PDF file. Okay, so this PDF file, when you look into the PDF file, it was page number 1. See, we have 2 columns and 4 rows. We have number of coils, number of paper clips with a few rows of data. This is the actual table. But what's happening is when Tableau, whenever, this is a common issue that we face when you have data in a PDF file. Okay, Tableau doesn't scan properly. It has a lot of issues while scanning. It also scans something which is actually not required. So, scanning issues are very, very common when you try connecting data from PDF files with Tableau. Okay, so this is the table that has been scanned. But let's look into the table. See, instead of number of coils and number of paper clips as column headers, Tableau has identified them as a part of your data. Okay, and instead of these, as your column headers, it is having something called short circuits. F2 is an automatically generated column header. If you have a table with no columns, it'll automatically give F1, F2, F3, and so on as your column headers. But in this case, we do have column headers, but Tableau was not able to identify them as my column header, instead of which you have something called short circuits. Now, where did the short circuits come from? When you look into the PDF file, short circuits is something that appears just above my table. Okay, so as I told you, during the scanning process, Tableau tries to scan, Tableau by mistake, it assumes the text which appears above or somewhere below the table also to be a part of your table. And, this is where short circuits has assumed to be a part of my table and brought into the data source page of Tableau. But it is actually not that way. Short circuits is not even a part of my table, right? So there's a lot of issues in how Tableau has scanned this table. Okay, now we will have to make some changes, right? We'll have to clean the table, clean the data. And I want a table which exactly looks like the one that I have in my PDF file. Okay, so what do we do? How do we clean the data? And this is where your data interpreter comes into act. Okay, now you can simply click on this checkbox, just check the box. Data interpreter will be able to clean your PDF file workbook. Just check this box telling Tableau to use the data interpreter, and within a couple of seconds, you'll get cleaned with data interpreter. Okay, now as you can see, you have number of coils and number of paper clips, which has been identified as the column headers. I mean, this was just a small table, right? If you have a lengthier table, if you're planning to know what are the changes data interpreter has done to my data, what are the steps taken by the data interpreter to give me a cleansed output, if you're planning to know more about it, all you have to do is just click on this link over here. It says review the results, right? Reviewing what data interpreter has done to my data, what cleansing work data interpreter has done to my data. Just click on the link over here and you'll have an Excel file that will open up containing the first page is the key for data interpreter. And when you get into page 1, table 1, it is telling you these are the changes. See, these two, as a number of coils, a number of paper clips, they're identified as headers by the data interpreter. So this, using the color key to understand what is pink and what is green, you can go into key for data interpreter. See, the ones in pink, data is interpreted as column headers. So that is how, or these are the changes, these are the cleansing. This is basically the cleansing work data interpreter is doing on my PDF file. Okay, right? So that's about connecting a PDF file. That's about connecting an Excel file. And there's another point I would like to tell you before we move into the rest of the file types connectivity. Okay, so now I'm back into the workbook where sample superstore is connected. Okay, so I've connected sample superstore. I've dragged and dropped orders into the canvas area. You get the corresponding data brought into the view area, right? Now, there's a specific reason why we call it as a view area. See, now the point is Tableau is a software which is letting you visualize your data, right? Tableau is acting as a front-end tool or a mirror, which is just reflecting the data through which you can convert them into graphical representations, okay? Which means you cannot touch your data in Tableau. Touching the data in the sense, you will not be able to make changes to your data in Tableau's workspace. No editing work, no adding rows, no adding columns, nothing can be done in Tableau's workspace. Tableau is just a mirror. Whatever data you have in your original data set, Tableau is just reflecting it as a mirror where you can play with your data. You can, use the columns, use your data, convert them into charts and graphs. That kind of work is what can be done inside Tableau, but making changes to your data is definitely not possible in Tableau's workspace. Now you might have a query. Now let's say I have 10 new rows which are to be added to the data set. How can I do that? You'll definitely not be able to do it in Tableau. If suppose you're planning to add a few rows, delete some existing rows, or might be there's a small change. See, this customer ID is actually not right. I will have to make a small change over here. Editing work, adding or deleting rows and columns, none of these, none of the editing work or changes to the data can be made from Tableau's workspace. You will have to go all the way to the data set. What's the data set connected with Tableau now? Sample Superstore. So go back to Sample Superstore's Excel file, make the necessary changes, and then these changes are going to be reflected into Tableau's workspace. So Tableau is just a mirror, okay, which is reflecting your data, acting as a front-end tool. Now, let me give you an example for that. See, let's say you have a person standing right in front of the mirror. Okay, now this person is considered to be the original data set. Okay, and the mirror right in front of him is representing Tableau. Okay, now when the person standing right in front of the mirror, he's changing his hair color. So what's happening? When the person changes his hair color, the reflection in the mirror is also, the change is also being reflected in the mirror, right? Similarly, you go into the original data set, make any change, all those changes are going to be reflected into Tableau's workspace. Tableau is just a mirror reflecting the data from its original location. But See, we do have options to rename column headers in Tableau. How is that possible? Now, for example, row ID, I'll just double click on row ID and I can rename it as however I wish to. Okay, or we have options to split your columns in Tableau. Might be order ID is there. I can easily go click on split. Okay, using hyphen as the separator, I can split my order ID column. I've tried splitting order ID, and when I scroll to the rightmost space of my table, I have order ID split 1, order ID split 2, and order ID split 3. Order ID has been split into 3 different columns. See, I mean, what was the point I told you? You'll not be able to make changes to the data. Okay, Tableau is just a front-end tool acting as a mirror. You won't be able to make changes to the data. But how come we are able to split a column, rename a column header? How is this possible? Okay, see, making changes in Tableau's workspace, like renaming your column headers, splitting your column, or might be, concatenating columns. All these changes that you're making locally in Tableau's workspace is just for your convenience to work in Tableau. Going back to the example, when the person is changing his hair color, it's exactly the same way reflecting in the mirror as well. Okay, but just imagine, what if you take a sketch pen and you scribble something on the mirror? Okay, will this scribbling affect the original person? Definitely no. Right? This scribbling that you've done on the mirror locally stays on the mirror. It is in no way affecting the original person. Similarly, renaming column headers, splitting your columns, or might be merging columns, all these points that are locally done in Tableau's workspace is just for your convenience to work in Tableau. It's something like the scribbling part that stays on the mirror itself. These changes that you're doing, column header renaming and all that, locally stays in Tableau's workspace. It is in no way affecting the original data set. See, my column header is still row ID in my Excel file. Order ID has not been split. Okay, these changes that are done in Tableau is just for your convenience. Just like the scribbling that you make on the mirror, it is in no way going to affect the original person. It is in no way going to affect the original data set. It's just for your convenience to work in Tableau, right? There's another point. Okay, so getting back to the PDF file. Now, see, the point is we have a lot of issues when you're connecting data from PDF files, the scan issues, column headers not being identified properly, and so on and on and on. Right? We'll have a lot of issues that either has to be rectified using the data interpreter, or might be you'll have to make changes manually as well, okay, in order to reach to a point where you have a table that is capable of proceeding with analysis. Okay, this seems to be frustrating, right? Now just imagine I have page 1, table 1 from the PDF file. Let's say this page 1, table 1 is so important for my organization.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
It's present in a PDF file, and I'm planning to very often work on this table in future as well. Might be in a day, at least twice or thrice, I'll be planning to work on this table. It's present inside a PDF file, right? Now, every time, very frequently in future, I'm planning to work with this table. Now, just imagine every time when you're planning to connect the table, you'll have to connect the PDF file, scan the PDF file, use the data interpreter, make all the necessary changes, and then start working on the table. If this is the case every single time, and in our case, it's just a small table. If you have a lengthier table, you will have a lot more issues, a lot more time taken to solve these issues and start working on the table. Okay, if this is going to be the case every single time, very often in future, it would definitely be time consuming and frustrating as well. Okay, so for that reason, what we normally do is, for the very first time, when you're connecting the table from your PDF file, we have to go ahead with those cleansing part, right? We'll make all the necessary changes. We'll use the data interpreter. And once you have, let's say you've spent half an hour in making all the necessary changes, okay? Will you be able to afford to spend the same half an hour every single time you're planning to work on the data? That's definitely not possible, right? It's not worth it. So what you can do is, to make your work easier, to avoid this time spent on the cleansing part, what you can do is, once you have a table that looks perfectly fine, once you've cleansed, you've made all the necessary changes, what you can do is you can export it into a CSV file. Okay, I'll tell you how that can be done. Just go into sheet number 1. Okay, just get into sheet number 1. You have your data source name, right click on your data source name, and there you have an option called export data to CSV. See, we have page 1, table 1 over here. That's the name of my table. I'm planning to export my data from page 1, table 1 into a CSV file. So this data from page 1, table 1 is now going to be exported into a CSV file. Okay, I'll tell you why it is specifically being exported into a CSV file, because CSV is nothing but character delimited, or might be a comma separated file. It's the most simplest file type from where data can be connected with Tableau, right? So I'm exporting my data from page 1, table 1 into a CSV file. Let's name it as, might be sample CSV. I'll be saving it in my desktop. Okay, I've exported my table from page 1, table 1. See, as you can see here, we have it. So the data from page 1, table 1, which was actually a PDF file, has been exported now into a CSV file. And let's open it up. Let's see how it looks like. I'll open it with my notepad because I want it as a comma separated file. You have the column headers separated by commas, and you also have the data separated by commas. So now, what was the purpose? Why did we do this? Because, see, in future, now let's say tomorrow, once again, I'm planning to connect the same table. I'm planning to work on it. Where do we have the table? We have it inside the PDF file. So right from the scratch, I'll have to connect the PDF file, specify the pages to scan for data, cleanse, go through the entire cleansing part, and then only start working with a table. But instead of that, to make your work easier, once you've cleansed your table, just export it into a CSV file, so that in future, if you're planning to work on the table, you can directly connect the data from this CSV file. I mean, you needn't spend your time cleansing the table by connecting it from the PDF file. Okay, it's not only table from PDF files that can be exported into CSV files. Any table from any file type, any database, any server can be exported into a CSV file. See, this is my sample superstore. I have orders in my canvas area. Just go inside your worksheet space, right click on your data source name, and here you have an option called export data to CSV. So any such table from any file type or location can be exported into a CSV file. Okay, now we'll be getting into the extract mode of connection. Now, extract is nothing but a local copy or a snapshot of your original data. Okay, it's a snapshot, or we also call it as the local copy of the original data. Or in simple terms, you can also call it as a picture that you click, right? Now, this snapshot or local copy of the original data is going to be saved locally in the folder called My Tableau repository. So we're already familiar with this folder, right? We've been using the bookmarks folder under My Tableau repository. Similarly, under My Tableau repository, you have another folder called Data Sources. Okay, That is where all your, see, the Tableau extract, all the Tableau extract files are going to be saved under this folder called My Tableau repository. Okay. So this local copy that you take of the original data is going to be saved locally within a specific folder. And because of this, you will have a better processing speed. Now, the local copies are not going to be saved automatically. We will have to go click on a save button. Okay, so this is something that's done manually only. If you're planning to work in an extract mode, that is when you'll have to go save your local copy. We'll look into the steps, how that can be done practically as well. Okay, now this is a very, very common interview question. We have two modes of connecting data with Tableau, right? Live and extract. Which is the better one? And if you have a very large data set, live mode is going to give you a slow processing speed. So how are you going to improvise the processing speed in such a scenario, right? That is when we move into the extract mode of connection, right? So what is extract mode all about? Now, why the processing speed is getting affected in a live mode might be because I have a huge data source in some server or cloud, and that's the reason for my processing speed to be affected, right? So in such a case, what you can do, you can go save your local copy. Okay, and by doing that, what is going to happen? A copy of your original data is coming locally within your system in a specific folder. Okay, now this local copy is what would be connected with Tableau, right? That is what is our extract mode of connection. Yes, you have your data. Okay, you take a copy of your data, and this copy is what is connected with Tableau. Whereas in a live mode, you directly have your data that is getting connected with Tableau. Okay, but this is what happens in an extract mode. So we'll be taking a copy of our data, saving it under My Tableau repository, and then connect that copy with Tableau. Okay, because of which you have a better processing speed compared to the live mode. Okay, because now there's no need for an internet connection. The background query is not go all the way to the server or cloud to pull your data. It is simply go into the copy of your data, pull the required columns into Tableau, right? So that is why we say in an extract mode, we have a better processing speed. Now, this is just a general answer that you can give. Okay, so from a general perspective, keeping a few factors in mind, if you have a very large data set, if you don't have a proper internet connection, if you want, your processing speed to be improvised, that is when extract mode is going to be useful. Okay, now in a real-time scenario, there's no mode that this is considered to be as the best one, because we have a lot of changes in the requirements factors in each and every scenario, and accordingly the best mode that suits your requirement will differ. Okay, now I'll list out the factors that you'll have to take into consideration. And there's one more point when extract mode will be of great use: when you're traveling. Okay, so when you're traveling, when you don't have an internet connection, you can make use of your local copy. Okay, might be, for example, see, at 8 a.m. I'm planning to start my travel. Let's say it's a normal travel, or might be in an airplane mode somewhere, but I don't have my internet connection, no hotspot, nothing. Okay, so I don't have my internet connection, but while traveling, I'm planning to analyze my data. I'm planning to work with Tableau. Okay, and my data is present in some cloud or server. So in order to connect the data from cloud or server, we should have an internet connection. Right. So in that case, what I am doing is at 8 a.m., right before I start my travel, okay, before I start, when I have my internet connection, I'm connecting the cloud data with Tableau in an extract manner and saving a copy of my data. Okay, so that for the next 5 to 6 hours when I'm traveling, I can simply work on the copy of my data. Okay, because for that, I'll not need an internet connection. It's anyways present locally in my system. It's just a copy of my cloud data present locally within the system. So you will not be in need of an internet connection for that. right? So that is when we save a local copy using the extract mode. And while traveling, when we don't have access to the original data, we make use of this local copy. Now, just like how data can be refreshed in a live mode, you can also refresh your data in an extract mode as well. Okay. So during which the entire extract gets replaced by a new snapshot of the original data. Now I'll tell you, see, let's say at 10 a.m. in the morning, I've created my copy of data and I'm working with this extract copy for the next 3 to 4 hours. Okay. Now by 2 p.m. in the afternoon, okay, let's say I'm reaching my destination at 10 a.m. I created a copy. And when I was traveling, I was working with this copy. And at 2 p.m., I've reached my destination. So I get back an instant connection. Okay. Now you can refresh your data even in an extract mode. Now at 2 p.m., I feel I have to refresh because there might be a lot of changes done to the original data. I want my worksheets and dashboards also to be updated accordingly, right? So at 2 p.m., I'll go click on the refresh button. This is now in an extract mode. So what will happen is the entire extract. See, I created a copy at 10 a.m., right? So this copy, this is considered to be the old copy. Okay. At 2 p.m., the moment I click on my refresh button, a new copy, a new snapshot of the data will be taken. The old copy will be replaced by this new copy of your original data, right? So you are replacing the old copy with this new copy. New copy is going to have the updated data. So as in turn, your worksheets and dashboards will also get updated. Okay. Now you might have a query. Why should we go take a new copy or a new snapshot when the refresh button is clicked? Why not make changes to the old extract file itself? So when I click on the refresh button, what's happening is the entire extract gets replaced by a new snapshot of the original data. Now let me give you an example. Let's say 10 years back, you clicked a picture of yourself. Okay, you have that in hand now. So that's considered to be an old picture. Okay, so that's how you looked 10 years ago. But now there's someone asking to share a picture of yourself to see how you look right now. Okay, so will you be able to go make changes to an older picture?
Just a quick info, guys. Intellipaat provides Business Intelligence Master's Program in partnership with Microsoft, the course link of which is given in the description below. Now, let's continue with the session.
To edit in such a way, to change it as of how you look right now, that's not possible, right? That's an old picture. To see or to show someone how you currently look like, okay, how you look right now, you'll have to take a new picture and share it, right? So you won't be able to go make changes to an old picture. So you'll have to click a new picture of yourself to see how you look right now, because there might be a lot of changes since 10 years. Okay, or might be you have a house, you had newly built it around 5 years back and you had clicked a picture back then. Okay, now you've made a lot of renovations, the paint color has been changed. Okay, a lot of changes how the house looks right now. Okay, so to show someone how your house looks right now, will you be able to go make changes to an old picture? That's not possible. You have to click a new picture, right? The same concept is happening over here. I had clicked a picture of my data. See, snapshot is nothing but a picture that you click, right? So I had clicked a picture of my data at 10 a.m. in the morning. Now at 2 p.m., I feel there might be some updates done to my data set. Okay, so I won't be able to go make change to an older picture. I can simply click a new picture, replace my older picture by this new picture, which is containing the updated data. So this is how extract refreshes happen in Tableau. Okay, so refresh is on data. Changes are related to dashboards and charts. See, now I have my data. Okay, now how are you building your charts and graphs and dashboards? So I have my data. Using the columns from my data, I'm creating the worksheets, and then I'm creating my dashboards, which are nothing but a collection of worksheets, right? So once you update your data, once you refresh your data, okay, the updates are going to be brought into Tableau's workspace. And just because data is getting updated, the corresponding worksheets also get updated, the corresponding dashboards also get updated. So it's like just one switch that you click on, okay, one refresh button that you click on, data is updated. So because of which the sheets are updated and because of which the dashboards are updated. So all are based on the data that you have in Tableau, right? So once data gets updated, the worksheets, dashboards, everything related to the data also gets updated. You needn't go recreate anything from the scratch. Okay, so that is what is refreshing in an extract mode. Okay, right. So first we'll look into these points practically, and after which we'll definitely get into incremental refresh and full refresh. But first we'll see how to save a local copy practically, how the local copy gets saved under my Tableau repository, and how Tableau refreshes your data in an extract mode. Okay, now I'll tell you, see, if you're having a specific column in a dashboard, and what if that column is deleted in your data set? How is Tableau going to react in such a scenario, right? Now, in general, what will happen is if you're just updating a specific row, adding a specific set of rows to your data, okay, so accordingly, the worksheets and dashboards will automatically change. But in the case of a column is deleted from the data set, we'll see how Tableau is going to react in such a scenario. Okay, so first I'll be working with this Google Sheet. Okay, it's a very simple Google Sheet that I have in my Google account. Okay, the same set of rows and columns that we had when we were discussing about the live mode. Okay, you have row ID, name, sales, date, modified date, and profit. Okay, so this is my Google Sheet, which is going to be connected with Tableau. Okay, so I have Google Sheets somewhere over here, or you can also click on more and look into the alphabetical order and try searching for Google Sheets. And what happens once you click on Google Sheet, you'll be directed to a new browser tab where you'll have to choose your Google account, as in wherever you have your Google Sheet. Get into the Google account and allow Tableau Desktop or permit Tableau Desktop to access your Google account. And by the time you get back to the workbook, you'll have a dialog box where the list of Google Sheets from your Google account are listed out. Okay, so live versus extract sample. This is the one that I'm planning to connect with Tableau. Okay, so just select it and then click on connect. And within a few seconds, you'll be directed to the same data source page. Okay, so I just have one sheet in my Google Sheet with around 5 rows and 6 columns. Okay, so by default, whenever you connect your data with Tableau, the data is going to be connected in a live manner. Okay, you can go inside your worksheet and start working. That's the live mode of connection. See, I'll go inside my worksheet. I'll try creating my charts and graphs. Okay, right? So that would be a live mode of connection. To refresh your data in a live mode, you'll have to right click on your data source name. And this is the refresh button using which your live data can be refreshed. Okay, and there's a single cylinder. These are some minute points you'll have to observe or make a note. Okay, so there's this single cylinder that appears right next to the data source name. So single cylinder is an indication. It's something that is representing that your data has been connected with Tableau in a live mode, in a live manner. Okay, this would change when you move into an extract mode of connection. Okay. So I'll go into my data source page. Now, you have your live connection and you have your extract radio button over here. Okay, so live and extract modes, toggling between live and extract mode is something that's not available in Tableau Public. Okay, so now I'll tell you, see, live is the default mode of connecting data with Tableau. But if you want to work in an extract mode, just go click on this radio button called extract. Step 1, click on the radio button called extract. And then what is the next step we normally do? We have to go inside our worksheet space to start converting data into graphical representations. So I'll go click on sheet number 1. Okay. So when I go click on sheet number 1, it is not going to be direct. It is not going to direct me to sheet 1, but instead you will have a dialog box that would appear, okay, which says save extract as. Okay, so Tableau is trying to tell you, see, you wanted to work in an extract mode of connection, right? You clicked on the extract radio button. So in order to work, in order to go inside your worksheet, okay, and work with data in an extract mode, you will first have to save a local copy in your local system. Only when you save your local copy under My Tableau repository, that would be connected with your workbook, with which you can proceed with your visualization work. Okay, so the moment you move into an extract mode of connection, and then when you try going into the worksheet or dashboard space, Tableau will definitely pop this dialog box up known as the Save Extract dialog box. Okay, and I hope you remember .hyper was the file type, okay, for Tableau data extract files or local copies. .hyper is the file extension. So this is where Tableau is asking you to save your local copy using the .hyper file type. So let's save it, okay, locally under My Tableau repository. I'll be naming it as my first new extract file. Okay, right? So this is how I'm naming it, my first new extract file. Okay, as a .hyper file. This is nothing but a snapshot or a copy of your original data that is getting saved under My Tableau repository. Okay, just click on save. Okay, the local copy will be saved, and within a few seconds, you'll automatically be directed to the worksheet space. And now when you look into the symbol right next to the data source name, you have a dual cylinder. For a live connection, you'll have a single cylinder, whereas for a for an extract mode, you will have a dual cylinder. Dual cylinder is nothing but it's trying to tell you, see, the first cylinder is considered to be the original data source. The second cylinder is considered to be a copy of the original data source with which you are right now working in Tableau. Okay, so under My Tableau repository, see, this is My Tableau repository within which you have a folder called data sources, and our extract file has been saved. Now it's exactly at 7:26 a.m. Okay, the timestamp, making a note of the timestamp is very important. So it's as per 7:26 a.m. Okay, I have all the data. However, the data looked like at 7:26 a.m. I have it in my local copy saved under My Tableau repository. So now this local copy is what is connected with my workbook. Now, even if I cut off my internet connection, and I'll still be able to work with this Google Sheet data because the copy of that data is available locally in my system. Okay, so that's how we approach an extract mode of connection. Okay, so now we are in an extract mode, and I'm planning to work in an extract mode just like the other day. We have row ID, we have name, okay, we have sales, and we also have profit. Okay, so this is a very simple table that I've created, and I'm trying to visualize my data. Okay, now meanwhile, what's happening is we have the database team who's making changes to the original data. Okay, let's say they are adding a new row, okay, with some sample data, right? Let's say this data is being added on 1st of November 2021. So initially, the date and the modified date will absolutely be the same, right? So I have my new row that has been added up, okay, with some sample data on 1st of November. And on the same day, I'm also making some changes to the existing data. Might be row number 1, you have a drastic increase in sales, okay, and the profit value as well. So whenever we make changes, whenever we modify any existing row, we'll have to make sure we update the modified data as well. Okay, so now what have we done with the original data? We've made change to an existing row, and we've also added a new row with row ID 6. Okay, right? So whenever you've made the necessary changes or updates in your data source, in your original data source, you'll have to go click on the save button, right? I hope you remember in our last class, we were working with an Excel file. So we discussed about this point. After your changes have been made, make sure to save the changes. Okay, just click on File, Save. Now, as this is a Google Sheet, I needn't manually save my changes. Google Sheet is, saving my changes automatically. But, if you're working with any other database or file, make sure to save the changes then and there. Okay, after the changes have been saved, going back to Tableau, I've been working with some data. See, I still have only 5 rows of data. I've been analyzing this set of data. And I feel, okay, there might be changes done to the original data set. Why don't we simply refresh and bring those changes also into Tableau's workspace? Let's, get the updated data and keep working on it, right? So normally, how do we refresh? Right click on your data source name, click on the refresh button, but there's nothing that's happening to my worksheet. We still have only 5 rows. The 6th row has not been brought in. The change made to first row is not being brought in. What's happening, right? See, when you right click on your data source name, this refresh button that you have is only going to work for a live mode of connection. But right now, are we on a live mode? No, we are in an extract mode of connection, right? So to refresh the data in an extract mode, you'll have to go all the way down, right click on your data source and go all the way down to this option called extract, under which you have the refresh button. Okay, so you're telling Tableau, refresh my extract. So now, see, the time is 7:33 a.m. exactly. Okay, so at this moment, when I click on the refresh button, a new snapshot will be clicked at 7:33 a.m. Okay.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Now, when you go into the data source page, there's this line which tells you, see, extract includes all the data till 7:33 a.m. This moment, when I went and clicked on the refresh button, at that moment, a new snapshot has been taken, replacing the older snapshot that was clicked at 7:26 a.m. See, my Tableau repository folder is having the 7:26 a.m. snapshot. So this old snapshot has been replaced and a new snapshot that was clicked at this moment when I tried refreshing my data, this new snapshot has been replaced instead of my old snapshot. So this is something that's having the updated data. You have the 6th row, you have the change made to an existing row. All such changes or updates are brought into Tableau's workspace when we tried clicking on the extract refresh button. Right click on your data source, get into extract, and under which you have a refresh button. So this is what is happening. A new snapshot has been taken, replacing the older snapshot. This is what is happening in an extract mode when you click on the refresh button. Okay. Now, I've already been working in an extract mode. Now I'm planning to get back to my live mode. You can just click on this radio button. So you can very easily toggle between live and extract. Okay. And after some time, I'm once again planning to move into an extract mode. This time, what will happen is Tableau will automatically pick up the last extract that you had saved previously. You can directly go into your worksheet space. It is not popping up the save extract as dialog box. Why? Because in a workbook of Tableau, only for the very first time you go into an extract mode of connection, Tableau will pop up the save extract as dialog box. For the second or third time or nth time, if you simply toggle between live and extract modes, Tableau is not going to pop up the save extract dialog box every time. So in a workbook, only for the first time you go into an extract mode, Tableau will pop up the save extract as dialog box. Okay, so now as per the points that we have over here, my local copy or snapshot is getting saved locally under my Tableau repository. Yes, so the first snapshot that was clicked at 7:26 a.m. is definitely available. It's still available in my Tableau repository. Okay, see at 7:26 we did click on the save extract as dialog box, save button. That is when my first extract was saved at 7:26 a.m. But after that, around 2 to 3 times we've refreshed the data, and while refreshing what's happening, a new snapshot has been taken, replacing the older snapshot. So now we are more bothered about the latest snapshot containing the updated data. We are no longer bothered about the older snapshots because anyways they'll have older data. Okay, so the first snapshot that you are taking, yes, it is available under my Tableau repository, but how about the other snapshots? When you click on the refresh button, new snapshots are taken, but where do we have these hyperfiles? Hyperfiles are nothing but copies, local copies are saved using .hyper file extension. Where do we go find these local copies? See, this is my Tableau repository. Okay, so we don't have the local copies over here, do we? See, you have 7:26 a.m., 28th of December, 7:26 a.m. Yes, you have your first local copy, but just look into my Tableau repository. There's no other. This is something else. The date is something else. But apart from that, you don't have any other. See, the 7:33, 7:38, 7:46, none of these refreshed snapshots are available over here. Okay, how come that's possible? I mean, where do we have those physical files then? Where do we have these .hyper files? It's only the first extract that is getting saved under my Tableau repository. Where do we have these refreshed extract files? We have it in the temporary folder of our system. Okay, so the first time you go save a local copy, Tableau saves it under my Tableau repository. But every time you click on the refresh button, a new snapshot is being taken, replacing the older snapshot, right? So these new snapshots that are taken when you click on the refresh button are going to be temporarily available in the temporary folder of your system. Okay, you can just get into the temporary folder of your system by typing mod or the percentage symbol, TEM3, and the mod symbol again. Okay, so this is how you access or get into the temporary folder of your system, or you'll have it in your C drive under users. Okay, so just get into the temporary folder of your system, within which you will have a separate folder that's just meant for Tableau. You have something called Tableau temp. Okay, this is a folder which is specifically meant for the temporary files related to Tableau. Okay, so get into Tableau temp, and that is where you have all your snapshots taken when you had clicked on the refresh button. Okay, so just scroll all the way down. Now, this is where you'll be able to see the 7:38 a.m. Tableau extract file, 7:33 a.m. Tableau extract file, and the latest one, 7:46 a.m. Tableau extract file. So whenever you click on the refresh button in an extract mode, a new snapshot is being taken. Yes, replacing the older snapshot. Okay, but this new snapshot that has been taken, the physical file, the .hyper file, is available in the temporary folder of your system. Now, why is Tableau doing this? Why can't it save all our snapshots under my Tableau repository? Why is it saving them in the temporary folder of our system? See, now you can just imagine. Now I've connected my data at 8 a.m. Okay, the first extract that I have, extract number 1, has been saved under my Tableau repository because that was the first time I'm moving into an extract mode of connection in that particular workbook. Okay, and after that, every 1 hour once at 9 a.m., 10 a.m., and so on, every 1 hour once till 6 p.m. in the evening, I've been clicking on the refresh button. Okay, so every 1 hour once, when you click on refresh, what would happen? A new snapshot will be taken, replacing the older snapshot. So this is what is happening. Every 1 hour once, a new snapshot is being taken. Now just imagine if all these snapshots that are clicked every time you click on the refresh button, if all of these snapshots are going to go into my Tableau repository, what will happen? Your Tableau repository folder will be overcrowded, right? See, now at 6 p.m. in the evening, you have your extract, you have your latest extract. So that's the latest. It is 6 p.m. right now. So that's the latest extract you have. Now, at this point, will you ever be bothered about the 10 a.m. extract or the 2 p.m. extract? Not at all, right? Because they are anyways going to have older data. I have the latest data in hand, which is the 6 p.m. extract. So we are always bothered about the latest or updated data that we have in hand currently. We will no longer be bothered about the 9 a.m. extract, the 11 a.m. extract, the older data extract. We will not be bothered about them. Okay, so in such a case, there's no point in saving them under my Tableau repository because anyways, you won't be in need of them in future as you keep getting your latest extracts, right? So for that reason, to avoid overcrowding of my Tableau repository, this procedure is being followed. Okay, so whenever you have a refresh, a new snapshot is taken, replacing the older snapshot, but the actual hyperfile of this new snapshot is going to be placed in the temporary folder of your system. Okay, now just imagine, see, every time I click on the refresh button, yes, new snapshots are placed in the temporary folder of our system. But what if I want one of those snapshots for later use? Okay, might be now we'll do that. See, it's 7:58 a.m. now. I'll click on my refresh button. So a new snapshot is getting created, replacing the older snapshot. It's taking a little time for that. Okay, and within a few seconds, you'll get, okay, it's 7:59 a.m. now. So it is trying to save a new snapshot at this moment, replacing the older data. Okay, might be I'll just go back to the same button. This is a little more quicker. Okay, so now it's 7:59 a.m. I've clicked on the refresh button, and yes, a new snapshot has been taken at 7:59 a.m. So this is my latest snapshot, right? Now, will you ever be bothered about the older ones that we have? Not at all, because I have the latest data, in a snapshot that was clicked most recently at 7:59 a.m. Okay, but where do we have this file? We have this file in the temporary folder of our system. Where is that? Yeah, we have it in the temporary folder. 7:59 a.m. snapshot is available in the temporary folder. Now see, the nature of temporary folder is like, it depends upon your settings. Now in my case, what happens is within a week, I mean once a week, my temporary files gets cleared. Or you might also have every day, by the end of the day, your temporary files are going to be automatically deleted, right? So normally temporary folder, the name itself tells you, just for a short span of time or some specific span of time, you will have the files that are stored in the temporary folder, and gradually as new files come in, the older files get deleted. Okay, but 7:59 a.m. extract that I have is the latest one. I want to fetch this 7:59 a.m. extract and save it, under my Tableau repository, because I'm planning to use it for later use, as in might be tomorrow morning. I want to work with this 7:59 a.m. snapshot, and I might lose it because it's right now present in the temporary folder. How do I go pull a file from the temporary folder and save it, in my Tableau repository so that I can use it later? So if that is your scenario, if that is your requirement, all you have to do is just get into the temporary folder, double click on the extract file that you are planning to save for later use. Just double click on it. You will have a new workbook that will open up with the extract file, the data in that local copy connected. See, we have it over here. Okay, see, this is my extract. You have a particular number, the temporary file, the extract that was clicked at 7:59 a.m. That local copy is what is now connected with my workbook. How do I open it up? I went into my temporary folder and I just double clicked on whichever extract file I'm planning to pull and save it in Tableau repository folder for later use. I've just double clicked on it and this is how it opens up. In order to save the data inside it under my Tableau repository, what you'll have to do, you'll have to go into the extract mode. So this is a workbook. For the very first time, I'm going into an extract mode, and then I'll click on sheet number 1, during which Tableau will pop this box up. Okay, so now you can name it accordingly. You can call it as the most recent or latest extract, however you would like to. Okay, just save it under my Tableau repository. So this is how, if in case your refreshed snapshot that's available in the temporary folder, which might get deleted after a specific span of time. If you're planning to go pull it, save it permanently or save it for later use under my Tableau repository, this is how you do it. Okay.
So in Tableau, you can sort your data either in ascending or descending order by any of these 3 options, that is based on data source order. By default, when you are loading the data from any of your data sources, it would be arranged in the data source order. So you can change it later through alphabetical order or even based on the order of the data based on the associated values of another fields. That is, in Tableau, we have 2 types of sorting. So you can sort your data either based on computed sorting or you can go for manual sorting. Computed sorting is the sort which is directly applied on the axis using a sort dialog button. And manual sorting is used to rearrange the order of dimension fields by dragging them next to each other in an ad hoc fashion. That is, when you go for a computed sorting, you choose the sorting based on the corresponding fields and the aggregation methods. If you go for the manual sorting, you have the up and down arrows where you can sort the values based on your own requirements. Let's go for a live demo to see how sorting can be applied on Tableau. So I'm connecting to sample superstore dataset. So here I'm going to take the customer name and sales. The default option, as I told you, by default it is sorted in data source order or the alphabetical order. So you can change the sorting either ascending or descending based upon the measure value which is referred on the view. So here on the measure axis you have a small sort symbol. So you can click on the sort symbol to sort your graph either ascending or descending. You also have the same sorting option to sort it ascending order or descending order in your toolbars as well. So here also you can use your sort option to sort your data in descending or in ascending order. So these are the default sorting methods where you can sort your data either ascending or in descending order. As I said, if you want to sort your view based on computed sorting method, click on the dimensions, go for sort dialog box, click on the sort option. So this is the sort dialog box where you have the sort order. Either you can choose ascending or descending. You can, by default, as I said, it is sorted by data source order. If you want to change it to alphabetic, change it to alphabetic or go by field option. So in this you can choose the various fields as well as aggregation. For example, if here I am showing the sales of each customer on my bar graph. If I want to sort this graph based on profit, that is average of profit, I choose profit and aggregation average. Now I am sorting the graph in descending order based on average of profit. Now my graph is sorted based on average of profit even though I show customer sales on my view. So this method is called as computed sorting. The next type of sorting available in Tableau is manual sorting. For example, if I choose the order date and profit, if I want to manually sort this year of order date, then I go for sort option. I go for a manual sort and I choose what needs to be on the top and what needs to be on the down. So this order is based on my own requirements. I manually sort my values. So this is referred as manual sorting. In case if you have multiple dimensions, for example, category, subcategory. Here I have two dimensions, category, subcategory and profit. So when you have multiple dimensions, you would be able to sort your graph based on individual panes. That is, each individual category has some subcategory of products. This is referred as panes. So I can sort my pane individually by clicking on particular value. I have the sorting option. So either you can go for sorting by ascending order or you choose descending order. You can also choose different sorting order based on different values in the pane. So this can be used when you use multiple dimensions. So these are the sorting methods available in Tableau. That is, you can sort your graph based on computed sorting, manual sorting, as well as you can also go for, when you have two dimensions, you can sort it based on individual panes as well.
So we'll start with filters. Okay, now what are filters? Okay, as you can see, you have a filter shelf which is available over here, and we had already discussed a little about how our dimensions and measures work inside filters, right? So what is the use of these filters? Why do we need them, right? It just narrows the data shown in your view, okay, so that you can focus only on the relevant information as per your requirement. For example, I might have different ship modes, okay, but I would like to retrieve the information of only the first class ship mode or only same day ship mode or anything of your choice. So during such cases, instead of going through all the ship modes, I can just try and choose one particular ship mode. I can filter out the others and focus on only the relevant information. Okay, and this shelf over here, it also allows you whether you need your data that you have mentioned in your filter to be excluded or included, right? I have placed my ship mode inside filter,
Okay, in case I want the information only regarding first class, I can check this box. Or if I want information of all the other ship modes excluding first class, I can either check the other three boxes. Okay, this is one way. Or an easier method is I'll check the first class, which I don't want to include in my view, and I'll go click this exclude button over here. So now as you can see, the first class has been striked out, which means I am excluding the information, the member which has been checked, whose box has been checked. So now I will be getting the information of all the other ship modes. So this filter shelf allows me to either exclude or include data in my view. Okay, and whenever you try to filter a field, you can choose any filter or any measure, any dimension on any measure into your filter shelf. And if you have applied a filter to any particular dimension on measure, that field will be displayed inside this shelf over here. For example, I have my category. I'm just dragging it and placing it into my filter shelf. I want information only about furniture and technology. Apply and OK. Now my category is placed inside the filter. So with this, I can identify that my category dimension, there's some filter being applied in this particular dimension. Okay, and we have a particular order in which the filtering is executed. Okay, we have 5 different types of filters. We have extract filters, we have data source filters, we have context filter, we have dimension filter, and we have measure filter. Okay, so what is an extract filter? As the name tells you, it filters the extracted data from the data source, right? So, and similarly, what is a data source filter? Data source filter, the filter will be applied right into your data source before you get the information, the data from your data source itself. Okay, so that is all about the data source filters.
Just a quick info, guys. Intellipaat provides Tableau online training and certification course mentored by industry experts. The course link of which is given in the description below. Now, let's continue with the session.
Measures filter. So now what does this context filter, what is it all about? So sometimes there might be a scenario where you have 2 dimension filters or 2 measure filters or any 2 filters of the same type, right? So I'll have my category being filtered. I want only technology information. And similarly, I'll have my ship mode also inside my filter. I'll need only my first class and second class. Okay. So when you have, more than more than 1, 2, or 3 different types of filters inside your filter shelf. Now, how does this get executed? So we have the order of execution, okay, or the order of operations in which filter is being executed. So first, the extract filter will be executed. Any filter that you have applied to your extract will be executed. Then any filter that you have been applied to your data source will be executed. Then we have something called context filter, and then the dimension filter, and then finally we have the measure filter. But in this case, we have 2 dimension filter. So now which dimension filter will be executed first, right? Tableau will get confused and it will provide a completely different view which we do not expect, right? Because I want the category to be filtered first, and then under this technology category that I have included in my view, I want the ship mode to be filtered. But Tableau considers both these filters as the dimension filters itself. The order in which your filters are visible, the order in which your dimensions are visible in this shelf does not play a role. like what I'm trying to say is, since I have my category on top and then I have my ship mode, it doesn't mean that category filter will be executed first and after which ship mode filter will be executed. Tableau considers both as dimension filters and they will be executed at the same time. Now, in order to solve this problem, okay, in order to solve this confusion, we will assign one dimension filter as the context filter. So by doing that, we are telling, according to the order of operations, the dimension filter will be executed only after the context filter. So in this example, I will change my, dimension filter. I'll say add to context. By doing this, okay, there's a color change, which means this is my context filter. This will be executed first, and then my ship mode, which is my dimension filter, will be executed. So these are the order of operations, and this is what we can do when we have a problem. When we have two similar type of filters, we can try using this option in order to avoid confusion, right? And these are the different types of filters, and we'll just see how to use filters, okay, and all about these extract, data source filters, context, dimension, and measure. Now I'll just tell you what is all about internal and external filters. Okay, so if I have, say, my segment in my filter, right? I have three different segments. I want only home office and consumer to be filtered. I'm not excluding it, I'm including home office and consumer. Okay, I'll click apply and okay. Now I am going to bring my segment in my columns, okay, and I'll bring my profit inside rows. So as you can see, it has been filtered. The segment, my corporate segment, is not being visible over here. Okay, so we have removed one segment type from the view by filtering segment dimension. Okay, and you can also try to show the filter. You can show this filter, and by this you have created an intent filter. The user themselves can change the filtering options. Okay, so you can either create a filter for any dimension by dragging it inside the filter shelf, okay, or else you can also choose this drop down option over here, and you can say, you can there'll be an option. Since I have already filtered, you can choose the filter option from this drop down box, or it is always better you just drag it into your filters shelf. Okay, and so now we have segment inside our view. Inside our view, in the sense, segment is a dimension which is placed in either the row and column, and we are filtering the view in terms of a dimension which is already present in our view. So this is known as an internal filter, right? So when your dimension or measure is a part of the view itself.
Just a quick info, guys. Intellipaat provides Business Intelligence Master's Program in partnership with Microsoft, the course link of which is given in the description below. Now, let's continue with the session.
Okay, it is known as an internal filter. Now, what do you mean by external filter? Okay, so if I want, I'll just remove this. Okay, so now I have my segment and profit, no filters, right? So now if I want to see the profit for any one particular category of products, okay, though my category is not a part of the view. So right now I have only my segment and profit in my view. Okay, I'll just drag my category into filter shelf. I'll say only technology or only furniture, any one option, and I'll apply. There's a change in the bar chart over here. Okay, so my chart has been changed according to the filter that I have applied. It's a category filter, it's a dimension filter, but my category is a dimension not present inside the view, right? Though it is not present inside the view, I have used it to filter the information which is being displayed in the view. Now this is known as an external filter. So when you have your dimension in your view and you're trying to filter that dimension, it becomes an internal filter. And when you try to filter out the information in your view with a dimension which does not belong to your view itself, it becomes your external filter, right? So this is all about your internal and external filter. And I'll just tell you about the tabs. So I'll have my subcategory inside filters. So now as you can see, we have 4 different tabs. We have the general tab, we have wildcard, we have condition and top. Okay, so general is nothing but you have 3 options. You have to select from a particular list. You have the list of all the subcategories in this dimension. You can keep choosing from the list. You can enter, particular subcategory name in order to search it, or you can select all the values or select none of the values with these options. Similarly, you have custom value list. You can manually type in your the subcategories to be filtered out or included or exclude from the filter. Okay, you can manually type in the subcategories over here, and use all will automatically use all the subcategories present inside the filter option. I mean, if present inside this particular field. Okay, so this is all about your general tab, and you have a summary of what are the filter options that you've been used so far. So the field name, you have selected 0 of 17 values, and it keeps changing as you keep selecting. Okay, and this is about the general tab. Okay, and your wildcard tab is nothing but you can filter using these 4 options mentioned over here, right? So for example, I have subcategories containing, let's say, A, B, L, E. So this is something that my subcategories contain, right? So if any of my subcategory name contains this 4 alphabets over here, okay, this particular text over here, this string, if any of my subcategory contains these strings, it will be displayed in my view. Let's just try that. Click on apply and okay. So right now we'll just clear the sheet. Okay, I'll have my subcategory. Okay, yes, I'll again bring it to my filters. I'll go into wildcard and I'll say this is the text, apply and okay. Now when I bring my subcategory in my view, okay, so tables is the only subcategory with a string that I had mentioned. So when I remove this filter, I have all these subcategories. Okay, let's try one more. I'll say if my has A and B together, so that text together, what happens? I'll go into wildcard tab, I'll say A, B, apply and okay. Now we have only labels and tables, okay, which had A and B string. So with it, you can also filter out the information using these options as well, right? And similarly, we have something called starts with. So whichever alphabet you want the subcategories to be displayed, which starts with any particular alphabet, let's say, okay, starts with A, apply and okay. And as you can see, all the subcategories starting with A is displayed. Similarly, you have something called ends with, let's say, S, apply and okay. All the subcategories which ends with S, are displayed over here. And similarly, the last one that we have is exactly matches. So now I should type in category, a subcategory name which exactly matches. If I say table, apply and okay, there's nothing that is going to be displayed because it should exactly match my subcategory name. So when I say tables, So this is when this particular subcategory will be displayed. Okay, this is all about your wildcard tab, right? So, and we have something called the condition tab. So by field, so this I can assign a condition by which my filter is to be performed, right? I can choose any particular field, let's say by sales, and aggregation can be chosen from these options. Okay, and your sales, you can just use this load option over here to load in the minimum and maximum values of my sales, of my sum of sales, right? So with the help of these minimum and maximum values, you will have an idea, as in please filter out or please display only those sales which are greater than, let's say, around 50,000. So with the help of this minimum and maximum value, this just gives me the range of values of my sum of sales for me to decide on what value I can mention over here in order to filter it out. Okay. So now this is just the same. If I say by formula, I will be typing in the exact formula, sum of sales greater than 50,000 inside this formula box. So both works the same way, right? And we have something called the top tab. So if I want to filter out the data, let's say I want to see the top 10 sales by sum of sales, okay? And I'll say apply. Okay, I should choose this. Okay, none over here. And I'll go to my top and I'll say top 10 by sum of sales. Okay, just apply and okay. So right now I have my subcategory. I should just apply a filter top 10 by, I'll have my sales. Okay, so as you can see, first I'll sort it out and I want to display only the top 10, or let's say only the top 5. Now how do I do that? I'll bring my subcategory inside filters, go to top, by field, top 10 by the sum of sales. So just click on apply and okay. You will be displayed only the top 10 sales. That is why I sorted out in a descending order. So only the top 10 by the sum of sales measure will be displayed in your view, right? You can also try and change this. You can also say as bottom 10. So the least 10 subcategories by sum of sales will be displayed, right? So this is how you try to filter out using the different tabs available in the filter shelf, or the filter dialog box, right? We'll be starting with calculations and expressions. We will look into what are LOD expressions, and we'll also discuss about groups. We'll go into our workbook, okay? And we just went through how to create a calculated field and how you can just go through the list of inbuilt calculations and functions that are available in Tableau with the corresponding syntax, with an explanation of what it does, and with an appropriate example, right? So today we'll see what are the different table calculations, and we have something called quick table calculations. How can a quick table calculation be quickly applied to our table, right? So for that, let me just create a text table first, right? Now let's have our order date in terms of years in our column, okay? Next, we'll have our order date, okay, in our rows as well. But this time I'll just click on this drop down arrow and I'll choose the discrete quarters of order date. And then when I drill down, now this is the table that we have tried to visualize. We have the different years that we have in the order date dimension. And we also have the different quarters and the corresponding months under each quarter, right? Now let me just expand this a little bit, and you can also format it. We shall increase the font, right? Yes. And then we shall place the value of sales in the text part, right? So now this is a simple table that we have visualized. Now let's try applying the table calculations one by one on this table, and let's see what are the different ways of computing, what are the various options available in the edit table calculation dialog box, right? So when you click on this drop down arrow right next to your measure, right in the pill of your measure, okay, you have this option called quick table calculation. Now you can apply quick table calculations only on measures. Okay, just click on this drop down arrow and you have this option called quick table calculation, and this is the list of the quick table calculations. They are nothing but table calculations which can be quickly applied to your table, right? So that is why we call it as a quick table calculation. Now let me say I would like to find the running total of sales. Okay, and this is how the running total of sales is calculated, right? So when you look into the values, we have January 2015, and when it comes to February, we have the value of January that is summed up with February, and the sum of both is placed, I'm sorry, not of February. This is done in a horizontal manner, right? Which means it moves from January 2015 to January 2016 to January 2017, and finally the sum of all the 4 Januaries is placed in this last column, first row of last column, which is nothing but January 2018, right? And similarly for February, we have 4,000, which is summed up with the value of February 2016, and the sum of both the Februaries, which belongs to 2015 and 16, is placed over here. And then it moves ahead, and the final value, which is the sum of February 2015, 16, 17 plus 18, is placed in the second row of the last column, right? So this is one way. This is the horizontal way in which your running total is calculated. Now you can change the way your calculation is getting computed, right? Or the direction in which your calculation is getting computed, right? Now, when you click on this drop down arrow, you have an option, you have a separate option which appears now, and this is known as the compute using, right? Now, basically, table calculations are defined by how they are partitioned or grouped and how they are addressed. Addressed is nothing but how they are computed or in which direction they are computed, right? Now, when you click, now by default, it is computed in a horizontal manner, okay? Table across the table, the calculation is computed, and this is the by default way of your calculation by which it gets computed, okay? When I click on table down way of computing, okay, now there's a vertical manner from top to bottom in which the calculation gets computed or the running total is calculated, right? So for the year of 2015, we have January value, we have February value summed up with January value that is placed over here. Then we have the first 3 months sales value, which is placed in this March, and so on. This goes on till December 2015, right? So every column, you can just verify this, click on analysis, you can go into totals and say show column grand totals, right? So that you'll be able to clearly verify that table down, computing any calculation or for example, running total calculation in a table down manner is equal to the grand column total that we have calculated and displayed in our worksheet, right? So this is table down way of computing. Let's try the table across. Okay. Now, when it comes to the table across way of computing, when you try to display the row grand total, you'll be able to see how the row grand total matches up with the last column values over here, because the running total is calculated in a horizontal manner across every row, right? So that is why we just verified it with the column grand total and the row grand total, right? You can just remove them. And I also have, now let me just tell you about the next way of computing. Now it was table across, which moves in a horizontal manner from left to right across the table, right? Then we have the table down way of computing. It moves from top to bottom in a vertical manner, okay? And then we have table across, then down. Now this is table across. First it moves in a horizontal manner, then it moves to the first column of the next row, and again it moves in a horizontal manner, right? So I have a simple diagram for this with which you'll be able to understand. Yes, table across is nothing but it is just in a horizontal manner from left to right. Okay, table down is in a vertical manner from top to bottom. Then we have table across, then down, which means it moves in a table across manner, then moves on to the first column of the next row, and then moves again in a horizontal manner across the table, and then goes down to the next row of the first column, right? And this goes on, and the final value is placed in this last row of the last column, which means in our example, the final value is placed in December 2018. So the summation of all the values that we have in our data set for all the different months and all the different years, this is the final sales value that is placed right here in the last row of the last column, right? This is computing using table across, then down. And similarly, we have table down, then across, right? Now this might look meaningful because it moves in a vertical manner from top to bottom, and it carries on this summed value of the first year to the starting of the next year, and this goes on, and the final summation of the entire values in this table is placed in the last row of the last column, which is nothing but December 2018. And when you look into this diagram, this is how table down then across way of computing is carried out. It moves in a vertical manner from top to bottom first, which is table down. Then it moves across to the first row of the next column, right? And then again it moves in a downward direction, and this goes on till it finally reaches the last row of the last column, which will contain the sum of the entire values of whatever is present in this table, right? Where we will use this. Yeah, when you need to calculate the sales or profit that your organization has done, might be you would like to compare what is the total sales done in every year. When it comes to when you have 4 different years, you can just try calculating. You can either show the column grand total. Yes, definitely. Both results are the same in the sense table across, then down, table down, then across, right? I think you're talking about these two. Okay, now when it comes to table across, then down, the way the final value might be the same, right? But the way you're calculating differs, right? Now in this way of computing, which is table across, then down, so you can simply compare of how it moves in a horizontal manner, right? So month by month you can keep calculating, and you can also apply a secondary calculation on this, right? So we'll look into that. And when you look into table down then across, you can clearly understand what is the total value of sales at the end of the first year and what has happened at the end of the second year. So far for these 2 years, what is the total value of sales, and so on. You can just, totally depends on your requirement. Though both the final values of both these way of computing the calculation is the same, the method and the way it gets calculated is completely different, right? So yes, it all depends upon your requirement. If you have any such requirement in your real-time scenario, then you just have this option that you can go ahead, right? So this was about the first 4 ways of computing, right? And just like these, we have pane down, pane across, then down, pane down, then across. Now, what is a pane? Pane is nothing but the sub-partition that we have. Okay, this is the quarter 1, this is quarter 2, quarter 3, and quarter 4. Now, we have computed it using pane down, which means the value of the first 3 months of quarter 1, the summation of quarter 1 of 2015 is placed over here. The summation of all the sales value of 2016 of quarter 1 is placed over here, right? So this is something like a subtotal that we have when you compute it using the pane down option. And then we have pane across, then down. Now across, then down, this is again, it moves first in a horizontal manner, moves to the first column of the next row, and this way of computing is done till the end of the first pane, right? So till the end of Q1, which is March of 2018, we have this running total which is carried on, and after which it freshly starts from the April month of next quarter of 2015, right? So this is, you're computing it for every pane, for every quarter. You are simply computing it either pane down then across or pane across then down, right? And this was the way of computing, and you can just look into these diagrams. I'll be sharing this file as well. Okay, now let's try applying the next, and you can clear your table calculation with just one click. Okay, you have an option called clear table calculation. Only when you have already applied any quick table calculation, you will have the option to clear the table calculation, right? And next comes difference. This is how the difference between two values get calculated. Now, why is the first column completely left blank, right? Now, whenever you would like to calculate a difference, you need two numbers, right? Only then you will be able to calculate a difference between these two numbers. So when it comes to difference, we have an extra option over here called relative to, right? And by default, relative to is previous, and by default, compute using is table across, right?
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Calculate the difference from, and that is why it is left blank. And then when you look into the next year of 2016, a difference has been calculated between 2016 and 15, and the result is placed in this column, in the second column under 2016, right? So this is how your difference is getting calculated relative to the previous value. Whatever previous value is present in front of it, according to that, your difference is getting calculated. Now, what if we say relative to next value, right? Now, 2015 has a next value. So yes, a difference is calculated and placed in the first column, and this goes on. But when you look into the year 2018, you do not have the next year from which the difference can be calculated, right? So that is why 2018 is completely left blank, okay? And next comes the first and last, right? Now, when I click on first, so we do not have a blank first column. We have the first column which is completely filled with 0, right? This is because we are calculating the difference from the first value, right? So which means first value, the difference between the first value and the first value is 0. The difference between the second value and the first value is so and so, right? So every column is compared, is using the first column in order to calculate the difference, right? And similarly, when I say relative to the last column, we will have the last column which is left, displayed as 0, because last column subtracted with the last column is again 0, right? So these are a few ways by which you can calculate the difference between any two numbers, okay? And you can change how, in what manner or between which numbers you are calculating the difference from, right? And with one click over here called clear table calculation, you can simply clear whatever calculation you had applied onto your table, right? And then comes the percent difference. Now this is very similar to difference. Now the only change is that your difference will be represented in a percentage format, right? So that's the small change when it comes to percentage difference. And you again have relative to options that you can choose from, right? Next we have percent of total, right? Now when I say percent of total and it is computed using table across, which is the default manner of computing your calculations, right? So when I say percent of total, so out of a total of 100%, okay, what is the contribution of this particular year which belongs to, or this particular month which belongs to 2015, 16, 17 or 18, right? Now let's try, I'll just change the way it is getting computed, right? Now when I try to show the column grand total, you'll be able to see we have, when you sum up all these values, you will arrive at a total of 100%, which means out of my total, which is 100%, what is the contribution of each month in every year, right? So by doing this, I'll be clearly able to see that in the year 2015, it is September month which has done the highest or contributed highest towards the total value of sales. And similarly, when it comes to 2016, we have the month of November, which has contributed the highest value or the highest amount of sales when you look into the total sales, right? So this is just the percentage, the contribution of this particular month out of 100%, right? So which means when you simply sum up all these values, you will arrive at a total of 100%, right? So this is how you make use of the percent of total calculation, right? Then we have rank, okay, just with a few rows and a few columns, and we have 5 different functions under rank. We have rank, rank modified, rank unique, rank dense, rank percentile, and the simple rank. So we'll just go through rank right after we complete the remaining options that we have that you can apply, that you can make use of in while using your table calculations, right? Then we have percentile, right? Now when you say percentile, now it is computed using a table across option, right? So it is in a horizontal manner. The least is given 0%, the highest is given 100%, and in between values are given equal percentages according to their contribution to the total value of sales, right? Now let me just change the way it is getting computed. Let's go ahead with table down. Now when you look into this, when you sum up the entire rows of my first column, you will not arrive at a total of 100%, because this is the percentile calculation, which means the highest of all is given 100%, the least of all is given 0%, and all the others out of 100%, whatever is the contribution of each month is clearly specified in this as a result of this calculation, right? So every single month is calculated as of what is its contribution out of the total, out of 100%, right? So this is not something like the percent of total. There's a small change between percent of total and percentile calculation that you can make use in Tableau, right? Now next we have our moving average. Now when it comes to moving average, we have 2 different types of moving average. We have the simple moving average and we have exponential moving average. And simple moving average, I'll create a separate table for that, and I'll explain what is moving average all about. And when it comes to exponential moving average, that is the inbuilt forecasting tool that we have. Yes, I think you're asking about the forecasting. Can we predict Q4 based on 3/4 percentile? 3/4 percentile. Now prediction, it comes under, I think you're talking about forecasting. Yes, definitely we can forecast values, but you should have enough historical data, okay, in order to forecast values. So yes, we'll be looking into detail about forecasting as well. So yes, definitely. And as of your question for now, yes, you can definitely predict your quarter wise, your month wise, or your day wise values of, you can predict day wise in any terms, year wise. It totally depends on what amount of data you have with which prediction can be done, right? So we have a few basic criteria for that. Yes, we look into that in detail when we move into that topic of forecast analysis. Okay, so now as of now, this is and then comes the moving average. Okay, now we have a few calculations involved under moving average. We'll go through that in detail as well right now. Okay. Then we have year to date total, right? Which means if you have till date, a data set which contains till date information, you can simply make use of this year to date total, and you can calculate the compound growth rate or year over growth. I mean, year over year growth, how your growth has been throughout these years, or again, your year to date growth will be calculated when you have a data which contains information or data till this particular date, right? Till date, the current date, right? So these are some of the calculations that you can quickly apply to your table. That is why they are placed under quick table calculations. And we also have, when you apply any quick table calculation, you have an option called edit table calculation over here with the delta symbol, right? Now let me just clear the table calculation, and I'll also remove the column grand total, right? So now when you click, let's say I'm going to make use of the running total. Now, as you notice, right next to your measure, you have a delta symbol or a triangle symbol, which indicates that this is a measure on which you have applied some kind of table calculation, right? So that is why your sum of sales is has a small delta symbol right next to it, indicating that you have already applied some calculation on this measure, right? And after applying a calculation, you'll be able to view this edit table calculation. Now, this is the dialog box which appears. We have, you can simply decide what calculation you are going to make use of. Okay. What is the aggregation you are going to choose in order to calculate the calculation, and the ways of computing, you can choose the way of computing using these options itself. Okay. And when it comes to specific dimensions, now this is something like, I hope you remember we had something called selected, or we had targeted highlighting, right? You can select fields with only with which you would like the highlighting to be visualized in your data, right? This is something like that. We have specific dimensions. As of now, year of order date has been the checkbox of year of order date has been clicked, which means it is the addressing field. Okay. Addressing field is nothing but the direction in which it moves, right? So this is moving across the years. So we have year of order date as the addressing field, and we have month and or quarter as the partitioning field, right? So it just partitions the calculation using month and quarter. Okay. Or you can also have your month and quarter as the addressing field, which means it will move in a downward direction. Okay. When these are chosen as the addressing field, and you'll have the unchecked box which acts as your partitioning field. So your calculation goes in this way, and there's a partition. You can just imagine there's an imaginary partition between every year, every column, and that is why year of order date is considered to be the partitioning field when you choose the options in this way. So the boxes which are checked, they act as addressing fields, just the direction in which they move, in which the calculation moves, and the unchecked box act as your partitioning field, right? And we have this option called restarting every. You can restart every month, okay? Or when you have, let's say this, you will not have your restarting option because we have only the month and quarter as our partitioning fields, right? So there's no point. You do not have an option to restart every month or every quarter, right? So this is one option that you have. You can just decide upon them. These are different ways by which you can calculate your let's say your values of sales or profit or any such values, right? These are the different options that you can make use of, and that again purely depends upon your requirement, right? So this was about partitioning and addressing fields, and we also have, you can sort them out. Okay, let me just create another sheet. Now let's have the different subcategories. Let's have the different categories, and then let's have the corresponding sales, right? Now let me apply a quick table calculation, let's say of running total on this table, okay? And it is computed using table down, okay? And now let's try going into the edit table calculation dialog box. Okay, now when you click on specific dimensions, you can simply decide whether you would like to, in this we do not have any partitioning field, right? Because we do not have anything in our column shelf, right? So this is, as I told you, it depends on what and how you have visualized, you have created your table, right? And then I just wanted to tell you about this. When I say sort order in terms of specific dimensions, you can just customize it. You can have it arrange your sum of sales, okay, in either the descending order or an ascending order, right? So it just starts from the least value of sales and then it goes on to the highest value, where we have phones is the subcategory which has the highest value of sales, right? So the running total is calculated in an ascending manner, okay, which means from the lowest value of sales to the highest value of sales. And when you say descending, it will start from the value of sales of phones and it ends at here, right? So I think it is fasteners where it ends, okay? And when you click on ascending, I think it starts from fasteners, right? So yes, I think I said art. No, it is the fasteners subcategory which has the least value of sales. So it starts from this, else you can just sort it out in your descending order, right? So this is again up to you, whichever order you would like to go ahead with, right? And then we have adding a secondary calculation, right? Now we'll go back to our sheet number 1. Now let's apply. So we have applied a running total calculation and it is computing using table across, right? Now when I go into the edit table calculation dialog box, you have an option called add secondary calculation, which means on top of the result of my calculation that I've already applied to the table, on top of this I will add another calculation, right? Now if I say add a secondary calculation, we'll again get another dialog box which says secondary calculation type. Now these are the only options, these are the only type of calculations that you can apply as a secondary calculation when your primary calculation is running total, right? So out of the running total values that I've calculated, calculate the difference from, okay, and it is relative to the previous value, right? So this is what you are applying, one calculation on top of the other, and where your first calculation becomes your primary calculation and your second calculation becomes your secondary calculation, the one that you're applying on top of the result of your first calculation, right?
Just a quick info, guys. Intellipaat provides Business Intelligence Master's Program in partnership with Microsoft, the course link of which is given in the description below. Now, let's continue with the session.
Okay, and now let's just go into moving average and I'll let you know. For that, I'm just going to filter out the date dimension, okay, so that I can explain the moving average with the most simplest set of data that we have, right? Now I'm just going to, let's say I'll bring my order date and I'm going to filter out so that instead of getting the data of the 4 different years, I would like only 2015 years data. And again, I'll bring my year of order date, and this time it is going to be in terms of months because I'm interested only about the month of January, right? Now, by doing this, when you bring in order date into your view, you will have only 2000 year data, only Q1 data, out of which only the month of January related data will be displayed. And these are the different days that we have in the month of January. Now you might see the days of the month of January starts from 3rd of January. We do not have 1st or 2nd, and we have 3rd, 4th, 5th, 6th, 7th, and we do not have 8th, right? And we have quite a few numbers or dates that are missing. Now this is because This is what you have been provided in your data set, right? So as a Tableau developer, you are just working with whatever data has been provided to you, right? So we basically are not concerned about the missing dates or missing data. Okay, there might be it might be a holiday for the superstore, or it might have been there's no order that has been made on that particular date, right? So there might be n number of reasons for that, but basically we do not have entries for these dates in our data set, and that is why we are just continuing with whatever data we have that we have been provided with, right? So that is why it starts somewhere from 3rd January, because we do not have entries, we do not have data for 1st or 2nd January, or any missing date that we have in our data set. Okay, so now I'll bring the value of sales and I'll place it in the text part, right? Now this is the month of January of the year 2015 and the corresponding days value of sales, right? Now let's try applying the moving average calculation. Okay, now this is the simple moving average that we are going to discuss about. An exponential moving average, as I told you, we'll discuss in detail when we are forecasting with the data that we have, right? Exponential moving average is the calculation behind forecasting in Tableau. Okay, now let's try applying the simple moving average calculation on our measure called sum of sales, right? And for that, I am just going to create a duplicate of my sales. Okay, and I'm going to bring this into my visualization, right? So now I have sales, copy and sales. So on my sales copy measure, I'm going to apply the quick table calculation of moving average. This is just to show you what is my actual value of sales, right? And from which the moving average has been calculated, what are the values of moving average, right? Just to compare between the actual value of sales and the moving average of sales, right? Now we'll go into the edit table calculation dialog box and we have a few options. Okay, now this is the window value, right? Now this window value is nothing but with respect to how many values you are calculating the moving average for this particular measure, right? Moving average is nothing but it is just a smoothing technique, or it just smooths out fluctuations in your calculations, right? So we have mentioned, so we have something called current value, null if there are not enough values, and when you have different combinations, the value changes accordingly. And in some cases you have a blank value on the first row, in some cases you have two blank values. Now let's see what happens with different combinations in these check boxes and what are they used for, right? So now basically a moving average is calculated by default with a window value of 2, right? Which means, now let me uncheck this box as well, right? It says with respect to two previous values, I am calculating the moving average, right? Now how does this happen? Okay, now we will look into the actual value of sales. Okay, now I have used 2 as my window value, which means with respect to two previous values, I will calculate my moving average, right? So when it comes to 16, okay, I do not have any previous value to calculate the moving average from. So that is why I have left the column as the cell as blank over here. When I move on to my second row, though I do not have enough two previous values, I should have two previous values to calculate the moving average from, right? I do not have enough previous values. I have only one previous value, but yes, that doesn't matter. I'll simply place that one previous value over here, right? But when it moves on to the third row, we have enough two previous values to calculate the moving average from. So it just adds up. It just says 288 plus 16 divided by 2, which is nothing but we have our value of 152 in our third row, right? So and this just goes on with the previous two values that you have. You calculate a moving average and you place that value right next to that particular row, right? Now this is what happens when you haven't included your current value and you are not displaying any null if there are not enough values. Now when I click on this null if there are not enough values, what will happen? Right, as I told you, when I am in my second row, I do not have enough previous values, but still, as I have just one value, I'm just simply placing that in this row. But when I say null if there are not enough values, my second row and my first row both become null, because for my first row, I do not have enough previous values, as well as for my second row, I do not have enough previous values to calculate the moving average from. That is why it is left blank. And only from the row where I have enough previous values to calculate the moving average from, I have my moving average of sales column which starts, right? So this was about how do you null if there are not enough values. Now let's see what happens when I am going to include my current value. Okay, now as I told you, 16 did not have enough previous values, but since we have mentioned, or as we have mentioned, yes, you can include your current value also. It is simply displaying its current value. When you look into the second row, we have one previous value and we are also allowed to include the current value, which means 288 plus 16 is nothing but 152 that is placed over here. Now, when you move on to the second row, it calculates the moving average with the two previous values, including its current value, which means 16 plus 288 plus 20 divided by 3 will give you 108. And this just goes on. Okay, now this is a small change that happens when you would like to include your current value or exclude your current value while calculating the moving average, right? So this was one option. And now let's see what happens if I'm going to display null if there are not enough values. Again, the first two values are displayed as null because they do not have enough previous values to calculate the moving average from, right? So these two options that we have, including and excluding the current value, whether to display null if there are not enough values or simply leave it as it is. Now these, we have changes that happens to the result when you have different combinations of these two different check boxes that we have, right? Now this was the concept behind simple moving average, or how a simple moving average will be calculated. Okay, now after this, I think we'll start with rank. I'll just connect Tableau with that simple file that I have, which is just for explaining rank. I have this rank sample. As I told you, it's a very small data set. We just have very few number of rows and columns. Okay, yes, this is rank sample. I just have 2 columns and I think around 5 rows. Okay, in this rank sample, I have a few names and the corresponding sales. Let's see how Tableau gives ranks to these names depending upon its value of sales, right? Now, let me just connect this to Tableau, right? I will be connecting this to the rank sample, and we have our name and the corresponding sales just like we had in our rank sample. Let me bring it over here. We have our name and the corresponding sales in the text part, right? So we have the names and sales. Now let's apply the quick table calculation of rank, okay? Or you can also create a calculated field, right? Where you start typing as rank, you'll be able to view. We have one simple rank function. We have rank dense, we have rank modified, rank percentile, and rank unique, right? So we'll just make use of these different rank calculations, okay, in here in our calculated field itself, so that you'll be clearly able to understand or view the difference between these different types of rank functions, right? So first I'll just say, I'll make use of the simple rank function, and I'm going to apply this rank function on my measure, right? And my measure is nothing but my sum of sales, right? So I'll just name this as rank, click apply and OK. You can just bring this rank and place it in your visualization. We have our rank. Okay, it says first rank, second rank, fifth, third. Now, when you look into the value of sales, right?
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We have the highest value of sales, which has been given the first rank. Then we have the next least value, or the next, the one which is lesser than the highest value, right? The next lowest value, which has been given the second rank. Now, when it comes to the third rank, we have a tie. We have same value of sales. Okay, and that is why the same rank has been given to both these names with the same value of sales, and the next higher rank is skipped, which means after third rank we should have had a fourth rank, which is skipped, and 20. Okay, now this might be given something around third rank. This will also be given the third rank. This will also be given the third rank, right? Now how will the next higher rank be skipped, right? So we will not have the fourth rank, we will not have the fifth rank, we will directly have the sixth rank for the next value of sales, right? So this is the rank function all about. We are just omitting, or we are just neglecting the next higher rank when we have a competition and when you make use of a simple rank function, right? Now let this calculation be as it is. Let me create another calculated field where I have the next rank function, which is rank dense. Okay, and in rank dense, I'll again say rank dense of sum of sales, right? Just click on apply and OK. When you bring in, I'll just try to rename it. This is rank dense, right? Let's see how rank dense handles combination. Handles the same value of sales, or handles competition, right? Now I'll bring rank dense and place it somewhere over here. I'll try expanding this. So we have the simple rank, and when it comes to rank dense, we have the first rank, we have the second rank, we have the third rank. When there's a competition, we have the same third rank. But instead of skipping any higher rank, it just moves on to the fourth rank, right? So it doesn't skip out any ranks, just as our simple rank function does. Okay, now that's a small difference between rank and rank dense. Then we also have the rank modified. Okay, let's see how competition is handled by rank modified, right? And I'll just name it as rank mod. Okay, click on apply and OK. Now you have the rank mod, which is a function, which is a calculated field that you have created. When you bring this into visualization, we have rank mod. Now it says first rank, second rank, and it straight away goes on to the fourth rank, right? So what happens under rank modified? The least rank is skipped and it straight away goes to the next higher rank when there's a competition, right? Now this is a small change. You can just compare this in contrast with our simple rank function. It skips the next higher rank, whereas your rank modified skips the previous or the lower rank, okay, and then moves on with a higher value. So this is one small difference between rank function and rank modified. Then we also have our rank percentile. Okay, again, just like how we had our percentile values in our quick table calculation, when it comes to percentile of rank, when it comes to the rank percentile, values range from 0 to 1, right? So it says we have the least value of sales with a 0, the highest value of sales with 1, and then all the intermediate ones are split up out of, are provided out of a total of 1, what is the contribution of this particular value of sales, right? And the last one that we have is the rank unique function, rank unique of sum of sales. Now, as the name tells you, it gives a unique rank. Okay, even if there's a competition, it gives a unique rank to all my value of sales, right? I'll just click on apply and okay. Now, when I bring in rank unique into my visualization, you'll be able to see we have first, second, third, fourth, and fifth rank. Now, for every value of sales, whether there's a competition or not, even when you have a competition, you will be given a unique rank. Okay. Now, for the same value of sales, okay, how does Tableau or how does this function has calculated a unique rank, which both have the same value of sales, which means which name has been given the highest rank. Now, G has been given the highest rank because it first looks into the value of sales. Okay, if there's a match in the value of sales, it simply next moves on to the actual name. It just calculates the ASCII code of your name, and according to which your unique rank is given. Right now, when you look into the alphabetical order, we have G, which comes first than W, and that is why G is given the higher priority, the higher rank when compared to the next alphabet, which has the very same value of sales, right? So this is how competition is handled by the different rank functions. Okay, we have rank simple rank, we have rank dense, rank modified, rank percentile, and rank unique, right? So rank, the simple rank function skips the next higher rank when we have a competition. The rank modified function skips the least rank, okay, when you have a competition. When it comes to rank dense, there's no skipping of any ranks, okay, even if you have the same value of sales, even if you have a competition, okay, there's the same rank that has been given for both the value of sales, but there's no skipping of the higher or lower rank. But when it comes to rank unique, every value in your file will be given a unique rank. So first it will look into the value of sales. If there's a competition, it will simply go into the ASCII code of characters, and that is how the one which comes first in an alphabetical order is given the higher priority rank, and then comes the least rank, right? So this was all about the different rank functions that we have in Tableau. Okay, and with this, right after this, we are going to start with our LOD expressions. Level LOD, like LOD is nothing but the level of detail expression, right? Now, when it comes to Tableau, as I told you, this is considered to be one of the complex topics in Tableau, right? But still, once you grasp the concept behind this, I'm sure definitely this is going to be one of the easiest topics, right? So let's see what is an LOD expression, what are the different LOD expressions that we have in Tableau. Okay, now LOD is nothing but we are going to compute calculations which has complete independency from the view level of detail. Okay, now I'll tell you what is view level of detail. Okay, so this is the basic syntax. We have fixed, include, exclude. We have dimension 1, dimension 2, and then we have a colon, and we have an aggregated expression right over here. Okay, this is the syntax. Now, when you look into the diagrams, we have one diagram which is purely for exclude LOD expression, and we have another diagram that was for include, and this is for exclude. First, I'll explain what every diagram or every symbol in our in this particular diagram represents about, right? And yes, this is the diagram for include. And as you see, we have aggregation over here and we have granularity on this side. So aggregation is inversely proportional to granularity, right? Now, what is granularity? Breaking down one plot into different plots. Okay, we are making it granular in nature, right? After which it totally depends, after which we will arrive at a raw data on which there is no aggregation that has been applied. Aggregation is nothing but the sum, the average that we apply on our measures. Okay, so an aggregation is inversely proportional to granularity, which means as you keep decreasing your aggregation, you will have a data which is more granular in nature. As you keep increasing your aggregation, you will have a data which is lesser granular in nature, right? So this is basically about aggregation and granularity. Then we have this dotted line over here, right? Now this dotted line corresponds to the view level of detail. What do you mean by view level of detail, right? For example, I'll just open up my workbook. Okay, now if I have category and let's say profit, now my view level of detail is nothing but what are the fields that are present right now in my view that corresponds to the view level of detail, right? Now category and sum of profit are the dimension and measure which fall or with which a visualization has been created, that is placed as or yes. So as I told you, this is the view level of detail. Now this dotted line corresponds to what fields are present in your visualization. Okay, and then we have a filled circle over here and we have a filled arrow mark. Now this filled circle represents a measure and this arrow mark represents a dimension. Okay, so here as per this diagram, we have the first filled circle which represents the measure called sum of sales. We have the next arrow mark which represents the dimension called country. Then we again have a circle, we have another arrow mark and so on, right? So I have an example with which we'll be discussing about include LOD expression in detail, right? And once we discuss about that example, we'll try connecting that example with this diagram and we'll see how the calculation has been carried out, right? And when we say include is our LOD expression, okay, we are including a new dimension, okay, with which a calculation will be performed, okay, and this dimension that you're including is not present in your view level of detail, right? So you are including a dimension with which a calculation will be performed, okay, and that dimension is not present in your view level of detail, and the corresponding result of this calculation we will be brought back to the view level of detail so that the result can be viewed in your worksheet, right? So this is just like a cycle. You have a measure and a category, you have a measure and a dimension in your view level of detail. You are including a dimension which is not a part of your visualization but only a part of your calculation, and then you are displaying the result of this calculation, right? So this is general explanation of this diagram for include, right? Whereas when you look into exclude, we again have aggregation and granularity, we again have the view level of detail, okay, but when you look into this diagram, there's a small change. The calculation when it comes to exclude is carried out above the view level of detail, but when it comes to include, the calculation is carried down the view level of detail, right? So I'll explain about these with appropriate examples, right? So we'll go back to our workbook. We'll just delete. Right. So now let me tell you, we'll start with our include LOD expression. Okay. Let's calculate the average of sales. Okay. Now I'll bring sales. Now you can place sales in your column, and then from this drop down arrow, you can change the way it is aggregated as average of sales. This is one option of how you can do this, or you can just instead of left clicking and then dragging your sales, you can right click on sales and then drag, place it in this space over here, after which automatically this dialog box appears and you can choose the way it should be aggregated from here itself, right? So we have our average of sales, and let's have our category and let's have our subcategory, right? So we have the average of sales. Okay, we have the subcategories listed under every category, and we have, the average sales of every subcategory that is getting displayed right over here. Okay, now what if I would like to compare the average sales of categories with the average sales of category in terms of subcategory? Okay, how do we do that? Okay, we will have to remove the subcategory. We will have to calculate the average of sales in terms of subcategory and then compare it with the average sales of category itself. Right now you might have a small confusion of what is the difference between average sales of category and average sales of category in terms of subcategory. Right now I'll try to complete the visualization first, and then I have a separate text file which is known as the LOD sample that I have. Okay, it is just something like a sample file of our superstore. Okay, so I'll explain how average of sales in terms of category is calculated and how average of sales in terms of subcategory is calculated, and why there is a change in the result between these two values. Right, so as of now we have our average sales in terms of categories. Okay, now I'm going to create a calculated field where I am going to calculate the average sales of subcategory, right? And I'm going to include the dimension called subcategory, okay, which is not present in my view right now. So I am including a dimension in the calculation that is getting performed. Okay, and this is the syntax. We have our keyword, we have our function or LOD expression name, which is include. Then we will have to specify dimensions that we are including in any calculation, and then we have our aggregated expression, which is nothing but the average of sales. Right, so I'll just click on apply and OK. Now when you bring the sales of subcategory, which is a calculation, into your view, as you notice, the way your average sales is plotted is completely different. The values are, totally different. The sales of subcategory is completely high when compared to the average of sales. This is because there's a second layer of aggregation that is applied on the result of your LOD calculation. So we will have to just change this into average. Okay, and now when you look into the tooltip, you have an average of sales and you also have average sales of subcategory, and we have different values for them. Right, now let's clearly go through every step behind how these values are calculated. Okay, and why there's a difference between the average sales of category and average sales of subcategory. Okay, and as I told you, I have a simple file for that. Right, so this is the LOD sample, the sample file that I told you. I'll be connecting this with Tableau, and I'll tell you, we again have three different categories. We have furniture, appliances, and technology, under which, for example, under the category called furniture, we have chairs, tables, beds. We have quite a lot of subcategories, and similarly under appliances we have around 2 to 3 subcategories, and under technology as well we have 2 to 3 subcategories. Right, now let's see, just like how we did in this workbook with sample superstore data, how to calculate the average of sales, how to calculate the average sales of subcategory using your include LOD expression, and what is the main purpose of making use of an LOD expression. Now we were discussing about LOD expressions, right? We have include, exclude, and fixed, and we started with include LOD expression. This is the LOD sample. As I told you, we'll try connecting this with Tableau, and I'll show you how I have an LOD explanation, LOD sample explanation notes as well. Okay, I'm sorry, this is taking a little time. It is a text file. This is my LOD sample that I'm going to open. right? We have again category, subcategory, and their corresponding sales. Okay, now I'll bring the categories and let's have the corresponding sales value, right? And when I change the aggregation, when I say I would like to view the average of sales, now this is how the average of sales is getting calculated. So first we'll see how average sales of every category is getting calculated, right? And we look into this. I'll have this side by side, right? Now it says we have the total sales, which is 10,400. Okay, so when you just add up all the sales value, okay, when you add up all the values of sales in the column, in the field called sales, you will have a total of 10,400, right? Which means in our workbook, when you bring in sales into the text part, you'll be able to view the entire sum of sales, right? So this is the total value of sales, which is 10,400. Okay, and when you calculate the sales of furniture, we are just adding up the sales value right next to the category called furniture, whatever subcategory it might belong to. As of now, we are concerned only about the category furniture. So I'll just add these. I'll add the value of sales, which is under the category of furniture. So we are arriving at a result of 150. Okay, now average sales of furniture is nothing but the total value of sales 150 divided by the number of occurrences of furniture, right? So furniture, whatever subcategory it might have, so furniture occurs 1, 2, 3, 4, 5 times in our data set, right? And that is how we calculate the average sales of furniture. Now when you look into our workbook, we have average sales of furniture, which is nothing but 30, right? Now this is the same way by which average sales of categories get calculated in our sample superstore as well, but I will not be able to clearly tell you the number of occurrences in this simple way that we just now did with this LOD sample, right? So that is why I thought I created a miniature or a sample just like our sample superstore, okay, with which explaining about this average of sales will be even better, right? So that is how we arrive at the average sales of subcategories, right? I mean average sales of categories. Okay, now this is the value of average sales of sample superstore categories, whereas this is our average sales of our LOD sample. Okay, and we'll just go back to this. And similarly, we have the total sales of appliances. Total sales of appliances. So wherever you have appliances, you just add up the value of sales and you will arrive at this total value, which is nothing but 6,900. And the average sales of appliances is 6,900 divided by the number of occurrences of appliances. So you have 1, 2, 3, 4, 5, 6, and we have 7, 8 over here, right? That is why we have 6,900 divided by 8, which is 862.5, which is the average sales value of your category called appliances, right? And again, similarly, you calculate the average sales of technology in the very same manner, right? And we have arrived at this sheet. You can just have this as a bar chart if you would like to, or you can also have it as a text table, right? Now, what if I would like to compare this average value of sales, okay, with the average sales of in terms of subcategories, right? Now, how do we do that, right? Now, I'll just show you. Okay, so now when it comes to average sales of furniture, average sales of appliances, this is just the straightforward method of how average sales is getting calculated. Now, how do I calculate the average sales of appliances in terms of its subcategories, right? Now, there's a difference between both, right? This is just the average sales of that particular category, but this is the average sales of appliances in terms of subcategory. Okay, I hope you're able to get the difference between these two. Now, when I say in terms of subcategories, under appliances, I have two subcategories. I have TV and I have fridge, right? So I will calculate the average of fridge and TV separately, right? And then calculate the average of subcategories of appliances, and which will arrive at a single value. Okay, so I'm just calculating the average sales of fridge, which is nothing but under appliances. When you look into fridge, we sum up the sales of only fridge subcategory. Okay, and it occurs around 1, 2, 3, 4, 5 times. So 4,800 is the total value of sales only of the subcategory called fridge under appliances, right? So 960 is the average sales of fridge. Average sales of TV is nothing but, again, you calculate the sales value of only TV, and the number of occurrences, you divide by the number of occurrences and you arrive at 700, right? Now, therefore, the average sales of subcategories of appliances is nothing but average sales of fridge plus average sales of TV divided by 2, which is nothing but 830. So your average sales of appliances is 862.2, but your average sales of appliances in terms of subcategories is 830, right? So I hope you understood why there's a change between these values of calculating average sales of categories or average sales of categories in terms of subcategories, right? So basically, this is the concept behind the calculation that we are going to go through as an example for LOD include expression, right? So while discussing about LOD, it is always better to stick on to one example first. Okay, from the same example, just go through the very same example again and again, try to get the concept behind it, and then you can definitely try this out in any other example. Okay, so that is the one very important point when LOD is concerned about, right? So basically, this is the difference. We have average sales of categories, which is a different value, and average sales of categories in terms of subcategories, which comes up to a different value. Now, how will we arrive at this value? This is only by having average sales and category in our view and including subcategory in the calculation alone by using the include LOD expression, right? So now in this diagram, we have our average of sales, we have our category in the view level of detail, we are including the dimension called subcategory, where the average of sales will be calculated for the categories in terms of subcategories, and the result alone will be brought into our visualization so that you can compare between both the average sales of category and average sales of category in terms of subcategory, right? So basically, this is what we are moving towards. This is the idea behind the calculation or the visualization that we are going to create. Okay, we are just trying to compare the average sales of categories with average sales of categories in terms of subcategories. Okay, and there's one more point. In order to bring the result of average sales of categories in terms of subcategories, we will remove subcategory from the view. Okay, we will create a calculated field which will include the dimension called subcategory, okay, which is not a part of my visualization. I'm including it only to calculate the average of sales, right? Yes, so this is the include LOD expression, and I'll just call this as sales of let's say subcategory, because it is in terms of subcategories, right? Just click on apply and OK. But when I try to bring this into visualization, okay, when I try to bring this into visualization, though there is already an aggregation called average that I have used in my calculation, okay, there is a second layer of aggregation that is applied to my calculation itself. okay, and which is by default the sum aggregation. I'll have to just change it as average, right? And now you'll be able to clearly compare between the average sales of categories and average sales of categories in terms of subcategories, okay? And what is the second layer of aggregation all about? When you look into this diagram, we are performing the calculation in a space which is below the view level of detail, below this dotted line, right? Which means my view level of detail is more aggregated than the space where I am performing this calculation, right? So that is why, because my calculation is less aggregated than the view level of detail, when I bring back the result to the view level of detail, just to match the aggregation of my result with the aggregation of the view level of detail, I am applying a second layer of aggregation, right? When you just look into this line, this horizontal line over here, and this view level of detail, right? Your view level of detail is more aggregated, and when you move down to the space where your calculation is carried out, it is less aggregated when compared to your actual view level of detail. So that is why, in order to match the aggregation with that of the view level of detail, we are applying a second layer of aggregation on our result. Okay, only then it will be matched with the aggregation of my view level of detail, and the result will be displayed in the worksheet. Right, now there are two ways by which you can apply the view level of you can apply the second layer of aggregation. You can either change from this measure over here, okay, or you can simply edit this calculation. You can simply wrap up this entire calculation with a second layer of aggregation, right? So my entire include expression is wrapped up with an average aggregation. You can also try doing this. Anyhow, you should have two layers of aggregation. Only then your result that is calculated in a level which is lesser aggregated than the view level of detail will be matched with your aggregation of the view level of detail, right? These are a few points about include LOD expression. Okay, now we'll just go into our actual workbook of sample superstore. Yes, so we have our average of sales of categories, and we have average sales of categories in terms of subcategories. Okay, you can just look into the tooltip. We have different values for both of them, because I'm sure by now you must be able to get the point why the value of both these are different, right? Now we'll just try enhancing the visualization. Okay, now we are going to create a dual axis graph, dual axis chart. Okay, and in order to create a dual axis graph, we need to have two measures. Okay, and we'll be discussing in detail about dual axis graph during our next session. We'll be starting with the next module, which is about charts and graphs.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We have average sales of subcategory. You can customize, you can enhance each and every chart, each and every graph, each and every measure. You can color them, you can change one into a bar chart, one into a line chart, just totally depending how you would want your view, your final view to appear, right? So I'll just show you one example. As of now, I'm changing both the measures as bar charts. Okay, and we have our average sales, which is blue in color, and we have our average sales of subcategory, which is orange in color. But you are not able to find the blue bar graph because it is just overlapped. Both the bar charts, bar graphs are overlapping on each other, right? So because of which, let me reduce the size of this so that you'll be able to see the blue graph right behind it. Okay. Now with this type of visualization, the user will be clearly able to compare between what is the average sales of category, which is the blue graph, blue bar chart, and what is the average sales of category in terms of subcategories, right? So that is why we have a orange bar chart over here, right? So you can easily compare them with this type of a visualization. This was one example where you can make use of LOD expression. You are calculating with a dimension which is not present in your visualization, right? You are including a dimension to your calculation which is not present in your visualization, right? Now exclude is just in contrast with this, right? Now just in contrast with include, we have our exclude LOD expression. We are, as you look into this, we have the filled circle, which is a measure. It is average of days. Then we have our first dimension, treatment category, and we have some other dimension called admit source, and then comes the view level of detail, right? Now from the view level of detail, okay, we are excluding a dimension which is already present in our view level of detail. We are performing the calculation without considering this excluded dimension and then displaying the result in the view level of detail, right? So we'll just look into that example as well. Let's say, for example, I have the state and city related sales, right? Now let's have the state. Okay, we have the list of states, and let's say we have cities. Okay, and let's have the corresponding sales, right? Now we have the state under which we have quite a lot of cities, and their corresponding sales is displayed over here, right? Now what if let's just sort this out in a descending order. Okay, so we get this over here, right? Now you can either use your state and city hierarchy as well for this, right? And now we are planning to compare the average sales. Okay, I'm sorry, I'll just change this into average sales. Instead of sum of sales, let's have average of sales, right? So now I have the average sales of cities, okay, that has been visualized over here. I would like to compare the average sales of state. Okay, for every state I would like to have a state average, okay, with which I can compare which cities has an average sales which is above or below the state average to which it belongs to, right? And how can I calculate the average of state when I have city in my visualization, right? This is where we make use of an exclude LOD expression, right? Just like this example over here, we have our average sales, we have our state, we have our city in our view level of detail, right? From which we are going to exclude a dimension. We are going to exclude city from our visualization. We are going to calculate the average sales of state alone and then bring the result to our visualization, right? Now let me just visualize it, and then when we arrive at the final visualization, you'll be clearly able to understand, right? So I'm going to create a calculated field. This, I'll just name this as state average. Okay, I'm going to exclude a dimension. Now you can, when you are including a dimension, you can include any dimension of your choice, whatever is present in your data set, right? But while excluding, you will have to make sure you will have to exclude only the dimension which is already present in your visualization, right? So that is one important point when it comes to exclude. So here we are excluding the dimension which is nothing but the city, and my aggregated expression is average of sales, right? I'll just click on apply and OK. Now this is the state average. You can simply bring the state average and place it into your visualization. Now there's one point. When we try to bring the calculation into our view in our include LOD expression, Okay, we had to either apply a second layer of aggregation, or we had to add 2 layers of aggregation. We had to wrap up the entire include expression or with an average aggregation, which is the second layer of aggregation, right? But when it comes to include, what is supposed to be done? I'm just bringing state average into my view, right? And yes, I have the result that is getting visualized. This is because, as I told you, when it comes to include, the calculation is done in a space which is in a lesser aggregated area than the view level of detail. That is why, while bringing the result back to the view level of detail, in which is more aggregated in nature, we had to apply a second layer of aggregation, right? But in contrast, we have our exclude calculation that is done above the view level of detail, above this dotted line, which means the calculation is getting performed in a space which is more aggregated than the aggregation of the view level of detail, right? That is why when it comes to an exclude LOD expression, okay, because the result is already in a more aggregated area, there is no need to apply a second layer of aggregation. You can simply replicate the result in the view level of detail, right? You can just compare these two diagrams. The calculation is below the view level of detail, and here the calculation is above the view level of detail, because we are excluding a dimension which is already a part of the view, right? So that is why the calculation is done above the view level of detail, and instead of applying a second layer of aggregation, there's no use of applying a second layer of aggregation. You can just replicate the result uh, to be visualized in your worksheet, right? In your view level of detail. Okay, let me go back to the workbook. I have brought the state average. We haven't applied any second layer of aggregation. We are just replicating the result over here. Okay, it says attribute because you cannot further apply any aggregation on top of this, right? Now let's enhance the visualization. Now we have both as bar charts. Okay, I would like to have the state average to be displayed as Gantt bar. So under state average, I am choosing the Gantt bar from the marks card. Okay, and let me create a and let me change the color of it first. Let's have a lighter color, something like this. Okay, and let me create the dual axis chart, right? And I would like to have my average sales of cities as a bar chart itself, right? Now let's try synchronizing the axis, right? After which we have our average sales of cities, and we have the average, the state average that is represented using a Gantt bar. So by this, you can clearly be able to find out which particular city has a sales which is lesser than the state average, or whichever is higher than the state average, right? You can also label them. You can also change the color of your bar chart. Let's say I would like to have this as light blue and orange. Okay, and you can also label them. You can simply bring your sales with a right click on your label and have it as an average of sales. Okay, and when you click on this label, you can decide on your alignment options. Okay, I'll just place it in the center, right? And then you can also label your state average, right? So with which you can easily compare whatever is your state average and whatever is your city average in one single chart, right? So this is an example of exclude LOD expression. We are excluding a dimension which is already a part of our visualization, performing the calculation with only the dimension that is left out. Okay, and then we are displaying, we are just, instead of applying, there's no need of applying a second layer of aggregation. We are just replicating the data in our view level of detail, right? So this was about include and exclude. So I hope you're able to compare both the differences between these two, right? And we just have one more to go, which is nothing but the fixed LOD expression. But when it comes to a fixed LOD expression, calculations are computed independently of what data is present in my visualization. I might have any dimension in my visualization, right? But the result of my calculation will remain fixed, right? So let's just look into an example for that. Let's say I would like to see which are the customers who are profitable and which are the customers who are not profitable, right? Let's say I'll bring in the customer name into rows and let me bring in the sum of profit. Okay. Now, when you look into this profit, we have a few customers with positive profit and we have a few customers with negative profit, right? So now let me just create a very simple calculated field, right? I'll just call this as color. Okay. I'm going to just say sum of profit is greater than 0. So there'll be two different colors, one for the value of sum of profit greater than 0 and one for the profit value which is lesser than 0, right? So I'll just click on apply, okay, and I'll place this into the colors mark. So now as you notice, and I'll just change true to be blue and false to be orange. Click on apply and okay. So here we have, you can also sort this out in descending order. So these are the list of positive customers, and as you go ahead, you'll have a list of negative customers, right? Which we have a different color code for the positive or profitable and non-profitable customers, right? But this doesn't answer any such analytical questions, right? As of what is the number of profitable customers, like let's say per city or in any state, in any particular state, what is the number of positive profitable customers and what is the number of negative or non-profitable customers, right? So how do we do that? So in order to answer such analytical questions, we will have to make use of our LOD expressions, right? And let's see how that can be done. Okay. Now you can also bring in city over here, okay, where you have whether this particular city has a positive profit or not, this particular city has a negative profit or not, right? But in this same chart, I would like to view the number of customers in any city who are profitable and not profitable, right? So let's see how this can be done. I'll just clear the sheet. Okay. Now let me create a calculated field, right? So whatever dimension is going to be placed in my visualization, this calculation is going to remain fixed. Okay, I'll just say fixed. I'm sorry, I'll just say fixed, and I'm going to fix the customer name over here because I would like to view the fixed count of customers, okay, in terms of whether they have positive profit or negative profit, right? So we are simply specifying a condition right here in our LOD expression, okay? So we have our sum of profit which is greater than 0 and customer name. Okay, I'm sorry, I just didn't name my calculation. Okay, so this is it. We have our fixed customer name. We are fixing the dimension called customer name. Okay, and we are just calculating whether the customers have a positive profit or a negative profit, right? So this is the result of this calculation, and we'll just name it as, let's say, profitable customers, right? So we have this calculated field. Just click on apply and okay. So we have profitable customers. Yes, they are profitable customers with a profit greater than 0, or no, true or false value. No, they have a negative profit, right? Now let me just let's say bring in customer. Okay, I'll bring in cities. Okay, let's try calculating the count of customers in terms of cities. We'll have our cities in rows. Okay, And now let's put this calculated field called profitable customers. Okay, and while putting this into our columns, we will have to apply, we will have to have a count distinct, or you can have a count aggregation. I think count will be fine, right? Let's have a count aggregation. Only then you will get a count of profitable or non-profitable customers, right? So as of now, we are able to view, we have a count of profitable customers as 355. The count of customers are clearly viewed over here. Okay, now let's try to make it even more clear. Okay, let's try to make it even more precise, and I'm creating another calculated field. So I'll just complete the visualization, and we'll come back to the different calculated fields that we created, and we'll just go through what is the advantage, what is the purpose of every calculated field, right? So now I'll just call this as profitable, whether this is profitable or not. We are just going to differentiate between them, right? So I'll just say if the result of my calculated field called profitable customers is equal to true, right? Then, right? So if the result of my calculated field called profitable customers, which makes use of the fixed LOD expression, is true, which means if the sum of profit is greater than 0, right, then they are profitable, right? Else you can just say they are non-profitable, right? And you can simply end your calculation, right? After which we will just click on apply and okay, right? And now let's just place this profitable into the colors marks card, okay? And I'll just change this. I want profitable to be blue in color, and I want non-profitable to be orange in color, right? I'll just click on apply and okay. Now for every city, we have a blue mark and we have an orange mark, right? So it says blue corresponds to profitable customers, where the count of profitable customers is 300. When you click on orange, it is the count of non-profitable customers, but it says count, the tooltip has to be enhanced, right? But as of now, this is the count of customers who has negative profit in this particular city, and this is the count of customers who has positive profit in this particular city, right? Now let's try enhancing the enhancing the tooltip. Okay, as of now, I don't think the tooltip is fine. Now let me just click on tooltip. Okay, I'll just remove this. I'll just have it as count of profitable customers. So these many customers, okay, you can just insert city from here. In this particular city, okay, your tooltip is going to be dynamic in nature, so it will automatically display the city wherever your cursor has been placed. So these many customers in this particular city are, whether they are profitable or non-profitable, right? To display that, we will make use of this calculated field, right? Just click on OK. And now when you look into the tooltip, it says 300 customers in New York City are profitable. So as an audience or as a user, they will be clearly able to understand what analysis you have made right from the tooltip that you have created, right? Or it says there are 50 customers in San Francisco who are non-profitable, right? So it clearly tells you from the tooltip itself, the users will be able to understand. And as we had made it dynamic, the name of the city also is getting updated according to wherever we place the cursor, right? And blue means it is profitable, and orange corresponds to the non-profitable customers, right? Now, why do we say this calculation is fixed? Whatever dimension is placed in your visualization, or this calculation is computed independently of whatever data is present in your visualization. Why do we say that? Now we have our city related information. Now I can just simply replace city by state. You just have to place state right on top of city. Okay. And as you notice, for example, in California, the tooltip has also been updated accordingly. Instead of city, we have the state in our tooltip. Okay. You have the information that 473 customers in California are profitable and 104 customers in California are non-profitable, right? So whatever dimension I bring in my view, the result of this calculation is just going to remain the same. The result of this calculation is just fixed as it is, right? You can also try bringing any other dimension, let's say subcategories, right? You might be able to see these many customers in this subcategory are profitable and these many customers in this subcategory are non-profitable, right? And you can also you can also label your visualization. Okay, I'll bring this count of profitable customers in the label part with a count aggregation, right? After which you'll be able to see, you can just expand this a little bit. You'll be able to see you have the exact count of customers right here in your bar chart itself, right? So this will allow the user to, very easily view your chart and, get to know what analysis you have made, right? So this is about the fixed LOD expression. Your calculation is computed independently of whatever data might be present, whatever dimension you might use in your visualization, right? So this is all about our LOD expressions that we have include, we have exclude, and we have fixed LOD expression. Next topic called LOD calculations, about how to fetch the latest 3 months details or 3-month data alone, right? So I'll create a new sheet. Now I'm going to bring in my order date. Okay, let's have it in terms of continuous months. Okay, and please note I have first converted it into a continuous date field, okay, in terms of months, and then I am changing it into discrete, right? This is because I would like to have a text table in this manner which has continuous month details, but the values should be displayed in a discrete format, right? So I hope you understood how we arrived at this. I have my order date in terms of continuous months, where I have every month name, a plot for every month, right? And after which I'm just changing it into discrete so that I'll be able to get this as a text table. I'll be able to make use of this as a text table, right? Now let me bring in the sales and place it into the text part, right? So this is our continuous months in a discrete format. Okay, now as of now the latest month is December 2018, November 2018, and October 2018, right? Now let's try to fetch out only the latest month, okay, which is December 2018, right? Let's see how that can be done. I'll be creating a very simple calculated field, right? I'll just call this as latest month sales, right? We'll call this as latest month sales because it is going to fetch only the sales of the latest month. And as our data is concerned, we have December 2018, which is the latest month, right? So for that, I'm going to make use of a few date functions, right? So now let's see how that can be done. I'll just say I'll make use of the if logical function. If I'll just complete typing the calculation, right? And then I'll let you know what is being done over here. Now we are calculating the date difference in terms of months, okay? And between, I'm just trunking the date to the month level, okay? And this Details is to be fetched from the field called order date. Okay. And after which, I mean, when it comes to date difference, we should have a date part. Okay. We should have a start date and an end date between which the date difference will be calculated, right? So when you look into this, okay, so we have the date difference in terms of month. The date part is month, right? Now the starting date is the date trunk. I'll tell you what is date trunk about. Okay, right? In terms of month, and then I'm going to
Just a quick info, guys. Intellipaat provides Business Intelligence Master's Program in partnership with Microsoft, the course link of which is given in the description below. Now, let's continue with the session.
calculate the max of date trunk. Now, what is this all about? I'll just let you know. I'll split this up into 3 and I'll explain the result, what every single function is going to display, right?
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
We have month as the date part again, and we have the order date from which the corresponding details are to be fetched, right? And after which we have, I'll just make sure the curly braces are fine, right? Yes, now when this is equal to 0, then you can display the sales, else end it, right? Date difference, we have month, 2, 1, 2, 3. Okay, I'll just close the date difference over here. I think this should work fine. Yes, right. So we are just calculating the difference between 2 dates, right? In terms of in the month level. Okay, so I am the result of this date trunk in terms of month level of order date. So this is the starting date, which is nothing but for every month we will have this value that is displayed. Okay, and then this max of date trunk, now date trunk month of order date, okay, the max of date trunk month of order date is going to be 12, right? Because the maximum month that we have in our the latest month that we have in our data set is 12, the month of 12 of 2018, right? So that is why we will have the month of 12 of 2018 over here. So when you find a difference between them, right, only the December month details will have a value of 0 when you calculate a difference, right? All the others will have a different value. For example, November will be something like 10 minus 2 or 12 minus 2. 12, which is the max of date trunk, minus 10, which is the number for October, which is nothing but 2, right? So the value is not going to be equal to 0. So only when it is equal to 0, we will be able to fetch the latest month details. Just click on apply and OK. So we have our latest month sales. Drag this latest month sales simply here into your visualization, right? Now, as you notice, we have the actual sales, and when it comes to the latest month sales, we have only the latest month, okay, which is December 2018 value of sales that is displayed in this space, right? Now, similarly, you can calculate, you can just create a calculated field for, let me just create a duplicate of this, okay, and I'm going to edit this. I'll name it as, let's say, previous month sales, okay, and here I will have the value as 1, okay. So now max will be 12, okay, and only when it is November we will have 12 minus 11, which will where the value is going to be 1, right? So just click on apply and OK. When you bring this into the view, you will have the previous month sales, and similarly you can also calculate the prior month sales, okay, just try duplicating this. You can edit this, have this value as 2, and then you can just name this as prior month sales, which is going to display the sales of the month of October, right? So this is how you fetch out every latest month details as per your requirement. Okay, now let's say you can just simply remove sales from your text part. Okay, and you can remove month from your rows, right, where we have only the latest month, previous month, and prior month sales, right? You can bring in measure values and simply place it into your rows so that we get a bar chart for the latest month, previous month, and prior month. Okay, and you can also label them if you require. Just bring in this calculation and label them, or you can just click on this, after which the label option, the text option in your toolbar, right, after which your bar charts will be labeled, right? So this is the latest month, previous month, prior month, and this calculation will be done according to whatever data is present in your data set, right? So this will get updated as your data set increases. Your data is getting added to your data set, right? And also for having latest 3 months together, right, you can just say a value. You can just change your calculation as, instead of equal to 2 or equal to 0 or equal to 1, you can just say anything which is less than or equal to 2, right? After which you will be able to, let's try doing that. I'll create a new sheet, right? Let me just create a duplicate of this and I'll try editing this. Okay, and in this calculation, let me just remove, we'll remove the condition. Let's have only the date difference, and let's also remove this, and let's change this to be lesser than or equal to 2, right? And just click apply and OK. Now you can I'll just rename this. You can have it as latest 3-month sales, right? So we have our latest 3-month sales. Okay, you can bring this, let's say, into your view, okay, where you have true and false values. Now, okay, now let me just bring in order date, okay, and their corresponding sales over here. Let's change it into a bar chart. Okay, you can also have it in terms of continuous months, right? Or you can also change this to be discrete so that you have a separate bar chart, right? Now when you let's say, let me bring this latest 3-month sales into the filter first, and I would like to view only the true values. Click on apply and OK, after which only the latest 3 months values will be displayed, right? So this is just displaying all the 3 months values together in one view. Okay, so this was just an example of LOD calculation. This is not an LOD expression. This is an LOD calculation, a calculation which will be carried out independent of what change is being made to your data or what is present in your visualization, right? So this was all about LOD expressions, LOD calculations, about the inbuilt functions and calculations that we have in Tableau, right? Yes, we are going to start with charts and graphs. Now, this is again one important topic because it really matters. Whatever analysis you have made, you will have to represent, you will have to visualize it with an appropriate chart, okay, as per analysis you have made, right? And only then your chart, your visualization, whatever analysis you have made will reach the audience in a better manner, right? So we have various types of charts and graphs that you can make use of in Tableau in order to visualize your data. Now we have around 24 types of charts and graphs, which is readily available right here under Show Me, right? And we also have a few other types of charts and graphs that can be created, right? Let's start with the dual axis graph, right? Or a dual axis chart. Let's see how to create that, right? As the name tells you, we have dual axis chart or graphs. Means you need to have two axes, right? Which means you need to have two measures. So only when you have two measures, you can create a dual axis chart, right? Let's say I have my order date, and let's say we have two measures. We have sales and we have profit, right? So now we have a separate axis for sales and we have a separate axis for profit. Now, if I would like to compare both these measures under one graph or in one graph, how do we do that? Now, this is where we go into the dual axis graph or dual axis chart, right? As I told you, we need to have two measures in order to create a dual axis graph. Now, when you click on the drop down arrow of your first measure, you do not have an option called dual axis, right? Only on your second measure, when you click on this drop down arrow, you have an option called dual axis, right? So let's create a dual axis. So now automatically we have a color code. We have a separate color for sales and we have a separate color for profit, right? But again, we have sales and profit, and the way, yes, exactly, sir. We will have to synchronize the axis, right? So we have the values, the way your graph, your axis appears is different for both. So we will have right click on any axis and you will have an option called synchronize axis, after which both the axes will get synchronized, and you can just remove the header. You can remove one axis, and now we have our sales and our profit plotted in the same graph with just one axis, right? And you can also notice there's a structure change in between these two pills, right? So there's a straight line with which these two pills appear, and this indicates that you have created a dual axis between these two measures, right? Now, what if I would like to have one more measure? What if I would like to compare, let's say, the sales, profit, and discount of this particular superstore in a single graph, right? How do we do that? Now, let me bring discount, which is again a measure, and place it right next to profit in rows. Okay, so now we have already created a dual axis chart or graph for sales and profit. Now let's also try including discount in this graph, right? Now when you click on this drop down arrow, you do not have the option called dual axis, because as I told you, a dual axis graph can be created only between two measures, right? Then how do we include a third measure, or how do we compare more than two measures in the same graph, right? Now this is where we make use of the measure names and measure values, right? So let's remove these measures. Okay, let me bring in the measure values, okay, which is an auto-generated field under measures. I'm just placing this measure values into rows, and after which all our measures, all the fields under measures, we have discount, we have number of records, profit, quantity, and sales. All these measures have been plotted out in our graph, and just to differentiate between these, I would like to bring measure names and place it into the colors mark, after which every measure name has been given a unique color. Okay, and now I can simply filter out. I would like to view only discount, profit, and sales in my graph, in one particular graph, right? I'll just click on apply and okay. So now you have only your sales, your profit, and your discount, which has been plotted in a single graph, right? So when you would like to compare, or when you would like to plot two measures into the same graph, you can go in for a dual axis option. When you would like to compare or visualize more than two measures in the same graph, you can make use of the measure names and measure values, by which we can create a multi-axis graph, right? So this is how you create a dual axis graph and a multi-axis graph using your measure names and measure values, right? So now this dual axis option can also be used to create dual axis maps, right? You can also combine two maps and display the information on two different maps in a single map using your dual axis option, right? And we'll also be looking into how to create a pie chart and how to create a donut pie chart, where again we'll be making use of this dual axis option, right? So basically, in order to create a dual axis chart or graph, you need two measures, and only on the drop down arrow of your second measure you will have the option of dual axis, right, with which you can combine, you can visualize both these measures into the same graph, right? So this was about the dual axis graph. Next we have, you can just look into the show me. You have different types of text tables, heat maps, highlight tables, pie charts, and so on. And you have the requirements for every type of chart or graph, right? So we'll just go through a few. We have a dual combination chart, or we also call it as a Pareto chart or Pareto chart, however you pronounce it, right? Now, as say dual combination, you have two different types of charts combined into one, right? Now, let's say I have my, again, let's have our date, and let's have both our measures, sales and profit, right? So under show me, so these are the different options that you have for this combination of one dimension and two measures, right? So now let's look into this option. So we call this as the dual combination chart, right? So one measure has been plotted out using a bar chart, and one measure has been plotted out using a line graph, right? So this is how, and automatically you have this dual axis chart that has been created between these two, right? Now this is a readily available option which is available, right? And you can also do this manually. For example, you can bring in your order date, you can bring in your sales, and let's say your profit. And when you look into this marks shelf, you have three options, so three different tabs. You have all, you have sum of sales, and you have sum of profit, right? So now this is, you can, we use Pareto. Yes, okay, yes, that is one type of chart that you can make use of. Yes, so as I told you, for comparison, we use Pareto. Yes, exactly. Yeah, now when it comes to your marks shelf, we have separate tabs for all. Now this simply means when you, let's say, change the size, or decrease the size, automatically both your graphs will correspond to whatever changes you make under the all tab, right? When you click on sum of sales, only your sales line graph will act according to the changes that you make in this space under your sum of sales, right? Now let's say I'm changing this into a bar chart, or you can have it as a circle mark, right? So only your sum of sales graph will correspond to whatever changes you are customizing using this tab, using these options under sum of sales. And the same with sum of profit, right? I would like to change the color, so only this particular line chart which corresponds to the profit will reflect the corresponding changes, right? So this was just one point. When you go in for a, when you have two measures, you have separate options, separate marks cards which are available for each measure, as well as a generalized marks card which is available for both your charts, right?
Just a quick info, guys. Intellipaat provides Business Intelligence Master's Program in partnership with Microsoft, the course link of which is given in the description below. Now, let's continue with the session.
And I have my corresponding sales, right? Now, by default, whenever you have one measure and one dimension, it is automatically a bar chart that gets created, right? So this is the first combination. Now, what happens when I have one date dimension and one measure, right? So it is automatically a line chart that gets created. when you have, it might be in any order, it might be, you might have a measure in rows and a dimension in columns, or just the other way around, it doesn't matter. But for a combination of date, dimension and a measure, it is always a line chart that gets created. You can very well go ahead and change it into a bar graph or any type of chart as per your requirement. But automatically, for this combination of one dimension and one measure, it is a line chart that gets created. Right now, similarly, you have, let's say, two measures. When you have two measures, you have the shapes marks card that comes, that is automatically used under your marks shelf, because it is a scatter plot chart that gets created when you go in for two measures in your visualization in your row and column shelf, right? And similarly, when you have two dimensions, let's say I have my subcategory and category, okay, it is automatically a text table that gets created for the combination of two dimensions in your row and column shelf, right? So we have a text table when you have two dimensions, you have a scatter plot chart when you have both as measures, you have a bar chart when you have one dimension and one measure, and you have a line chart when you go in for one date dimension and one measure, right? So these are a few basic points. As you start using Tableau, definitely you'll be, getting to know all these in the flow, right? So this was just for information about, what type of chart gets created automatically for the different combinations with which that you bring into visualization, right? So as I told you, you have we just had our region and sales. Okay, by default it is a bar chart that gets created, but I can also go in and create a line chart. Okay, and so and you can also have a date line chart. Hierarchies, when you make use of a date dimension for which Tableau itself has created a default hierarchy, you can just go ahead, you can have a separate line chart for every year or for every quarter. Okay, or you can also change it into a continuous year, right? We'll have it as a continuous year with the measure, after which you have a line chart for it, and then you can keep going ahead in terms of your continuous date field, right? So now there are a few differences between using a discrete date field and continuous date field, right? So this is basically how each discrete date field and continuous date field act when you try to visualize data using these date fields, right? And you can also, let's say, bring in categories or any dimension in the colors mark, after which you will have a separate line chart for every category, okay, that you have in your data set. Or you can also bring in region, right? So you have a separate line chart depending upon the sales in a continuous month format for the different regions that you have in your data set, right? So this is how you color your line charts. This is known as a colored line chart. Okay, so these are the different options with which you can go in for a line chart, right? And next we have bar chart, right? So again, bar chart is something that we've been using. Let's say we have our subcategory with the corresponding sales. Now this is a vertical bar chart. You can just swap your pills to create a horizontal bar chart, and you can just place in, let's say, ship mode or any dimension, after which you are creating a colored bar chart, right? Now this becomes a colored bar chart, and you can just, let's say, I'll show the filter for the dimension category, and this becomes an interactive bar chart because you're interacting with your bar chart. Okay, and then we have something called as a leveled bar chart. Now when I bring category also into the view, we have a separate pane for every category under which the corresponding subcategories are placed, right? This is known as a leveled bar chart. So basically we have the horizontal vertical bar chart, we color our bar charts, we make it interactive, and you can also have such bar charts known as leveled bar charts. Now when you click on your sorting options, there's a sorting that takes place for every category. Okay, so yes, now these are again a few options while creating bar charts. Next, we have pie charts. I'll just show you. When you have two measures, it is a scatter plot chart that's created, and I would like to split this plot into, let's say, I'll have different subcategories. You can place it into the details mark, right, by which the same shape has been given for all your subcategories, or you can also place it into the shapes marks card. Okay, after which you will have a separate shape that has been given for the members in your dimension called subcategory, right? Now this is again called the shape legend. Okay, just like we have our color legend, this is known as, we also have our size legend, and this is, this is known as the shape legend. It is just a key which indicates that for which particular shape, which category belongs to which particular shape. And as you notice, we have repeated shapes over here because, this particular palette that we are using consists of only around 10 different shapes where we have 17 subcategories. You can just go in and choose from the set of palettes that are available, right? You can make use of these arrows, right? Or you have these thin arrows or weather related shapes, right? So these are a few options that you can make use of. Okay, so this was about the scatter plot chart and how you can make use of the marks card, the shape card in your marks shelf. Okay, this was about the scatter plot, and you can again make your scatter plot chart colored or interactive, right? And we also have the option called drop lines. Now let me bring in subcategory into detail. And now when you click on any one plot, okay, when you just right click, you have this option called drop lines, right? I'll just say show drop lines. Okay, and again when you right click on any plot, you have an option called edit drop lines. Now these are lines dropping from any plot that you select, right? Your lines drop both to your x-axis as well as to your y-axis, and you can just customize them. I would like my line to drop only to x-axis, okay, and I would like the line to be dropped always, and not only when I select, but I want the line to be dropped always. The line is supposed to drop to x-axis, right? Just click on OK, after which for all the plots in your graph, there's a line which is dropping to x-axis. Now this doesn't exactly show where your line is dropping or what value in which your line is dropping, right? You can also customize that. Let's say I'll go in for only when selected, right? And I would like the line to drop to both to x-axis and y-axis. Okay, and I would like to give an automatic label as well, right? Now when you click on OK, now only when I select any plot from my graph, right? Let's say I'm selecting this plot. Now there's a line dropping to both x and y axis, as well as we have the value that has automatically appeared at the end of the line. So with this, we can clearly identify what is the exact value this line is dropping at, or between these what values this plot has been plotted out, right? So this is just for your convenience. When you go in for a presentation, you can just have such drop lines. So whenever you click, you select any particular plot, you will have lines dropping, you will have the exact value where on which your line is dropping for this particular plot, right? So this is what drop lines are all about. And next we have the bubble chart. So when you look under show me, you have packed bubbles. Okay, you have one or more dimension and you need one or two measures in order to create a bubble chart. Now let's say we'll have categories and we have the corresponding profit, right? And as I told you, by default, with a dimension and a measure, you have a bar chart that gets created, right? But when it comes to packed bubbles, we will have to go into show me and then select packed bubbles. Now this is how a packed bubble chart looks like. You have circles and you have a number of circles and you have the size of circles. Now the number of circles is decided by the dimension, right? Because the number of values, the number of members in your dimension decide the number of circles, okay? And the value of your measure decide the size of every circle, right? For example, I have my subcategory. You can also create a chart by simply clicking on one dimension, press Control from your keyboard, click on any other measure, and then go into show me, after which you will be able to see what are the different types of charts that can be created with this combination of one dimension and one measure, right? You needn't have to bring them into the visualization and then create a chart. You can just click both, any of your dimensions and measures, and then go into show me and select that particular chart, right? So we're under subcategories, we have 17 subcategories, and that is why we have 17 circles right here in our bubble chart. Okay, and the size of every circle is decided by its value of sales, right? So we have phones with the greatest value of sales, and that is why phones is having a larger circle compared to all other subcategories. Now there's one limitation while going in for a bubble chart, right? It is always better to avoid going in for bubble charts with dimensions having more data, right? For example, if I would create a bubble chart for customer names, right? I have quite a long list of customer names. Now, when I go in to create a bubble chart for customer names with their corresponding, let's say, profit or quantity or sales, okay? Now, this is how your packed bubble chart appears. Okay, it just forms a cluster. We are not able to clearly identify or analyze any information as such from this type of a graph, right? So it is always better to avoid using packed bubbles when you have more data. But when you have a limited number of members in your dimension, you can very well go ahead. Let's say, for example, ship mode and its corresponding profit. You can very well make use of packed bubbles, right? Where the number of bubbles is decided by the dimension and the size of bubbles is decided by your measure, right? And this was about the packed bubbles chart. We also have tree maps, okay?
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
When I click on tree map, you have technology, office supplies, and furniture, right? When it comes to tree maps, as I told you, it is very similar to a packed bubble because the number of boxes, it might be a square or a rectangle, the number of boxes in this tree map is decided by your dimension, right? So under the dimension called categories, we have three different categories. So we have three different boxes, and the size of each box is decided by the sales or whatever the profit, right? So profit is our measure over here. So whatever is your measure, depending upon the value of that measure, your size, the size of your box is decided, right? So again, as I told you, the number of boxes is decided by the dimension and the size of each box is decided by your measure. Okay, and when it comes to tree maps, the main visual element of tree map is known as, it is also known as a space filling display, right? So when you notice, we have only three members in this dimension called category. but still the entire space in our worksheet has been occupied by this tree map, right? Or let's say I would have subcategory wise sales for which I'm creating a tree map, right? And even then I have the entire space in my worksheet that is occupied, right? Now this is why we call tree maps as a space filling display, because it occupies the entire space in our worksheet. And in this example, we have our subcategories. We have 17 subcategories. So the number of boxes is equal to the number of members in your dimension. And the size of each box is decided by your measure, which is nothing but sales in this particular example, right? And I'll just show you. Let's create a hierarchy. Let's say I have my country and my state, right? I'm just creating a hierarchy for this. And let's try using this hierarchy and create a tree map, right? As I told you, we only have one country called United States under the dimension called country, right? Even then, the entire space is occupied in my worksheet, right? And when I drill down, so under this particular country, we have so many different states for which a tree map has been created. So you can also make use of hierarchies while creating tree maps, okay? And this is one important point. It is known as the space filling display. It is the only chart which occupies the entire space, no matter what measure or what dimension you make use of to create a tree map, right? And again, when it comes to tree maps, you can have an interactive or a colored tree map, right? So any chart for which you simply create a quick filter, that becomes an interactive chart, okay? And you can also color them out. Let's say, for example, I'll bring a category into the colors marks card, after which your tree map has been divided into 3 different colors depending upon whichever category your subcategories belong to, right? And you can make it interactive in nature using your quick filter, right? So this becomes an interactive tree map as well as a colored tree map, right? So this was all about tree maps. And then we have pie charts, right? So now let's see how to create a pie chart and what are the different options and what are the different types of pie charts that you can create in Tableau, right? Now you can simply click on one dimension. Let's say we'll have a region and the corresponding sales, okay? And under show me, you can go in and create a pie chart, right? Or this is one way by which you can create a pie chart, or you can simply, let's say, drag in categories, the corresponding sales, and under your marks, in your marks shelf, you can choose your pie marks card, right? After which you will have a separate pie that gets created for every single category, okay? Or you can simply bring in the sales value and place it into your visualization, right? And then choose pie from your marks card for which a pie chart has been created for the entire value of sales, right? And then you can bring in any dimension in your colors marks card, right? So these are a few ways with which you can go in and create a pie chart, okay? And now let's see what is a donut pie chart all about, okay? And when you would like to create a donut pie chart, we need to have 2 different pie charts that is combined together, okay? Now why do we call it as a donut pie chart? Because it resembles a donut, okay? I'll just try and visualize. I'll visualize and then let you know. You'll be able to clearly get the point why it is known as a donut pie chart. And in order to do that, we will have to combine 2 pie charts, and combining 2 different charts is done with the dual axis option that we have, right? And in order to create a dual axis chart, we need to have 2 measures, right? Now we will be making use of, let's say, the number of records, okay? This is an auto-generated field, and we'll be making use of number of records twice in our visualization, and this is just for creating a donut pie chart, right? So because we need two measures to create a donut pie chart, we are going in for this measure called the number of records with an attribute aggregation, right? Which means it cannot be partitioned further, right? Or it cannot be, you cannot partition the data, right? So we'll just quickly look into that. We'll have our number of records and I'll have it as an attribute, right? Then again, we'll have our number of records. You can either go in for a dual axis chart, or you can also change it into a pie, okay? And then go in for a dual axis option, right? Where you can just decrease the size, right? Fine. And my first, I'll just change the color. Okay, why is my color not changing? Right. So I've just changed the color of one of my, number of records, one of my circle, right? And let this be blue in color. And then I'll try increasing the size, or I'll try decreasing the size for the second number of attributes, right? So you just have to first make sure which circle corresponds to which number of records, right? Whichever, I mean, both will be overlapping on each other. So you'll just have to make sure which circle corresponds to which number of records and then make the necessary changes, right? So I'm just decreasing its size. I think this looks better. Now this resembles a donut, right? That is why we basically call it as a donut pie chart. Now let's have, yes. So yes, this resembles a donut, and now let's try adding details to it. Now in my second circle, which is the inner circle, okay, I've just given it to be the same as the background color, just to resemble a donut. Okay, I'll just make sure it's my second circle. Yes, now in this second circle, I'm going to place my entire value of sales. Okay, and in my outer circle, I can place any dimension, right? For example, I'll bring my categories, place it into the label part, right? And categories, and place it into the colors part, after which you have a separate color that you have given for every category, and you have the entire value of sales. And you can also bring in sales and place it into the label part right next to every category, right? So this is how you create a donut pie chart. Now this is just for visualization purpose that we are making use of number of records. Okay, and this is just another way that you can make use, that you can use to visualize, to represent your data, right? Rather than going in for a normal pie chart, you can just try this out. Okay, and then we have heat maps, right? Now let's see what is a heat map all about, and I'll let you know how to create a calendar, how to visualize a calendar right here in our worksheet. Okay, now basically heat map is a visualization where marks on your chart are represented as colors, right? So as the marks heat up due to the higher values or density of records, a more intense color is displayed, right? I'll just show you. Let's say we have our month of order date. Okay, we have discrete months, and let's say we have our subcategories. So now when both are dimensions, we get a text table by default. Okay, you can just bring in sales in color. Okay, and we'll also have sales in size. Okay, and then we'll have the mark as circle. Okay, now so you can also increase the size of the circles a little bit, right? So now as the value of sales increases, the intensity of the color in your chart also increases, right? So darker the color, darker the value of sales. Okay, so this is why we call it as a heat map, right? Your marks heat up due to the higher values of whatever your measure is, right? And when it comes to a heat map, you can also decide the color using one measure and decide the size using another measure, right? Let me decide the size by profit, right? So though fonts is darker in color, the size is lesser when compared to copiers, right? Which means the size is decided by, the size of the circle is decided by the corresponding profit, and the color, the intensity of the color is decided by the sales, right? So in this heat map, we are making use of two measures. One measure decides the color and one measure decides the size of the circle that we have in our heat map, right? Now let's see how to create a calendar. Okay, so we'll be making use of this heat map to create a calendar, and for that we need to create a few calculated fields, right? As I told you, we'll be creating, and this will also help you go through, help you understand of what different calculations can be used, right? So this is just for a practice purpose. So let's try creating a calendar. Let's try visualizing a calendar right here in our worksheet. Okay. And for that, we'll be making use of a few calculated fields, right? So my first calculated field, in order to create a calendar, we need the week days, we need the week numbers, we need the day numbers, and the month names, and also to which particular year that particular month belongs to, right? So we have quite a lot of things that needs to put up into our, that we need to calculate and fetch out from the data that we have in order to create and visualize a calendar, right? So first, let me fetch the weekday names, okay, which means the weekday names as in Sunday, Monday, and so on, in order to visualize, bring in my calendar. So I'll just call this calculated field as weekday, and I'm going to make use of the date name function, okay? And you have the syntax and you have the explanation and you have an example for it, right? So the date part that we are going to fetch is the weekday, okay? And we are going to fetch the weekday names from the field called order date, right? So this is our first calculated field, okay? I hope it was quite simple. Just click on apply and okay. So we have our weekday. Next, we need the week number, for which we are creating another calculated field. Now, week number. So in year, we have around 53 weeks, right? So in order to clearly display which particular week we are visualizing in our worksheet, we need this week number, okay? And again, we are going to make use of the date name function. We are going to fetch out the week from the order date. Now, when I complete the visualization, you'll clearly be able to understand what is the purpose of every calculated field. We also go back to every calculated field and we will try going through it again once we complete the visualization, right? And next, we need to fetch the year to which your the month in your calendar belongs to, right? That is why we are creating a calculated field for year, and we have inbuilt function called year, which simply fetches and displays the year of whatever field that you specify in its inside the year function, right? Just click on apply and okay. So we have our year, we have our week number, and we have our week day. Then we need the name of the different months, okay? I'll call this as month name, and we are again making use of the date name function. This time we are going to fetch the month part from the order date, right? Click on apply and okay. And finally, we need the different days of our month, right? So that is why we are creating another calculated field called day. We will make use of the date part function, okay? We are going to fetch the day part from my order date, right? Just click on apply and okay. So now we have our year and day which has been brought under measures. I'll just place it under dimension, okay, because I need discrete values of this calculation. right? So now next we have our year, we have our month, we have the weekdays, week numbers, and the different days of every month, right? Next step is to visualize all these, is to visualize a calendar using all these calculated fields, right? So first of all, we'll bring our weekdays, place it into columns. So we have all the weekday names right here, okay? And then we have the week numbers that I'm placing into rows, right? So we have around 53 weeks, okay? And then we need to filter out year and month because I need only one particular month of one particular year calendar to be displayed in my worksheet, right? So that, I mean, for that purpose, I'm just showing the filter for month name as well as showing the filter for year, okay? And we will be changing this into a single value drop down, okay? And this also as a single value drop down. You can also have it as a single value list. Just to save the space, I'm going in for a single value drop down, right? In this manner, we are just visualizing only the month of January, which belongs to the year of 2015, right? So this is why we basically made use of our filters, okay? Right. Next, so this is the first week number. When you simply change it into, I would like to say 2017, the month of August, right? So the week number changes accordingly, right? So as a next step, we will bring our day into the text part, okay, where we have the different days, and we do have a few blanks, missing dates in between. And as I told you, this is because the data set that we have been provided with does not contain information regarding this particular date. For example, August 10th of 2017, there was no entry made. There's no entry, there's no data available in our data set for this particular date. That is why it has been left blank, right? So as a Tableau developer, we are just visualizing whatever data has been provided to us, right? So these missing values, it doesn't matter. It is again purely based on your data, right? So we are not concerned about that. We are just trying to visualize with whatever data that we have been connected with Tableau, right? So we have our calendar for every month of any year as per your requirement, okay? And then you can just try to color them out. Let's bring weekday into the color marks card where you have a separate color for every weekday, okay? And you can also change the mark to square, right? After which you have a square right next to every day number. And under the label marks card, you have an option called alignment. I'll change it into center aligned so that they are placed right in center of my box of my square, okay? And next, you can just increase the size of your square. Let me just, yes, you can increase the size of your square, and then you can change the font color to black. You can make it bold, right? So all these colors are purely depending on your requirement. Okay, however you would like to visualize it, you can just go in for that, right? And you can increase or decrease the size. You can edit the label, your size, your font, your color, okay? And you can also edit colors, okay? You can change the colors as per your requirement, right? So this is how you display a calendar, okay? You bring a calendar right here into your worksheet, okay? You can just say, I would like to view the calendar for the year 2016 and the month of December, right? So you have a perfect calendar that has been visualized, that has been brought right here in your worksheet with just a few simple calculated fields that we created. One to fetch the weekdays, the weekday names, to fetch the week numbers, right? The year to which it belongs to, the month to which this particular calendar belongs to, and finally the days that we have simply placed into the text part, right? So after which we have just enhanced our visualization, okay? And as I told you, you can also have it as a single value list, okay, with such radio buttons. You can simply try using this as well, okay? And when you go in for all, you have all the different months of all the different years that has been brought into visualization, right? So this is just a calendar that we have created, and using a few calculated fields Tableau, right? So this was about creating a calendar with Tableau, right? So what's the real-time scenario for calendar, right? So you might want to have one sheet which is exclusively meant for calendar. So when you go in for dashboards, when you have multiple sheets, you can have a parameter, right, where you're allowing the user to simply choose a year, or you can have such interactive filters, right, where the user will choose a particular year and month whose corresponding data is displayed. And you can also have one sheet which displays this calendar, so that the user can easily identify which what are the missing dates, and anything regarding the calendar of that particular month, right? So this is just for your convenience. Again, if you would like to include this in your dashboard for additional information, then you can just go ahead with that, right? So this was basically just how to visualize your calendar. And real-time scenario, in the sense, again, as I told you, it totally depends on your whatever data you're trying to visualize and whatever is your real-time scenario. If you are in need of it, if you would like to given a calendar, given a worksheet for a calendar as such, you can just go ahead with that, right? So yes, and the difference between a heat map and a tree map. Now, heat map, as I told you, it the the colors, your map, your chart itself, the colors in your chart gets the intensity depending upon the value of your measure, right? Whereas when it comes to a tree map, it occupies the entire space in your worksheet. You have the structure, which is decided by the dimension, and the size of your structure, the size of your box, your square or rectangle, the size is decided by the measure, right? So both are completely different. They are not the same, right? So these are just different ways by which you can visualize your data, right? So whichever type of chart you feel is appropriate for visualizing the data or analysis that you have made, you can just go ahead with that. We also have something called waterfall chart, and we have, I think, some two or more, three types of charts that can be discussed about. We have something called as a motion chart, right? So we'll just look into that. And when it comes to real-time scenario, it is all up to you to decide which chart will be appropriate, okay, in order to visualize your analysis, your data that you have made with the data that you have been connected with Tableau, right? So I'm just telling you, these are the different options that you can make use of, right? And it is all up to you to decide which will be appropriate for your requirement and for your analysis of your data, right? So I hope you're able to get what I'm trying to say, all right? Waterfall chart, it is just effective for dashboards, right? And for displaying the effect of positive and negative values, right? Now let's say, for example, how sales or profit goes from one place to another, like a waterfall, right? So that is why we call it as a waterfall chart. And let's say, for example, we have subcategories and we have the corresponding sales, right? And in our marks shelf, I'm going to make use of the Gantt bar, okay? And then sort it out in descending order. And we will just make use of this measure in the size as well as in the colors marks card, right? So this just resembles a waterfall, just tells of how your sales moves from one subcategory to another, okay? And this is just another way by which you can visualize your data, right? And we also have funnel charts, okay, that you can create using Tableau. Now, these are a few types that is not readily available under Show Me, okay. Under funnel chart, we have a basic funnel chart and we have something called as an advanced funnel chart, right? So with funnel chart, you can just represent, let's say, your measure at different stages or sectors, right? Now let's see how to create a basic funnel chart. I'll have my sales, okay, and I'm going to make use of this segment in the size marks card, okay, and then I'm going to make use of the segment in my colors marks card. I'm just coloring out the entire value of sales depending upon these three segments in my dimension, okay, and size is going to be decided by the measure, okay, and I'll just make it into an entire view. And here we have our basic funnel chart, right? And you can simply label them. Let's have the different segments, their corresponding sales. And here in this sum of sales, you can apply a quick table calculation of percent of total, right? So with this type of a visualization, the audience will clearly be able to understand, right, the sales value of which segment is higher, is more when compared to the other segments, and what is the contribution of this particular segment to the total value of sales in terms of percentage, right? So this is how you go in for a basic funnel chart. So first I had my sales in the view, then I just colored it out using any of my dimension, okay, and then I brought in the measure to decide the size of every segment, right? And then we have our funnel chart. You can just make use of any measure, any dimension, and go ahead and create such a funnel chart, okay. And let's see what is the advanced funnel chart all about. Now for this, let's make use of the ship mode. I have the different ship modes, and let's have the corresponding sales, right? And in my marks card, I'm going to go in for my area. I'll just swap this up and I'll have it as an entire view, okay? We'll sort it out in descending order. So now this is the different ship modes and their corresponding sales value that has been plotted out in our graph, right? And it is an area mark card that we have used, okay. Now this resembles half of our funnel, right? This just looks like half of our funnel. Now just for visualization purpose, just to bring in the image of an entire funnel in our worksheet, we are going to make use of a simple calculated field, right? Now this is displaying the positive of sales, the positive sales values, right? Now when I create a simple calculated field, I'll just say negative of sales, right? Just click on apply and okay. Bring this calculation, place it right before the actual sum of sales. And then you have the mirror image, the symmetric part, the left side of our funnel that has been brought into visualization, right? So now this looks like a complete funnel. As I told you, this negative of sales, the calculated field that we have created, is just for visualization purpose, okay. Just to complete the image of a funnel, we are making use of this calculated field, right? Now when it comes to enhancing the visualization, I'll go into the sum of calculation, which is nothing but this left part of my funnel. I can change the color of it, okay, and I'll label it using the different ship modes, okay.
Just a quick info, guys. Intellipaat provides Business Intelligence Master's Program in partnership with Microsoft, the course link of which is given in the description below. Now, let's continue with the session. Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
my requirement, right? So this is how you create an advanced funnel chart. Okay, and this mirror image or the left part of our funnel chart has been created using the negative value of whatever measure with which the right side funnel has been plotted out. Okay, and this is just to complete the image of a funnel. Just for visualization purpose, we have created this calculation, right? So this was all about an advanced funnel chart. And finally, we look into what is a motion chart, right? Now, as the name tells you, your chart appears as if it is in motion, right? So that is why it is moving. That is why we call it as a motion chart. And we've already gone through the filter shelf, and we are, going through the marks shelf then and there. We are making use of the different marks cards. We've also gone through what is a column shelf and a row shelf. Now we have this page shelf, right? So we'll be making use of this page shelf to create motion charts. Okay, and let me say, for example, if I'm using region and if I'm placing it in my page shelf, okay, there's a separate page that gets created for every member of my dimension called region, right? So under region, I have 4 different: central, east, south, and west, right? So when I make use of these options, I have a separate page that has been created for every single region, right? When you make use of these arrows, we have this page is for central, this is for south, and finally we have a page for west. So every member, every value of this dimension will have a separate page that gets created. Okay, and let's say, for example, I'm bringing in my order date. Okay, and then I'm bringing in the order date in terms of let's say month. Okay, and the corresponding sales. Okay, now if I make use of these arrows, you have a separate line graph that is plotted for every year, right? So you have this dimension called order date that has been placed into a page shelf. It has 4 different values: 2015, 2016, 17, and 18. So every year has been allotted a separate page, okay, that you can go through using these options, right? So we'll just go back to our first page, which is 2015, right? You can toggle between these pages using this drop down arrow, or you can make use of these arrow marks right next to them, or this slider with which you can just toggle between these years, right? And you have this option called playback, play, and you have stop option. And you also have 1 horizontal bar, 2 horizontal bar, and 3 horizontal bars. Now this is the speed in which your chart will move. Okay, your pages will move one after the other, and this is the slowest of all, this is the normal speed, this is the fastest of all, right? Now when I go in for the slowest speed, okay, when I click on this play option, you just have to make a note over here. We had our 2015, next comes the 2016, then comes 2017, and then comes 2018, right? So once you click on this play button, automatically the pages start appearing one after the other, okay, depending on whatever speed you have wanted your pages to move in, right? If I go in for a normal speed, when I click on play option, now this is a little faster. Okay, now this is how your different years, whatever data is present, whatever chart is present for every year of this particular dimension will be appeared as if your chart is in motion, right? And you can also look into the fastest of all. This is going to be too quick, right? You can just make a look, you can just note this part over here, which tells you which year this particular page or line graph corresponds to, right? Now, when I click on play button, you just have to make a note on this year. Now I'll click on play, and as I told you, it was too quick, right? Of how the line moves from one year to another, right? Your pages are moved, are your pages appear one after the other, okay, of whichever dimension you have placed in your page shelf, right? Now you can also go in for a continuous month, right? When you go in for a continuous month, let's say I'll go in for a normal speed, and here you have the line graph for the first year, second year, third year, and the final year. This is how your chart moves, right? So depending upon whether it is a discrete date field or a continuous date field, you can display this motion chart, okay? And this option called show history, right? Now, when you click on play button, we have quite a lot of options on show history, right? For example, let's say I would like to highlight, I would like to show the history for all the marks, okay? And you can just format the amount of fade or the formatting color, okay? And now when I click, now as you notice, you have a faded history, a faded line chart for the past years, for the history, right? So we have shown history with a particular amount of fade, okay, for the previous years. So which means when I click on play option, we have the first year, second year, third year, and the final year with the past years whose line graphs is faded in nature, right? So this was about how to show the history. And when it comes to marks, trails, or both, this is right now unavailable, right? Only when you choose the circle mark from your marks card, you will be able to select trails or both, right? If I say show only marks, when I click on play button, only the plots will be highlighted in history, okay? If I say show trails, right, this is how it appears, okay, as of from where the how the starting of this, and what is the trail between, between these different line graphs of these different years, right? Now if I say show both, okay, and you can decide your, again, your color, your trail format, whether it should be a dotted line with this thickness or this color. These are the formatting options. Now when I click on play button, right, now this is how it appears, right? So you are just showing your history, okay? You can also show it only for the last, let's say, 2 months, right? And you can show marks, you can have separate color, okay? So it is all up to you, right? So for only for the previous 2 years, you are displaying your history, right? So yeah, so basically your chart appears to be in motion, and that is why we call this as a motion chart, okay? So any dimension that you place in your page shelf will, every member of that particular dimension will be allotted a separate page. As we also went through region, you can also have categories, right? So for every category, you will have a separate page that gets created, and you can create any bar chart or any type of chart over here in the worksheet, in the workspace, which will be available only for this type of category. And you can make use of these play options, the speed options. You can also customize. When you click on this drop down arrow right next to your title called category, you can either remove the title, you can edit your title, whatever it is supposed to be, you can customize it, which means you can, for example, remove the slider, okay, or you can also remove the playback controls, you can remove history controls, you can also remove the page readout, or you can bring them back, bring the slider back, right? So these are a few options that you can customize of how your page shelf option, your page, your motion chart options should appear in your worksheet, right? So this was about a motion chart. It appears as if your chart is in movement, is in motion, right? And that is why we call it as a motion chart. Okay, so we have just gone through all the different types of charts and graphs that can be created with Tableau. Okay.
And this quickly brings us to the roles and responsibilities of a Tableau developer. There are lots of roles basically when it comes to Tableau, and the most important thing that you need to know is that it is basically well suited to the people who really like problem solving skills. They want to be a team player and they know how to manage their time very effectively, and this is done to ensure that they all meet their timelines and keep to the projected schedules as well, guys. So there are more than 5 roles which Tableau developer can assume, but the 3 main ones which the companies are hiring for on a constant always are Tableau developer, analytics engineer, and a business intelligence architect, guys. So you can be called as a Tableau developer, an analytics engineer, or a business intelligence architect if you are a certified Tableau expert, and if you pretty much have good experience working on with Tableau, or that you want to learn, and after learning, mastering the concepts and having a certificate, you can pretty much exploit all of these designation, guys. So coming to responsibilities, the most important responsibility in my opinion is the first point, because again, you need to develop, you need to maintain, and you need to manage advanced reporting, guys. It's not just basic XY axis and put some graphs. You just saw what the analytics looks like. So you need to manage advanced reporting, you need to do very good dashboarding, and you need to provide other business intelligence solutions at the same time. And then you need to be performing very good data analysis, you need to document whatever you're doing, you need to provide validation to the data that's being processed, and you need to know how you can design and map these data and convert it from raw data into good information as well. And the third point is pretty much you need to be on the roll, you need to be a runner when it comes to this, because you need to review and improve all their existing systems. You need to collaborate with brand new teams, brand new people, lots of teams, to basically integrate all of these new systems in case they're using any legacy or old applications, guys. And then after this, you need to conduct a lot of tests, because again, unit testing is something very important when it comes to Tableau. And then you'll be developing very good amount of database queries, because you need to know how these affect your visualizations, right? So basically, you'll analyze whatever the effects that your dashboarding brings about, and then if there are any issues with that, you can troubleshoot the same, fix it, test it again, and do all this again. So the last point is again creating amazing tools to store data within the organization, because again everything from storing data, managing data, analyzing data, and putting out dashboards, you as a Tableau developer will be responsible for all of these, guys. And this quickly brings us to the skills of a Tableau developer. There are 3 major skills of a Tableau developer that are considered very important: programming skills, statistical skills, and data handling, guys. And I'm sorry. Coming to programming skills, again, having very good statistical programming languages and having knowledge in them, like Python and R, is a very good skill. And at the same time, knowing a statistical language is not as important when it comes to if you cannot make it talk to data. So having a good database querying language and knowing something like SQL is a great start as well. And having very good mathematical skills, very good understanding of statistics is a must. And being familiar with mathematical testing, statistical testing, distribution testing, maximum likelihood estimators is also a requirement, guys. And this basically will help you achieve better analytics. And guys, do not be overwhelmed by the skills that you need to become a Tableau developer. Again, you will be trained on all of these, and after being trained, all of these will look very simple to you, because at the end of the day, if you're training with a good certification program, it will make you an expert in all of the skills that's being shown on your screen right now. And then coming to data handling, again, you need to understand the data you're working with, you need to wrangle through the data and see how it works, because if the data can be exploited in a good way, it can pretty much give you great analytics, and you can drive all of your models, whatever business requirements you have, through a success, guys. And after this, again, as I've been telling, data is very unruly, data is raw, and it needs to be refined all the time, and making sure that you're using the refined data to give visualizations are very important as well. And knowing data management techniques are very good, and they form a very vital requirement as well, guys. And this brings us to the average salary of a Tableau developer. I've broken it down into 2 terms in the United States of America and in the subcontinent of India, guys. So a junior Tableau developer in the USA gets somewhere around $75,500 annually, and in India gets a junior Tableau developer gets somewhere around 7 lakhs per annum. And then coming to a senior Tableau developer with some amount of experience, very good certification, and great knowledge, gets a package of somewhere around $105,000 in America and 17 lakhs per annum in India, guys. So these are average numbers, and there is no hard and fast rule that you will get these numbers again. You can get 15 lakhs per annum for a junior developer, 25 lakhs per annum for a senior developer as well, guys. It all depends on your skill. It all depends on how good you are, because the companies these days don't mind paying a lot if they know you are good at what you do and you bring a lot to the table, guys. Irrespective of where you are, irrespective of what money you ask for, if you're damn good at your job and if you are certified and people know you're hiring, people know that you have put in some work to understand the data and you can drive their business to success, they are ready to pay lots more amount, guys. So this quickly brings me to the learning path of a Tableau developer. Well, the most simple way that you need to go about learning Tableau is, again, first you need to understand the basic W's of data analysis, guys. Why, what, when, who, and so much more. All the questions which start with W will be your first starting point of data analysis. And after that, you will be learning the basics of mathematics and statistics. And after this, you'll be learning all the data blending techniques where you'll be understanding data, churning through data, and figuring it out. And after all of these, you'll be working with data hands-on by learning a couple of database technologies, querying, SQL, and so much more. And after that, finally, you'll be using all of the 4 skills you've learned previously, all the routes that you have taken to come there, to visualize all these data, to create reports, dashboards, and to go on to become a certified and pretty much a very good Tableau developer as well, guys.
Now, moving on to what exactly is Power BI. So it is a business analytics tool which was developed by Microsoft in 2013. It is generally used for interactive data visualizations and business intelligence. It provides an interface which is easy and simple to understand and work with. End users can create their own dashboards and reports using Power BI. Right. Now, as we've discussed about these tools in a brief, now let us discuss about the data visualization in both of them. Right. So first and foremost, let us understand what exactly is data visualization, guys. So data visualization is nothing but representing the particular data in the forms of charts, diagrams, graphs, and so on. Instead of going through the reports which are made up of complex and large amount of data, you can just use graphs, diagrams, charts, etc. That is, as they will be more convenient for the users to understand, isn't it? Which BI tool you should choose for data visualization? Well, it depends. If you're looking for a data visualization tool for customized data visualization, then you can go with Power BI, as you can drag and drop into the visualization through a sidebar and you can import the data as well, right? It also has opened up software development kit which helps to convert data from various data sources into interactive reports and dashboards. Whereas when it comes to data visualizations using Tableau, then it is majorly used for pure visualization. Like if you're looking for a more organized and clean approach, then you can choose Tableau. In this, data visualizations are created in the form of worksheets or dashboards. Right. Tableau provides connections to multiple different sets of data sources and it is majorly used for larger sets of data visualization in an organization. So it has additional drill down features also. Now let's move forward and discuss about few of the parameters based on which we will differentiate between both of these tools. So the first parameter that we have is performance here. So guys, in Tableau it can handle large amount of data from different data sources with better performance, whereas Power BI can only handle a limited amount of data here. Second parameter is the source of data. Power BI has limited access to the other servers and databases as compared to Tableau. For example, Oracle databases, PostgreSQL database, SQL Server database, SAP HANA database, and so on. Whereas in case of Tableau, it has got access to multiple number of different servers and database sources such as text file, JSON file, PDF file, Excel, statistical files, Microsoft SQL Server, MySQL, and Oracle, Redshift, and the list goes on. Right. Now, in the third point we have is the difficulty level of learning or learning curve. So guys, in Power BI, it is comparatively easier to learn as compared to Tableau. Even if we see from the learner's point of perspective or the business point of perspective, Power BI is comparatively easy to understand as well as easy to learn. I'm not saying that Tableau is very much difficult to learn or understand, but Power BI is comparatively a little more precise when it comes to such kind of terminologies, right? So now if we talk about its data capability, so guys, in Power BI, each group or workspace can handle up to 10 GB of data, and more than 10 GB of data are supposed to be in cloud or Azure, I would say, right? But if it is in local database, then Power BI just pulls the data and does not import them. But in case of Tableau, it works on columnar based structure, that is, it only allows to store unique values for every column, and that is how it is possible to fetch billions of records or rows in this. Right, now moving towards our fifth parameter, which is integration. So with integration, in case of Power BI, you can easily integrate with different data sources like SharePoint, Azure, Power Flow, Power Apps, 365, Excel, and many other Microsoft products. Whereas Tableau is used for more scalable approach here with different outsourcing tools as well, even including all of these Microsoft based tools as well as outsource based tools also, right? And the sixth parameter is about the data shaping. So as Power BI offers query editor, which allows its users to do many things in an easier manner, and it is more flexible. It also offers self-documenting and other features as well, whereas Tableau does not offer any of these kinds of services. Now the seventh parameter that we have is the data modeling. Power BI provides Power Pivot DAX, which are more accessible to the users, whereas Tableau does not provide any of them. Finally, we have application. So guys, Power BI is used for dashboards, custom visuals, and more like open source approaches. But Tableau is used for longer run operations and ad hoc analysis. As we have discussed about the parameters, now let us head towards the pricing part. So guys, when it comes to pricing, then Power BI is more affordable option as compared to Tableau, because Power BI offers three subscription tiers, that is Desktop, Pro and Premium. Desktop cost is not chargeable for its users, and Pro cost starts as $9.99 per user per month. Pro also offers 60 days of free trial, and in this server cost, web user cost, etc. is lesser. And the premium plan starts at $4,995 per user per month as per the storage resource.
Just a quick info, guys. Intellipaat provides Business Intelligence Master's Program in partnership with Microsoft, the course link of which is given in the description below. Now, let's continue with the session.
$35 per user per month, and Tableau viewer cost starts at $12 per user per month, which is a bit higher as compared to Power BI. So if you look at it from the initial cost perspective, then Power BI is way cheaper as compared to Tableau. But for longer run, that is total usage cost per year is lesser in Tableau. So guys, after knowing about pricing, let us differentiate them based on some of the functionalities of both Tableau and Power BI. First, we have in the functionalities is the support level. So guys, in Power BI, customer support is limited for users for free BI account, and it offers robust support resources and documentation, whereas Tableau offers comprehensive knowledge based support for its users. Now, if we talk about licensing, then Power BI has rigid licensing, whereas Tableau has flexible licensing. And in case of infrastructure, Power BI has SaaS or software as a service infrastructure, whereas Tableau has a flexible infrastructure here. And when it comes to scalability, for larger data set, Power BI has good scalability, whereas Tableau has much better scalability for larger data sets as compared to Power BI.
So, coming to the first question on the top Tableau interview question set, the first question usually goes with a comparison question because it is vital that you understand the differences. For example, the question states, compare ClickView with Tableau. I'm sure you already know that both of these are amazing business intelligence tools that you can work with very easily, and each of them have their own niche applications, right? So let's check out the differences. So whenever we talk about data integrations in terms of capability with Tableau and QuickView, Tableau has an edge over QuickView in this particular sense. And then whenever you're working with multidimensional data as well, Tableau has the capability to handle it that much better, efficiently and faster. And of course, most of us work with PowerPoints as well. So whenever you have a lot of work with PowerPoints, dashboarding on that and creating good amount of visualizations and insights on that is great, especially if you have the support for PowerPoint, right? The native support, and Tableau does that, while ClickView is a little bit held back in this regard. And then when we talk about scalability and visual drill down as well, right? In terms of visual drill down, background, yes, ClickView is amazing to work with and it provides good amount of efficiency. So you don't have to do a lot to have a big impact on the output. But then when you talk about scalability, right? Scalability, Tableau, there is no beating Tableau out here, because ClickView has a direct limitation applied because of the ability of it to maximize its usage of RAM, while with respect to Tableau, right? So it can scale, and RAM is not a limiting factor out here. So this is the basic comparison that you can state to the interviewer whenever you ask the comparison between ClickView and Tableau. And now, when we come to the second question, it states, how is the context filter different from all of the other filters? So one thing you always have to know is that whenever you create a context filter, right, what Tableau does for you is that Tableau will create a temporary table just for this particular filter. So when you create a context filter, Tableau will create one temporary table just for this particular filter set, and every other filter will get applied on the context filter, guys. So every other filter will get applied on the context filter as if it was cascading parameters, right? Pretty simple and straightforward. But then when you have created an actual context filter, let's say on an example such as countries, USA and India, what Tableau will do is Tableau will create a temporary table for both of these countries and all the data that goes into these particular countries as well. And let's say now if you have any other filters that have to be applied, and if you do not have any context filter, right, and every single record will actually be checked for filters and then applied if required. So if you have a context filter, make sure to mention about Tableau being able to create the temporary table and then mapping the data based on it, and later applying all of the context filter data on top of it. Now, moving on to question 3. Question 3 is again another follow-up question. It's regarding context filters itself. So the interviewer may ask, what is the disadvantage of making use of context filters? Well, the context filter is an entity that is actually not changed a lot around by the user, right? So what happens is, if you have to change these context filters, then in the backend the database has to be reamped, it has to be recomputed entirely, and whatever temporary table has been created during your first set of filters will be removed. It'll have to be rewritten, and all of these takes a lot of time, effort, and computation power as well. So at the end of the day, it's all about slowing down performance if you have to change your context filter. And then, whenever we are adding dimensions to context, right, what Tableau does, we already know this, is that it creates a temporary table. And one disadvantage with creating a temporary table is that every time we initiate a view, or every time we instantiate a view option, or check the output, so what usually happens with this is that since it's creating this temporary table, it will reload it every time. So creation of a temporary table leads to a lot of reloads as well. And one more important thing you have to know is that whenever we are working with tools like Microsoft Excel and Access, or let's say any other general, text data sources, right? So the temporary table that gets created actually gets created in the Microsoft Access table format. This can be a disadvantage if you cannot scale this into other tools, in case if you have any down the pipeline as well. And then of course, whenever you're working with SQL Server, let's say Oracle data sources, or even MySQL, you must have the explicit permission to create that temporary table on the server itself. So having these access parameters and having these permissions is very vital too. So the talk is not always about a single dimensional data, right? So whenever we talk about multi-dimensional data sources, temporary tables usually are not created for this, and context filters are basically defined through which an understanding on what filters are independent, what filters are dependent, and then later mapped and put into place. So since temporary tables here are not being created, and since you're basing it on the fact that it is either independent or non-independent, this might again take a little bit of hit as well. So these form to be some of the disadvantages of making use of context filters. Now, question number 3 states, what are the 5 main products that are offered by Tableau? Well, this is something you really should know as a person interviewing for a Tableau developer interview or any of the similar roles. So make sure to mention all 5 of these products. We have Tableau Desktop, we have Tableau Server, we have Tableau Online, we have Tableau Reader, and we have Tableau Public. With this, we can check out the next question, the 5th question, that says, what is the latest version of Tableau Desktop? Now, this is a very tricky question and it's asked in a lot of Tableau interviews, is what we've seen. And this is only done to make sure that you are up to date with the latest version of the tool, that you understand all of the change logs of what Tableau is changing around, right? See, Tableau, after it came out, it has had a huge number of changes. It's become very efficient now, it's become very beautiful, very easy to use, and all of that. Alongside this, there have been a lot of changes as well. So, what the interviewer expects with this question is to check if you are up to date on their website, to check out all of their latest offerings to make the full use out of it for your business intelligence solution as well. So as of September 2020, when we're recording this particular video, their latest version of Tableau Desktop is version 2020.3. That's March 2020. Well, moving on to the sixth question, it states, what is data visualization? Now, guys, data visualization, business intelligence, all of these are key questions that are asked in Tableau interviews. So make sure to pay attention, right? So whenever you speak about data visualization, you can talk about what it is, right? So what we usually do is we have data either in a structured or an unstructured format. It can be in a presentation, it can be in an Excel sheet, or it might come from a variety of different sources. So instead of looking at an Excel sheet which has probably 100,000 entries, we create beautiful looking dashboards through which we can gain some insight, which would have been very difficult to do with the naked eye unless we had this visualization, right? So that's the basic aspect of data visualization. You can have multiple graphics, you can have complex looking animations, and you can have aesthetically very pleasing to look at graphs as well. So this will help, especially whenever you have to pitch a product to a person who is not from a technical background, or let's say if you have to explain a concept to your juniors, or even in a business meeting where a lot of graphs will make more sense rather than an Excel sheet with 100,000 entries, right? So you can use an approach like this to answer this question. Now, moving on to the seventh question, it states, why Tableau? So the interviewer here is again trying to find out why and what is your inclination with making use of Tableau and where it shines. So you can talk about all of the advantages of Tableau, and two of the most important concepts that you have to talk about is about data sharing and how you can analyze it, and later it's about creating views and the ability to share it. Let's walk over with the first one. So let's say you have data from multiple sources, right? You might have a server on premise as well. You might have a database in that server, or let's say a database on the cloud, a data warehousing solution, a cloud application, or an Excel file, or a PPT file, whatever it is. With Tableau, you can analyze this very, very easily without having to put much effort. This is point number one. And then point number two, you can state is that, so it doesn't end with you creating beautiful looking visuals, dashboards and all of that. At the end of the day, you have to have the ability to easily share it across your team, across the floor, to make sure that people in your team and people from a variety of other teams can access to this, right? So you can have the sales team look at the data, you can have your data analytics team understand the data, you can have your data engineering team, in fact, come look at the data as well. So your ability to easily share this data, blend it and merge it with other data, and one important thing is to keep it up to date automatically, right? So all of these can be done very easily with the help of Tableau, guys.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. What are the components of a dashboard? A. Horizontal. B. Vertical. C. Image extract. D. All of the above. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So with this, we can check out the eighth question that states, what are filters and how many types of filters are there in Tableau? A filter, as the name suggests, is used to funnel data. So what are we funneling out here? So let's say we have 10 rows of data in an Excel sheet and we only want to see the data from one particular person, or let's say of one particular criteria. Let's say if you have the student details of a particular college, we want to filter them by name. You usually filter them by age. Let's say you want to pick up all the people, all the students in the college of the age 23 years. So applying a filter will make sure that the backend will run and it will only show you results of these students students who are of age 23, right? So we're trying to prevent unnecessary data in that context, and we're trying to only see what it is that we exactly require and then work with that. So for this follow-up question, which states how many types of filters are there are three types of filters, and we already checked out one, right? So there's quick filters, there's context filters, and there's data source filters. So make sure to mention all of these when this question is asked. Now, moving on to question number 9, it says how to remove the show all option from a Tableau auto filter. See, again, this is a question that is asked to see your proficiency in terms of handling the tool, even though you might not be sitting in front of the tool right now, right? So when you think about it, answer this question in a very simple way, in a very straightforward way. It's a very straightforward question with a very simple answer. So to remove the show all option, right? So all you have to do is right click on the filter, click on the customize button, and it's a simple check on the show all button, and this ensures that the option is actually, and this ensures that and then after you uncheck all of this, right, this makes sure that your option is removed. So since you're sitting in front of the interview, even though you might have a laptop, that's it is an added bonus that you first verbally say out the answer, and then of course you can run Tableau Desktop on your machine right then and there, and then show all of these practically to the interviewer as well. So make sure to keep that in mind. So moving on to the 10th question, it states, can we use non-used columns, as in the columns that are not used in the reports but that are present and used in the data sources in actual Tableau filter? So can we use non-used columns in Tableau filters? The answer is a very straightforward yes, right? So think about an example when you're approaching with this. So if you have a data source where you have employee data, right? So you can have employee ID, employee name, the department, designation, salary, and all of it. And let's say now we have reports where we're only using employee name and employee salary, right? So what you can actually do is you can apply filters on employee designation even though you have not used these reports from the data source, right? So it is very simple, it is very straightforward, and yes, it is achievable. We can make use of non-used columns, but then it has to be used in the data source, but then it really doesn't have to be used in the reports, guys. So moving on to the 11th question, it states, what is the benefit of Tableau extract file over the live connection? Well, when you think about Tableau extract file, right? So extract can be used anywhere without having to create a connection. That's the biggest advantage of it. So you can create your own custom visualizations without even having to connect to a database prior as well. So this is the ability provided by the Tableau extract file, where you can pull in all the data and work with it without even having to connect with that particular database as well. Now with this, moving on to the 12th question, it states, what is the difference between TWB and TWBX file extensions? Please explain. Well, one thing you have to understand is that whenever we talk about TWB, right, the Tableau workbook files, it is a live connection. It points directly to the data source, and whenever the user is receiving a TWB file, he or she needs permission to access the data source. And with a TWB data file, no data is included prior as well. So it's live connection. It points to the data source, and you need permission to access the data source, and initially there is no data that comes included with the file as well. Now, whenever you talk about TWBX file extensions, right, here what we're actually trying to do is we take the data offline and we store it on the local machine. So be it in a package, be it in a zip file, or any other packaging files where we completely remove this kind of dependency of having to need the permissions and having to have these access protocols in case if you do not have all of that as well. So TWB files require permissions from the data source, but then TWBX is all about bringing the data offline, keeping it in the native place, and to make sure that you avoid the need for permission as well. Now with this, we can check out the 13th question that says, what is the maximum number of tables we can join in Tableau? So this is a very commonly asked question, and you are supposed to know the answer to this, guys. It's a very straightforward answer. So in Tableau, we can have a maximum of 32 tables that we can join at a time, and no, it is not possible to combine more than 32 tables in a very straightforward way either. So make sure to answer this in a clear and a concise way. Now with this, moving on to the next question, it states, what are dimensions and facts? Again, it's a very simple example, but it always adds a lot of value if you can explain it with an example, right? So dimensions are nothing but the text columns where we are describing what the actual data is pertaining to that column, right? So you can have a product name, you can have the name of a city, and a lot of other things. So dimension is nothing but the simple description of what data we are trying to pull in from that particular column. And then when you talk about facts, right? Facts are the actual measures of data that you might have in that particular data set. So whenever you think about facts, think about numerical values, right? So you can have a profit percentage, you can have the profit in, of course, in monetary value, you can have the sales figures, you can have the sales in that particular monetary value as well, and a lot of other things. So when you think about dimensions and facts, it's a pretty simple concept. Now, moving on to the 15th question, it states, can we place an Excel file in a shared location and use it to develop a report and refresh it in regular intervals? What the interviewer is trying to ask is to see if you've had the experience of doing this. So let's say if you had the data source, an Excel file, and if you had to place it in a shared location, could you actually use that right from there directly to create a report and then, refresh it as and when you require? The answer to this is yes. Tableau is an amazing tool. It's very powerful to use, and yes, it can be done in a very simple way as well. But then, if you have a requirement for better performance, right, it is always vital to extract it, bring it to your machine, use it locally, and then work with it. But then, if your criteria doesn't really have to do much with having the best performance possible, then yes, it is possible to work with a shared location file and to develop a report and later update it as and when you require as well. Now, moving to the 16th question, it states, what is the difference between a heat map and a tree map in Tableau? Well, guys, a heat map is one of the things that you really have to know, and I'm sure you guys would have used a tree map or even a heat map for that particular instance in your journey of learning Tableau as well. So a heat map is nothing but a very simple way where you can categorize the data in that particular data set by making use of variety options of, let's say, sizing, or let's say even by making use of a variety of color as well. So why do we do this is to make sure we differentiate it from one entity to the other, right? So you can map and check all of the orange color looking entities on your screen right now. You can try to differentiate and compare all of the black colored entities. So you can try to compare all of the black colored entries to another colored entry as well, right? So using colors and sizes is an amazing way, and it can be done using a heat map. But then now when you're talking about a tree map is far more powerful than a heat map, because here we're trying to have a hierarchy. So here we're trying to have a structure which is very similar to a tree data structure, and here we're trying to, so not only are we trying to visualize a part of the relationship here, what we're trying to do actually is in a very simple way denote the entire relationship that exists between entries for our particular workbook as well. So as you can see on your screen, you have the states of United States. So you have all the state names of the United States of America, and you can map it based on color as well. You can map it based on size, and eventually you have a hierarchical tree structure through which you have mapped it, and the node structure goes on and on, very similar to a tree structure. Now moving on to the 17th question, it states, what is balanced access? Well, in a balanced axis, what happens is that there are multiple measures that are actually shown on a single axis, and all of the marks that are shown, right, it's all done in a single pane as well. So to do this, all you have to do is you have to first drag a dimension into a column, and after you have dragged the dimension, all you have to do is drag the first measure and drag the second measure, but this time not to a different axis but then to an existing axis, right? So you can see the simple difference between the second and the third point, and this is what that makes a blended axis what it is. So dragging a dimension, dragging the first measure into the column, and dragging the second measure onto the existing axis rather than a new one. So this is all about blended axis. Now when you think about the 18th question, here is another very fun question which again is asked a lot. So what makes Tableau stand out from all of the other tools, right? So whenever we talk about business intelligence, whenever we talk about all of these tools, they are fantastic to use. I'm sure all of the developers who have went into creating all of these tools have taken a lot of time, pain and effort to make it very easy for us to use, right? So thinking about that, all of the other BI tools are extremely pricey and can get out of hand if you're a small company. But then what Tableau does, that's very different from most of the other people, is that they have a free offering, right? So Tableau Public is free and it has an academic distribution in case if you're a college student and you want to learn and work with Tableau as well. So having this option to use it for free definitely is a standout point. And then when you think about how well recognized Tableau is, all of the big firms make use of a business intelligence tool in one way or another, right? Right from the startups to all the trillion-dollar businesses out there. Tableau, in fact, is also well recognized by very big firms such as Forrester Research, and it's considered to be one of the most easy to use product as of now, and one of the most agile products available as well. So it's not only just this, right? See, there are other BI tools which can do a lot of things more, in a substantial way than what Tableau can do. Tableau is just a data visualization tool, but then you can have and do a lot of things. But then you can have a lot of other tools which have a complete technology stack that they bring along as well, right? So considering that, you will have to make use of these other products along with Tableau. Let's say if you have enterprise grade data to perform ETL, maintenance, data storage, and all of that as well. So in that regard, definitely it is one of the vital points to mention of why Tableau stands out the way it does. Moving on to the 19th question, it states, how do we do data testing in Tableau? This is a tricky question, and I've put in a lot of tricky questions for this particular presentation as well. So make sure you pay attention throughout. Now, how can we do data testing in Tableau, right? When you think about it, data testing is not possible in Tableau because Tableau is a data visualization tool and it is not a testing tool such as Selenium or something. So make sure to answer it and do not be confused. The interviewer may be trying to see if you get confused with concepts such as this. So it's a very straightforward no. Tableau is used for data visualization. Tableau cannot perform data testing, but of course it is one of the best tools out there for data visualization today, especially when you have data which is already pre-processed or data which is already structured, and you can work with it easily as well. But still, it doesn't add a lot of value in terms of data testing as well. Now with this, coming to the 20th question, it states, can you get values from two different sources as a single input into our parameter? The answer is no. Tableau currently actually does not support multi-valued parameter, right? So, there's actually a technique which is called as the dynamic parameter with a blend technique that can be used to highlight every single value out there. But then you cannot make use of multiple values because this is how Tableau is built and this is how Tableau is, worked on. And one very important concept that you should know whenever you're answering this question is that the parameters in Tableau, right, they are not dynamic. So you literally cannot start filtering stuff at the runtime as well. So this is something which you should talk about along with the technique when you ask this particular question. So the answer is no. Currently Tableau does not support multi-valued parameters, but then of course down the line with a lot of updates, then it definitely is something that we all are waiting and in anticipation for as well. Now moving on to the 21st question, it states, how do we use parameters in Tableau? So you can use parameters with the following entities, right? You can use parameters, map them with filters. You have parameters across calculated fields, across actions. You have measure swaps, you have changing views, and you have auto updates as well, right? So make sure to at least mention 3 or 4, but then it really adds value if you can mention 4, 5, or in fact all of these as well. So using parameters in Tableau is definitely a core concept and you're supposed to know it in and out at this point of time. So it always adds values to talk about where parameters are used and in fact how parameters are used as well. Now moving to the 22nd question, it states, what is the use of the new custom SQL query in Tableau? Well, one thing you have to know about is that the custom SQL query, right, it's a query that is written after you've connected to the data and you want to pull the data to have a structured view of it. Now, to give you an example, think about having 50 columns in a particular table, but then we do not require 50. We only want 10, 20, or 30 of it. So instead of taking all the 50 columns and then working with it individually, what we can try to do is we can write an SQL query that has the ability to filter out and just give us the 10 columns that we want, and then work with it later and create a structured view based upon that. So why do we even have to do this? One, you want 10 out of 50, you're getting that straightforward. Number two, when you think about computation power, the performance will go up to an exponential extent, because this is a very simple example that we're talking about. In an actual production environment, this will not be the case. So the performance hit in case when you want 10 but you still have to pull in 50 is avoided. If you want 10 out of 50, you can have 10 out of 50, guys. That's a very simple example. Make sure to state it with the example as well. Now, moving on to the 23rd question, it states, what are the differences between Tableau and other traditional BI tools, right? One thing you already know about Tableau if you're here is that it is one of the most easiest tools to use. It's best in its class. It has a free offering, and in fact it provides very good visual analytics capabilities as well. So whenever you think about data foundation concepts, here is where Tableau has it a little slow. It really doesn't help with plumbing, so you will have to make use of an SQL server alongside Tableau to have the complete package of using it. And of course, Tableau licenses can get relatively expensive if you're looking to scale up your organization and scale up your data quickly as well. But then traditional BI tools can do it all, but then it might have a significant cost upfront, and then with a lot of parameters, right? So think about higher consultations, you have hardware changes, you have to have good software there as well. So all of these will cost money, and this will come up to you as soon as you get started itself. So that is one of the biggest differences. And then when you think about all the big vendors out there, right? So if you have to check about reasonable value for money, and if you have to check about what best you can get for the money that you've spent, someone like Microsoft is the person who can do it to the best of their capabilities, right? So they're a huge organization. And then when you think about open source vendors, there's Jaspersoft, there's Pentaho, and there's a lot of other tools that you can make use of as well. But then this does not have an enough talent pool as of yet. This does not have the enough amount of traction that is required for developers to kick in full time to build Pentaho and Jaspersoft into an amazing tool that can directly compete with Microsoft's offerings as well. So think about Tableau, think about Power BI, think about tools like Pentaho, Jaspersoft, and you will have a clear understanding of where the basic differences lie as well. Now, so moving on to the 24th question, it states, what are the similarities and differences that lie in between a tool like Tableau and a tool like Palantir? Well, one of the things you really have to understand is that Palantir and Tableau do things very, very differently, right? So Palantir is known for its ability to be a security tool in terms of handling problems such as fraud detection, handling the payments, and all of that, right? So the customers, or let's say the investors in Palantir, are people such as PayPal, the Central Intelligence Agency, and a lot of others. And on the other end, you already know that Tableau is a visualization player. It has its roots very strong into the Stanford University research as well, right? So one thing it'll always add value is that you talk about new points, right? So think about VQL or VisQL. So VisQL is basically the visual query language that will allow users to build any sort of visualizations that require on already existing data warehouses and spreadsheets, right? So Tableau's support for this is definitely a point that you can mention whenever you asked to talk about Tableau as well. So here is another point to your arsenal of Tableau knowledge. Moving on to the 25th question, it states how to create cascading filters without making use of a context filter. Well, it's very simple. All you have to do is think about a situation, right? So let's say we have two filters, filter 1 and filter 2. And based on filter 1, we have to make use of filter 2 on that particular data. And now when you have to say, and now let's think of it as filter 1 being country and filter 2 being it as states, right? So if you choose the country as India, then filter 2 must display filter 2 must display only the states of India and not states of every single country out there, right? So this is how you can cascade filters without having to make use of a context filter. Now to do this, right? So for the filter 2, make sure you select the option wherever the value So make sure you select option of only relevant values for the filter for the second. So make sure you select the option for only relevant values for the second filter, to actually go on to do a thing like this. It's a pretty simple thing and it can be easily done by making use of Tableau. Moving on to the next question, it states, is Tableau good for a strategic acquisition? Well, of course, Tableau is an amazing tool for strategic acquisition as it provides amazing data insights, and you can do a lot more with Tableau with the approach of you having to put in a lot less effort as well, right? So, in terms of acquisition, what it does, it will help you plan properly, set up a pipeline, understand what anomalies are lying there, and try to fix them as well. You can improvise your entire process and have it better as well. So it'll give you a lot of insights which might skip your eye if you're directly looking at the data with your naked eye as well. So in terms of strategic acquisition, it's a big yes for sure. Coming to the 27th question, it states how to display the top 5 and the last 5 sales in the same view. So to do this in a very simple way, there are two ways. Make sure to mention both as well. One, of course, you can apply filters where you can do it in a straight way, and number two, you have calculated fields where you can achieve the same effect of, let's say, top 5 sales and the last 5 sales in the same view without you having to do much as well. So make sure to mention the both ways. Now, question number 28 states, let's say, suppose without having to use a line or a bar chart, I want to design a view to show the region-wise profit of sales. How can I go on to do this? So what we're trying to do here is, we want to show the region-wise profit and sales without having to use a line chart. So how would you suggest that we do it? If you do have a computer or a laptop in front of you right now, it will always add a lot of value if you can show all of these practically with any of the previous projects or data sets that you might have worked with. But then take a simple approach to verbally explain it first. See, for example, you can generate a map by making use of cities, and later, you can just drag the profit and all of the sales to that particular details, and then, add the state as a quick filter and work with it as well. So you can use a very simple approach, and to explain it can be done in a very simple and a concise way, but then it'll add value if you can show it practically, right? So pull out a data set, and tell the interviewer that you want to show how this can be done practically as well. So that will impress them definitely. Now, moving on to the 29th question, it says design a view in a map such that if a user selects any state, the profit and the sales in the cities under that state would show up. So if someone selects any state, right, so whatever the profit is there in that particular state and whatever sales in the cities of that state, that should show up. How can this be done? This can be done if you have state, city, sales and profit as our fields in our data, right? So we require these data. Make sure to mention that first. Without the data, you cannot mention it, right? And to have this particular effect, so all you have to do is click on the state field, drag the city out into our marks card, which comes under the state field, of course, and then drag the sales into size, drag the profit and drop into the color, click on the size legend. You can, increase it to whatever size that you require, say for example 75%, and then click on the state field and show quick filter. And after you have done that, all you have to do is you have to select any of the states and see if it is working or not. So if you have done steps from 1 to 6 right, then of course with the 7th step you will have the view which indicates the number of sales, and the color will directly indicate the profit values as well. So it's a simple thing with 6 simple steps. So this is the hardly 30-second task, but then at the end of the day, the insight you can drive out of this task is huge. So make sure you mention the advantage, how to do it, and what we require to do it as well. Now moving on to the 30th question, it states how to add custom color in Tableau. Custom color can be added in Tableau by making use of preferences.tps. So go to my documents, go to my table repository, and you will find a file called as preferences.tps. And here, you can add a color code. You can add the hash code, which is also called as the custom color code, wherein you can add wherein you can add it and make use of it directly as well. But then one thing you have to note is that, let's say in Tableau version 9.0 and above, right, you have a direct color picker option, which is basically giving you a user interface to do the exact same thing. So all you have to do is you can click on the color that you require, hit OK, and you're done with it in a very simple way as well. So coming on to the 31st question, it states how can we combine a database and the flat file data in Tableau Desktop? How can we do this? It's again not a very difficult concept. All you have to do is you have to connect the data twice, because for the first time when you're connecting, it's for the database tables, and the second time you're connecting, it'll be for the flat file data. And then go to data, edit relationships, and give a join condition based on all of the columns that you have to find in common from our database file to the actual flat file data as well. So it's simple, connect it twice, once for database, once for flat file data. Go to data, edit relationships, put a join condition on the columns for the database tables to the flat file as well. And as soon as you're done with this, you have combined a database and a flat file in a very simple way in Tableau Desktop. Now, moving to the 30-second question, it states, what does Tableau do? Well, here's another tricky question, right? So Tableau can do a lot of things. Use the insights from all the 31 questions that you have come across until now to answer it. But then one important thing you really have to state is that Tableau is one of these tools which has a goal to make sure that it will help people see and understand data better, in a very aesthetic way and in a very simple way as well. So Tableau brings about a data analytics solution, it brings about a business intelligence solution and a data visualization solution. It puts it right in the hands of common people, right? So what it does is you will have a broad population of business users who can actually work with their data, ask questions on their data, understand the performance of their data, and eventually solve a lot of problems using this as well. So this question you can talk about 20-25 minutes and still you can have a lot of points that you can talk about Tableau as well. But then make sure to mention all the primary concepts. So make sure to mention all the primary points and how it adds value to the people, right? So what we're trying to do with Tableau is solve a problem. So make sure you talk about what the problem is and how Tableau aims to solve it. Moving to the 33rd question, it states, what is Tableau Public? Tableau Public is a free tool. It's a free service that lets anyone anywhere in the world publish an interactive data set onto the website, right? So once you're connected to the internet, you can do a lot of things. Once you have installed Tableau Public, I still say the same thing. You can do a lot of things. Now, whenever you think about making use of Tableau Public, make sure to explicitly mention that you really do not require any programming skills out here, right? So there's a lot of people, a lot of learners who keep asking us in case if they require a programming head start to start with Tableau. The answer is no, you really do not require anything, right? So with Tableau Desktop, anywhere anyone on the web can interact with the data, see the data, work with it, download it, create their own visualization, edit the visualization, and in fact, you can also check out what everyone else are doing as well. So you can do that to get ideas. You can do that to see how aesthetically pleasing things can get if something is done in a neat way when you're making use of Tableau as well. So it adds a lot of value, and make sure to mention all of that. Now with question number 34, we're talking about data modeling. So what is data modeling? One thing you have to know about data modeling is that it is the basic analysis that we perform of all of the data objects that we're using in our context right now. So whenever we're trying to model data, we're trying to find relationships, we're trying to associate each of these data objects, comparing them one with the other to see how we can base any assumption on them, or how we can apply certain steps on them to see how we can drive insight, right? So it's a pretty simple thing. To analyze the data objects, you really require context, you really require certain relationships to work with, and data modeling is a way where we go on to show all of these relationships as well. It is as simple as that. Moving to question number 35, it states, what is your daily process with Tableau? What is your daily work process with Tableau? This is another tricky question, and this is completely based on your way to work with Tableau. There is no one right answer for this, and start your answer with this, right? It completely depends on what projects you're working with Tableau, the complexity of the project, the client requirement, the performance requirements, the complexity of the actual time involved in doing the project, and a lot of other things. But then of course you can have a very simple data work process that I've mentioned on the screen. It's an example. So what usually happens whenever you're working with with Tableau is that first you will get an understanding of what the requirements are, and after you understood what the requirements are, you're going to start pulling in all the required data. You're going to create a storyboard based upon that, and eventually apply and create visualizations in Tableau. And the last step, of course, you're going to present it to a client for review, right? So use this as a foundation, and you can talk about your previous experiences on this as well. So use all of these as foundational points, add more value to them based on the experience level that you have, and convey it to the interviewer in a clean and a concise way. Then coming to the next question, it states, how does Tableau work with big data sets or huge data sets? To start off the answer to this question, make sure to state this. Tableau's performance varies a lot depending on the performance of source data as well. So depending on how how clean the data is, how structured it is, or a lot of other parameters that is present in the data set as well. So your performance is having a direct correlation with the performance of the data source itself. So what happens is that the main impact on performance comes whenever we talk about the time that takes to execute a query, right? So if your data source is taking an ample amount of time to execute a query, then what does Tableau have to do? Well, Tableau has to sit and wait until your data source can give you this data, right? So that means you are waiting, Tableau is waiting, and your data source is taking some time. So this really doesn't add a lot of value. So you can state all of these to say how Tableau can deal with huge data sets as well. You can do it very well, of course, but then it takes certain time to go on to do it. Now, coming to the next question, it states, how will you publish and schedule a workbook in Tableau server? It's a very simple task. All you have to do is create a schedule for a particular time, whatever time that is you require, and or let's say even the client has provided you a time. All you have to do is create an extract for the data source, pull all the data, and eventually publish it on the workbook in the server as well. So creating extract is the actual important step that you have to concentrate on, as whenever we talk about publishing a workbook, especially while scheduling it, right? So there's a lot of authentication methodologies that you have to check as well. So before you can publish it, there is actually an explicit option that states scheduling and authentication. You can click on that, you can select the schedule from whenever you have to publish it, and then directly hit publish. So all the data sources and all of the assignments that have to be published will run through the schedule and be done automatically without you having to put a lot of time, or let's say punching back in whenever you have the scheduled time and then looking at something there as well. So you really don't have to do any of that. This entire process is automated. It will get refreshed on a regular basis, and you can work with it automatically without having to put much effort as it is. Now, coming on to the 38th question, it states, distinguish between parameters and filters. Well, parameters, you already have to know this. It is the dynamic values that will replace all of the constant values whenever we talk about any calculations, right? And parameters, if used right, can be used as filters itself. But what are filters? Filters are used to restrict the data based upon conditions that we have, and where have we mentioned all of these conditions? We have mentioned it in the filters shelf, right? So it's a very simple thing. Talk about what filters are, talk about what parameters are, and make sure to state that you can also use parameters as filters if required as well. So that point is a highlight, and it will add a lot of value if you can state that directly too. And now coming on to the 39th question, it states, how to view an SQL generated query in Tableau Desktop or by Tableau Desktop. So all of the queries that get generated actually go into a log file, right? So there's the Tableau Desktop log file. So there's the Tableau Desktop log file that you can get into as soon as you go into C Drive, Users, My Documents, My Tableau repository.
Just a quick info, guys. Test your knowledge of Tableau by answering this question. Which of the following is not a trend line model? A. Linear trend line. B. Exponential trend line. C. Binomial trend line. D. Logarithmic trend line. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Where all of your data is mentioned, all of the detailed information about the query. So make sure to mention all of these as well. Once you have to have a live connection with the data source, you have to check all of the files. If you're making use of an extract, there's another file, and the actual file which will contain all of the queries as well. Now moving on to the 40th question, it states, what is page shelf? Page shelf is a very simple concept, but do not be fooled by how simple it is, because it's a very powerful part of Tableau. It's a foundational concept in Tableau where you can actually control the display of the output and any result that gets printed on the output as well. So page shelf acts as a primary barrier, acts as a primary visualization criteria where you can work with a lot of things to make sure that you can control a lot of parameters when displaying or when controlling the output as well. So in that regard, page shelf adds a lot of value. Now, coming to the 41st question, we have another different question. So moving on to the 41st question, we have a question that states, what are the major differences in between Tableau 7 and Tableau 8? Now guys, you really have to know this question. This is another trick question that can be asked to you to see how proficient you are with Tableau and all of the years of experience that you say you bring with, right? This is a way to verify that as well. So, with respect to Tableau 8, you have a lot of new things that got implemented. Think about tree maps, think about bubble charts, think about whisker plots, box plots, and all of that, right? So new features are amazing. One very important thing you have to talk about is the introduction of the R script and how you can directly copy the worksheet from one workbook into another one without having to redo it or without having to put in a lot of effort there as well. So not only this question, whenever you asked about any question pertaining to older version of Tableaus, in case if you have used it, I'm sure you'll be able to answer those questions. But then in case if you haven't used it, make sure to explicitly mention saying that you haven't had a lot of experience using that as well. I mean, of course, it's going to be 90% same with one version to the other, but then it always adds value if you know it exactly as well. So make sure to mention that. Moving on to question number 42, it states how to create filled maps. So to create a filled map, right, let's take an example. Whenever we talk about map view, right, so all you have to do is click on the geographical field, click on anything such as zip code, click on area code, state, or any of these, and select the filled map mark type, right? And select the filled map mark type. So with this, what you can do is the automatic mark type that will show all of the types of views as circles over the map, right? So once it starts showing it as circles over the map, then you can have the marks card, and from the marks card you can select all the filled map to eventually color your geographical areas as per requirement as well. And to color all of that, it's a very simple thing, and I'm sure you already know this. And step number 3 is very simple. Drag a field to the color shelf, define what locations need to be colored, how these locations need to be colored, and just drag a field to the color shelf and you can be done with that. And of course, you can explain this probably in under a minute to the interviewer, but then if you have your laptop, I would really suggest you take your laptops to the interviewers in case if that's allowed, and then make sure to show this practically to the interviewer as well, because all of these concepts you can explain them easily and in a very straightforward way verbally, but then what will add value is if you can actually show them practically as well. Now moving on to the 43rd question, it states, does a parameter have its own drop down list? In Tableau, yes, a parameter has its own drop down list, and whatever entries that you make in the parameter while actually creating, right, so it can be directly viewed as items in the drop down list. So the answer is simple, the answer is straightforward. It's a yes, it's possible to have a drop down list for a parameter. Moving on to the 44th question, it states, how is data blending different from data joining? Again, this is a question which is asked a lot of times in this interview, just like all of these other questions that you've been going across right now. So make sure to concentrate. Now, when we talk about data blending, right, so data blending, as the name suggests, in fact is the process where we combine the data from two different sources or more than two different sources as well. So your two different sources can be a Microsoft Excel file, you can have another set of data on an SQL server, Oracle server, a cloud computing platform, or a server which is on premises, a remote server which is in the client's location, and a lot of other things to bring these data together to use in Tableau, right? That's what data blending is. And data joining, on the other hand, is a very simple concept. It's a straightforward concept, just like data blending, but it's very different. What we're trying to do here is we're trying to combine the data from two or more tables and sheets from the same data source. Data blending spoke about two different data sources and bringing it together. Data joining is all about talking about two different sheets or tables that are present in the same data source, guys. That is the basic difference. In joining, we talk about same data source and everything that is present in that data source, and in blending, we talk about more than one source. So make sure to explicitly explicitly mention that without fail. And now, question number 45, it says, is it possible to store a huge amount of data in the memory engine by making use of Tableau? Is it possible to store a huge amount of data? If yes, how can we do it? So if an interviewer asks you a question like this, right, the second part of the question might give you a clue to the first part in case if you're unprepared as well. So he or she can state, if yes, how is it possible, right? So the actual answer to this question, now coming to that, is yes, it is possible to store a large amount of data in the memory engine by making use of Tableau. But then it is not as simple as that, because there is no one straight answer to this, because you can store massive amounts of data based upon the Tableau server implementation. You can have a lot of configurations for that, right? You can have 8 core configurations, you can have 16 core configurations, and you can have more than that as well. So depending on how your Tableau server is configured and built, based on that you can store it. So it's a relative answer to the relative question. And not only if just hyper is used or not, let's say there are many other factors that will affect, such as the server memory can also have an exponential effect in how much data that you can eventually store and directly use in a rapid fashion for the memory engine, and a lot of things as well. So make sure to talk about the server memory and make sure to talk about the server configuration in general as well. Now moving on to the 46th question, it states, what is the difference between rank and index in Tableau? So whenever we talk about rank and index, one commonality is that both of these come under table calculations in Tableau, guys. So index is the actual entity that will deal with the record's physical location, and think about incremental numbers, for example. So as soon as incremental numbers are assigned according to the record's physical order, right? So as soon as this order is particularly met, and how is it met? By making use of index. Now, whenever you think about rank, right? So rank usually deals with the record's value. Whatever highest value is there gets the highest rank. Whatever lowest value is there gets the lowest rank. So it's a pretty simple and a straightforward business in terms of rank and index as well. Index deals with its position, record deals with its values, right? So if you have used any other programming language as well, you will understand the usage of index. And rank, as the name suggests, is a numerical value that denotes how it maps in the real world as well. Now with that, coming to the 47th question, here is another very simple question, but then if you do not know how to answer this, it can get a little difficult as well. So to answer this question that states, suppose my license expires today, can my users be able to view the dashboards or workbooks that I published in the server earlier? Well, you really have to know the answer to this question, guys. If your license expires today, right? If your server license expires today, the username of the server will change. It'll go from the name that you have put in, and it'll say unlicensed user. It means that whoever created the dashboard and published it into the server cannot access it anymore. But then everyone else can still do it. So the site admin, what he can do is he can change the ownership to another person, and so at this time, what the site admin can do is the site admin can change ownership to another person. This way, we are trying to make sure that if we have and if we are making use of extracts, right, it doesn't fail. But if you do not change ownerships, you really cannot extract the data anymore if it's unlicensed. So yes, if the license expired today, you cannot have access to it, but then everyone else can. Moving on to the 48th question, it states, what is the difference between the quick filter and the normal filter in Tableau? Well, quick filter is an entity that's used to filter options and to select options in a very rapid manner. And a normal filter is something with which you can limit the options from the list. You can calculate some conditions, work with the data, limit it based upon a value, limit it based upon an index, or limit it based upon a general field in a column as well. So quick filter is used to view the filtering options, while normal filter is actually used to view a lot more compared to that as well. And hence the name quick filter and normal filter in Tableau. So make sure to mention this basic difference in a clear way to the interviewer. Moving on to the 49th question, it states, what is your plan after joining for the Tableau developer role, or let's say any other Tableau role that you might be joining for as well? So to answer this question, make sure that you keep it concise, you keep it clear, and do not talk about it for 20 minutes. So you can start answering on how you have actually worked with Tableau in your previous years. It may be your learning, it may be your it may be your use in a production environment and whatnot. And think about talking about a plan where you first understand the company structure that you're interviewing for, and how well you can have an impact in terms of Tableau will only come if you can understand how well the data is implemented there, right? How the data workflow is set up, how the infrastructure is set up, and all of that. So talk about you first having the ability to easily grasp and understand new things, and then talk about how you can better it or improvise something in the coming days, with further iterations as well. It's not only just that, right? So it's all about you fitting into a role, being a team player, the ability to talk to multiple teams, and the ability to solve the problem at hand. And if you can do it very efficiently as a Tableau developer, then you open up your resume not only to just one or two interviewers, but then even to the top companies across the globe as well. So this is a very tricky question. This totally depends on your potential, your capability, but guys, it is extremely vital, as I've highlighted in the answer, that you have to keep it concise and you have to talk about how you will fit in there, right? So you really cannot barge in and say, I'm going to start changing everything up. Yes, you might have to start changing everything up only after you have understood it and you've seen a problem and you have a thorough way of solving that with your solution, which is supposedly better as well. So make sure to mention all of that. Now, coming to the last question, it states, have you earned any sort of certification to improve your learning and implementation process? Well, guys, if you've made it to this question, congratulations. These 50 questions will add a lot of value to your Tableau interview, and I'm sure you can use this as a guide to ace all of your interviews as well. But then this question is very important. If you have ever used a certification program to learn and gain knowledge, you will understand that it will portray a lot of things, right? So you can gain a lot of knowledge in a clear way, in a concise way, from professionals across the globe, and you can make use of real world projects to concrete your learning, and you can do a lot more for a learner. But now let's talk about what it does whenever you're in an interview, right? So if you have certifications, let's say you are a certified Tableau developer, as soon as you step into this Tableau interview and you state that you have a certification and you talk about it, one thing it will show to the interviewer is that you want your career to be built around here, right? So because you would have spent a considerable amount of time, you would have spent a considerable amount of effort to go on to do something in this field as well. So in that aspect, you definitely will show a lot of aspiration there too. And another thing where you're showing strong aspiration is, let's say if you have jumped from another different background, you might be coming from a management background, you might be a Python developer who wants to become a Tableau developer now, and everything else too. So it'll show that you have the ability to grasp novel things, new things, and understand how they work. And you being serious about it also shows how your certification has added value to your life as well. And of course, since you'll be learning a new thing, in case if it was new to you, not taught in college or any of that, it will show that you are an effective learner and you have the capabilities to be taught. So being teachable is everything in today's world, and I'm sure most of you already know that as well. One important thing you have to talk about is, of course, talk about the certifications, talk about what you learned through that certifications. But then here's a secret, guys. Here's a secret tip. Talk about how you used it rather than talking a lot about what it is, because there's a good chance they already know. So there's a good chance that the interviewer might know all the certifications that already exist with Tableau, but then he or she will absolutely have no clue what you have implemented, right? So talk about your projects, talk about your ideas, talk about the new things that you have tried, talk about your practical implementations that you have done after your learning. This is where you try to understand, and this is where you actually impress the interviewer as well, guys. So I hope these 50 questions add a lot of value to your interviewers, and I take this opportunity to wish you all the best for all the upcoming interviews as well. As always, I'll see you on the next one.
Just a quick info, guys. Intellipaat provides Business Intelligence Master's Program in partnership with Microsoft, the course link of which is given in the description below.